Now there also are two other files in that app directory, which I haven't covered yet, and one is the globals CSS file. Now in there, I set up some CSS styles for you, and this file is being imported into the layout.js file so that it's essentially available on every page that's being loaded. This is how you can import CSS files in Next.js. It's an approach that also works in most vanilla React projects, and this will then simply ensure that these styles are made available on every loaded page. Besides that, we also have an icon PNG file here, and that's another special file name actually. If you add an image called icon, it will be used as a favicon by Next.js. Because you might have noticed that in the layout.js file, we did not set up anything regarding a favicon, so that little icon that shows up in the tab here, for example, and yet we have one here if you take a close look. And that's the case because I added this icon PNG file, which uses this special icon name, and if you add an image called icon directly in the app folder, as I'm doing it here, this will be used as a favicon. So as you can tell by now, the app folder is very important. In there, you define your routes by adding folders, and you have some reserved file names like page.js, icon.png, or layout.js, which then simply unlock different features, you could say. And for example, a route layout is needed just as you need page.js files to really set up a route. But you're not limited to these special files in Next.js. We can, for example, still also add regular React components, which are not treated as pages. For that, let's say that we want to put this image and this header into a separate component, so that we cut it from here and we instead add it to a component. We could do that by adding a new JavaScript file anywhere in that project, for example, next to the page.js file, and we could name it header.js. By the way, you can also use JSX as an extension, also for those pages, if you prefer that, but here I'll stick to the default, which was JS in this next project. But now I added this file here. You could also name this header with an uppercase starting character, but here, since all these other default and important Next.js file names use lowercase names, I'll stick to a lowercase name for my component file here as well. But now in here, we can export a function, a component function called header, where we return a fragment, and then in there, this image next to the h1 element. So that's now again a standard React component. But now, it's actually a component that's not automatically picked up or handled by Next.js in any way. It's not rendered as a layout or as a page. Instead, it's currently ignored, because header is now not some special file name. We can, of course, import it now. We can import it here into page.js, like this. And then here we can output it, just as you learned it with vanilla React. Because we are still working with React here. We are still working with components and JSX, just enhanced with some extra features. With that, if you save that and you reload, you see the same content as before, but now with that custom component being used. And you could really store this component anywhere. We could also add a components folder here inside of the app folder and move header.js in there. In that case, we just have to update the import and make sure that we import header from ./components/header. But with that being done, everything still works. Here you also see the importance of page.js. Because now that I added this components folder here, you could think that we now should be able to visit /components. But we would get a 404 error because this file in there is ignored by Next.js when it comes to routing, and we simply got no page.js file in here. So that's how the Next app router works. Now, personally, I prefer to store my components outside of that app folder, but you can absolutely store them in there. And indeed, in the official Next.js documentation, you can find an entire article that discusses different ways of structuring your Next.js projects and storing components. Attached to this lecture, you find a link to this article, and you can simply pick the structure you personally like the most. I prefer to have my components outside of the app folder so that the app folder is just used for routing and routing related tasks. Now with that components folder moved out of header.js, you of course also again must update your import here. And here you can take advantage of another feature that's typically unlocked in Next.js projects, where you can use an @ symbol in your import paths to refer to the root project. So the root project outside of the app folder. It's this JS config file that configures this alias, and that's simply a little convenience feature which can simplify your import paths. Because now I can simply refer to the root project folder with @ and then there dive into the components folder and target the header.js file. That's how we can use this feature. And with all that, again, we got the same content as before if we visit the starting page, but now with that outsourced components folder. So now that we have a solid understanding of how we can generally set up routes and also work with regular components, before we dive into that Meals app, there's just one other route type I also want to explore together with you. Because let's say we also want to have a blog route in here. So of course we could add a blog folder in the app directory and add a page.js file in there. But let's then say we also want to have different blog posts. So that nested in that blog folder, we have a post 1 folder, a post 2 folder, and so on. And of course, this then doesn't lead anywhere, because this would mean that we need to add a new folder whenever a new blog post is added to the database or wherever we're storing them. And that is not scalable and not maintainable. So what we need here for these posts is a so-called dynamic route, a route which we only define once, but which is then capable of rendering different pages for different blog posts. And in Next.js, we can create such a dynamic route by adding a nested folder where we use square brackets. This is a special syntax supported by Next.js, where you then put any placeholder, any identifier of your choice between those square brackets. For example, slug or whatever you want. And this placeholder will become important later. Then we again need a page.js file because, of course, we want to render some content. And if you want to build a new page that should be visitable, you need a page.js file. Now let's start with the page.js file directly in the blog folder though. There we could of course export a component called blog page, where we then return this main element maybe, and say the blog. And then here I want to have, let's say, 2 paragraphs with links to different blog posts. So I'll use that link component and import that from next/link. And then here, let's say, we want to have one blog post under blog/post-1, like this. But then we also want to have a second one that leads to post 2 here in that path. So almost the same path, but different segments here at the end. Now we need to go to that page.js file in that slug folder, in that square bracket slug folder, and here, of course, we also should export a component function, the blog post page, for example. And there we can again return the main element and say blog posts, and we'll make this more dynamic later. With that, if we save everything and you go back, you will see that if you visit /blog, you have these 2 links, and if you click them, indeed you're taken to that blog post page. And that works for both links. And as you can tell, if you take a look at this URL, it changes. We have post-2 here as a segment after /blog and post-1 for that other link. But it's the same page.js file becoming active for different segment values, so for different path segment values. And that is what is achieved with that dynamic route syntax here. This square bracket thing here simply tells Next.js that we want to have some path segment after blog in this case, but that we don't know the exact value of the segment yet. And it's then this placeholder, this identifier, slug, that will give us access to the concrete value that we do get when that route is loaded. Because Next.js actually passes a props object to all those page components. And all these page components get one special prop, which you can pull out with help of destructuring. And that's a parents prop, which again is set by Next.js. You don't have to pass it manually because you're not rendering these components manually. Instead, Next.js is doing that for you, and it is setting this prop for you. And what's inside of this parents prop? Well, this will be an object where every placeholder you had in such a dynamic route here will be a key, and the value stored under that key will be the concrete value encoded in the URL, so post-1, for example. And you can see that if you output it by accessing parents.slug here, in this case, in this page here. If you do that, you see post 1 here. If I enter anything-else here, you see anything-else here. And this is a great feature because this would now allow you to, for example, reach out to a database where your blog posts might be stored and fetch the blog post with that slug, so that you can then show its content on this page instead. And that's how you can set up such dynamic routes. Now, Next.js has way more to offer. You can also set up custom not found pages, deal with errors, add more pages, fetch data, change data, and we'll do all that, but not in this demo project, instead by working on that Meals app I showed you before. So I'm now in a brand new project, which you find attached both as a local and a Code Sandbox version. And this is this Foodies app, this Meals app project on which we're going to work for the rest of this section. Now, of course, the project we got here is pretty similar to what we have before, but I removed all those pages we created. We got an extra assets folder with some images that we need for this application we're building, so that's important. In addition, the public folder also contains some images that will be used. And I also, of course, have updated styles, an updated favicon, and then also an updated layout and page.js file. And especially the layout.js file is also interesting because it's not an empty shell as we had it before. Instead, we have a layout here where we still set up that general HTML skeleton, but you then also find an SVG graphic in there, which is simply there for aesthetic reasons and which will be rendered behind the header of this website in the end. So that's the project I prepared. Again, as mentioned, you'll find it attached, and that's the project we'll work on now. And here I now got a little exercise for you, because we did already learn how we can generally set up routes in Next.js applications. We learned that over the last couple of lectures. And therefore my exercise for you is to create 3 new routes in this new project that I shared with you. To be precise, I want you to create a meals route, a /meals/share route, so a nested route in the meals route with an extra path of share, and a community route. And for this exercise, it's then enough if every route renders a super simple React component that maybe just outputs some title. So the page content of all these routes is not important right now. We'll work on that together over the next lectures. But you should set up those routes, and if you feel like it, you also can add some links to some of these pages so that users can navigate between those routes. But that's not all. I then also want you to create an extra 4th route, which also leads to /meals/something, but now that something part should be dynamic. So that in the end, later, we'll have /meals/share, which will be the page that allows us to share meals with the community, and /meals/ and then some dynamic segment, some dynamic slug that will identify a specific meal and that will later allow us to view the details of a selected meal. That's my exercise for you. Create those routes, add some links, but don't worry about styling or the page content. In the next lecture, we're going to set up those routes together, and thereafter, we're going to fill them with some life. So, did you succeed? Let's now create those routes together. And I will start with the meals route. Now for that, we should go to that app folder, because that folder has a special role in Next.js projects, as you learned. And in there, we can set up a new route and a new path segment that can be entered in the URL by simply adding a folder with that intended path segment as a name. So for example, meals, if we want to be able to go to our domain /meals. Now, as I also mentioned before, adding just a folder like this won't do anything though. Instead, you must add a page.js file here to show something on the screen. And then in this page.js file, you should export a component, a React component, a functional component to be precise. In this case, you could name it meals page, though this name here, as I mentioned, doesn't matter. It's totally up to you. But you must export a component. That's important. And then here I'll simply return an h1 element where I say meals page. That's of course just some dummy content, and we're going to replace it with more meaningful content later. But with that added, we got the first route. Now the goal also was to add a nested route in that meals folder, so that we can also visit /meals/share. And for that, we can simply create a nested folder with, again, that path segment that we want to have as a folder name. And again, we need a page.js file in there in order to be able to visit that. And then, of course, export a component function. So here, the share meal page. That sounds like a fitting name. And then I'll return an h1 element where I say share meal. Now with that, we got 2 of those 3 routes you should add, but there also is another route, not nested into the meals folder, but instead a sibling to the meals folder. And that is the community route. And again, in here, we add a page.js file and then export our community page component here. And then simply return h1 community. Now with that, we got those 3 routes set up, but I also told you to add some links that allow users to navigate between those routes. And therefore, that's exactly what I'll do here. And I'll start on the home page, actually. There, below this h1 element, I'll add a paragraph that should display a link to the meals page. And for that, as you learned, you should use the link component provided by Next.js. This is a component that renders an anchor element, but that also allows Next.js to gain control of the ongoing navigation and keep you in that single page application. So here, if I want a link that takes me to the meals page, we can use the link component and then simply set the href attribute or the href prop to /meals. And of course, now we can also add extra links now. For example, one that leads to /meals/share, like this. And then I'll add one last link that takes me to the community page by pointing at /community. And of course, these paths, which I'm setting up here, do map to the paths I set up in my folder structure. So /meals goes to this page, meals share goes to this page or this folder, and community goes to this folder. And then, of course, the respective page.js files become active. So that's how that works. And if we now save that, and you then make sure that the development server is up and running, which is the case on CodeSandbox, but which you have to start manually locally. By the way, locally, in order to start it, you also have to run npm install first. And then you should be able to start it. And if you make sure that that's the case, you can visit localhost 3000 or whichever address is showing up for you here when you start that development server. And you should be able to see that starting page. Now, those links here are a bit hard to read. This is, of course, not the final styling. We'll make this app look better throughout this section, but we have these links at least, and we can click them. And if I click the meals link, I'm taken to the meals page, so that works. If I click the share meal link, I'm taken to /meals/share, and that also works. And if I click the community link, I'm unsurprisingly taken to /community and that community page. And with that, we added these 3 routes. Now there also was another task to also create a dynamic route that allows users to go to /meals/some dynamic segment, some identifier of the meal a user wants to view. And you also learned how that can be done. For that, back in that app folder, back in that meals folder, since that page that should be added is nested inside the meals path, it's /meals/some dynamic element. And therefore, inside of that meals folder, we add another subfolder, which is a sibling to the share folder. And we turn that into a dynamic route here by adding square brackets to the folder name. And then between those square brackets, as you learned, you put any identifier of your choice. For example, meal slug. But again, this is up to you. With that added though, you can then add your page.js file. And now this page here will become active whenever the user enters the address /meals/something, which is not shared though. Because Next.js is smart enough to understand that if you're visiting /meals/share, that it's this page that should become active. And not this dynamic page. Even though theoretically share could be treated as a value for this dynamic segment. But Next.js is smart enough to see and understand that there is a more specifically named folder, which therefore has precedence over this dynamic segment. But anything but share, like something or ABC or my-meal, will be treated as a value for this dynamic segment and will lead to the activation of this page.js file. And therefore, with that, here we can export another component function, which could be named meal details page, where I want to output the title here where I say meal details, like this. And with that done, if we now save this, we can also visit /meals/abc or /something. However, as mentioned, if we visit /meals/share, we go to the share meal page. So that works as intended. And that's then this exercise solved. With that, we repeated what we learned, and you got more practice with this file-based router that's provided by Next.js. And we're therefore now ready to finally start working on the contents of those pages and on making this website more useful and beautiful. So let's now start working on this page, and let's start making it look better and make it more useful. And for that, I actually want to start by adding a proper header and navigation and logo to this website. And for that, I'll actually work on that layout.js file. Because the idea behind layouts in Next.js is that they act as wrappers around pages. And you can theoretically also have nested layouts where a subset of pages could also use another more specialized layout. So you're not limited to this one root layout, which we have here in this project. It's worth noting though that if you had a nested layout, so if we had a layout in this meals folder here, then this layout here would indeed only become active for those meals related pages, but it would itself be nested into the root layout. So the root layout will always be active. And I can quickly show this to you by adding a component function to this layout.js file, because layouts like pages are in the end React components. And I'll name this meals layout. And then here I'll return, let's say, a fragment where I'll simply add a paragraph which says meals layout, and which below that paragraph should then output the actual page content. And for that, those layout components can use the special children prop that exists in React. Now you learned that every component can accept and use this prop, and that normally the content that's made available through that prop here will be the content wrapped by those component tags. So if I were using meals layout like this, then this content here between those tags is what would be made available through that children prop. However, in case of layouts and pages, we aren't rendering those components ourselves. We're not using them in JSX code ourselves. Instead, Next.js is using them for us. But Next.js will essentially wrap that layout around all pages or nested layouts that are covered by this layout. And therefore, children will give you access to any nested layouts or pages. And hence, we can output the page content here with children. And that's also what happens in that root layout, which, as mentioned, will still be active even if you have a nested layout. Now, this root layout also accepts this children prop and uses it to output the wrapped content, which again are pages or other layouts, nested layouts like this meals layout. That's how that works. And with that nested layout added, you'll see that on the starting page, we don't see it. We don't see that text meals layout anywhere on the screen on the starting page. But if I go to a meals page, we see it here. And yet the root layout is still active, as you can, for example, tell by this SVG, this brownish SVG, which is still visible here. So that's how layouts work, but here we actually don't need that nested layout, hence I'll delete it. But we will now work on that root layout to add some header that's visible on all pages. Some header that allows us to navigate between those pages. Now to add that header, I'll add a brand new component. We could of course also just add it in here in this layout file, but in order to keep this a bit leaner, I'll add a separate component. And I'll actually also outsource this div here into a separate component thereafter. And therefore, I'll add a new file which should store that component. And we could name it main-header.js. Now, as I also mentioned before, it is up to you where you store those component files. If they don't have any reserved name like page or a layout, Next.js doesn't care. You can add them like this, or inside of a components folder, in the app folder, wherever you want. But I personally prefer to keep them out of the app folder so that the app folder is really only dealing with routing and not with those other components, but that's just a personal preference. There is this entire article in the Next.js documentation that discusses different ways of structuring Next projects. Now here, I'll keep it out of the app folder though, and therefore it's now in this main header.js file where I want to set up this header that should be shared across all pages. And for that in here, I'll export another React component, which I'll name main header. a regular React component as you know and love it. And then there I'll return a header element like this. And in that header, I then want to have a logo and the main navigation of this page. Now that logo should be clickable, and therefore I'll start by adding a link here, using the link component provided by Next.js, so that we can wrap that around the logo to make it clickable. And the idea is that clicking the logo simply takes us back to the starting page, so to this path here. But then the logo should actually be the combination of an image and some text. And therefore we can use that image element, that default image element, and then set the source to a certain image. And I want to set it to an image which I provided as part of the starting project. There I provided this assets folder to you, and that assets folder then has a logo PNG file, which is that logo I want to use. Now the great thing in Next.js projects, like in most React projects, is that you can simply import such an image into your JavaScript files, and you'll then automatically get a path to those images. So here I'll import my logo image from, and then I'll use this alias here to refer to the root directory of my project, this @ symbol, and I'll therefore import that logo from @assets, and then there the logo.png file. And that's then the source of this image, though what's important in Next projects, unlike in many other React projects, is that you can't just assign it like this. Instead, you have to access the src property, because this imported logo in Next projects will be an object where the path to the image is then stored under that src property. With that, I'll also assign an alt text. A plate with food on it sounds fitting for this logo. And that's my image. Now I also want to have some text next to that image, and here the name of this demo app is simply Next Level Food. So that's now my logo. And we could outsource this into a separate component as well, if we wanted to, but here I'll keep it in this main header component. Now that's not everything though. Instead, I also want to have my navigation here. Hence, I'll add a nav element, and in there an unordered list, and in there a list item. And that list item should then contain another link leading to a certain page. To be precise, a link that allows us to browse the meals that have been shared by community members. So here it should lead to /meals. Now that's not the only link though. Instead, I'll also add another link, which should allow us to go to the community, to the foodies community, and hence here it should lead to /community, like that. That's my navigation. With that all added, and with this main header component finished, we can go back to that root layout, and then there, output this main header above that children slot here, so above the page content. Simply like this, though very important, you of course must import it. So here I added this import from that components folder in the root project directory. If you do that and you save everything, you should see something like this if you revisit the page. A total mess, but at least the header is there. It's there and it's working, and it's there on every page, which is amazing. And we can also go back to the starting page, but of course it's totally unstyled and doesn't look good. And that's therefore what will change next. So let's work on styling this header. And when it comes to styling Next.js projects, you got a couple of different options, as it's the case for React projects as well. Now you can already see one option in this project here, and that is such a global CSS file, as I have it here. And you could add multiple global CSS files. The names are up to you. They are global because they're getting imported like this in the layout.js file, in the root layout.js file. And therefore, any CSS file that's being imported like this into this root layout.js file will be available on every page, and the styles set up here will be available on every page. That's the great thing. But this is not the only way of styling Next.js projects. Another popular option for styling Next.js projects is to use Tailwind CSS, because Tailwind in general is pretty popular. It's a CSS library that allows you to style elements by adding small utility classes to those elements. And indeed, on the Tailwind website, you also find instructions on how you could add Tailwind to a Next.js project. And in addition, when creating a new Next.js project, you're also asked whether you want to add Tailwind CSS. at least at the point of time where I recorded this. So getting started with Tailwind in Next projects is pretty easy, and Tailwind, as mentioned, indeed is also a popular solution for styling those apps. But we're not going to use it in this project, simply because I don't want to bore you by adding a bunch of CSS classes to my JSX code. And that is what we would have to do when using Tailwind. So it's amazing, but not great for a course like this, where I want to focus on the main topic, which is Next.js and React, not Tailwind. Therefore, I'll not use it here, but you could use it. Instead, here in this section, we'll use another solution that's supported by Next.js. And that would be CSS modules, which is, in general, standard CSS code, but scoped to specific components by assigning special names to your CSS files. And that's supported by Next.js out of the box. And the idea simply is that you add CSS files that end with .module.css, and you can then import an object from those files, which will be generated automatically by the underlying build process and development server, which gives you access to all the CSS classes defined in those files as properties. And that's what I'll do here. And therefore, I prepared a CSS file for you, a main header CSS file, which you can add next to that main header JS file. And in that main header CSS file, I'm simply setting up a bunch of CSS classes and styles. You can, of course, tweak them as you want, but it should also work like this. Now we just have to import them, or import this file, into this main header.js file to activate it and to make those classes available in this file and scope those classes to this component. And for that, we need a special way of importing this, not as we imported CSS in the layout.js file like this. That would simply add the CSS classes as global classes that affect all pages and all components, but instead by using import and then any name of your choice, like classes, from, and then main header module CSS in this case, a relative path to that file. And with that added, you can now use this classes object, which it is, to access certain properties. And every class defined here in this main header module CSS file will simply be available as a property on this imported object. So for example, here on this logo, we can assign a class to this link. And we now don't do this as a string, like some class, but instead as a dynamic value where we access this class's object. And then here it's the logo class. And this will apply this class here and all the other related styles to this link and the nested elements. But it's doing that such that the styles are scoped to this component and can't affect any other component on the page, even if you would use a similar class name there. So that's the first step here. In addition, I also want to add a class name to the header itself, and that would be classes.header. And then on the navigation, I want to add a class to this nav element here with classes.nav. With all that done, if you save that and you go back to your page, this now looks much better. Now we got a properly styled header, a properly styled logo, and these navigation links here, which also look better, and which of course also still work. But now all styled in a beautiful way with help of CSS modules. So now that we styled this header, there's another element of this header that can be improved, and that would be this image here. Because at the moment, we're simply using the regular image element for displaying this image. And that's not bad or a problem, but in Next.js, you actually got a better element for outputting images than this default image element. Because in Next.js, you have a special built-in image component, which exists to help you output images in a more optimized way. For example, by lazy loading images under the hood, so that they're only displayed if they're really visible on the page. It does that automatically for you without any extra configuration. It can also simplify the process of setting up responsive images and so on. And therefore the recommendation is to use this image component in your Next.js projects if you are outputting any image. Now this image component has a lot of props and configuration options, and attached you'll find a link to the full article on this component, though I will say that many of those props and options are really for more advanced use cases. In general, getting started with that image component and using it in most use cases is pretty simple and straightforward. And all you have to do here in this main header component is to replace the default img element here with the image element that can be imported from next/image. Then you need to set the source to such an imported image, but now to that overall object and not just the src property value. So I changed that src prop value therefore. Because this object that's generated by Next.js when you import an image like this contains useful information that's used under the hood by this image component to display it in an optimized way. For example, it automatically detects the size of this image. And therefore, in its simplest form, this is all we have to do. No other setup is required. With that, if you reload, you will see the image as before, but if you now inspect it, you will see that this image element that's being rendered here has a couple of extra attributes which we didn't add. For example, this loading lazy attribute, which makes sure that the image is lazy loaded and therefore only loaded if it's really visible. In addition, it automatically inferred the width and height, though we could override that if we wanted to. And it generated this source set attribute here, hence ensuring that differently sized images are loaded depending on the viewport and the device we are using to visit this website. In addition, it will also automatically serve that image in the best file format for the browser that's being used by a user. So, for example, as a WebP image if you're visiting this page with Chrome. As you can see, if you visit the Network tab and reload, there you'll see that this image that's being served here was returned as a WebP image, which is a special file format that is more efficient than a PNG. And you get all of that out of the box when using this image component. Now, one thing we should do here, about which we also learn here in the console, the JavaScript console, is add the priority property to this image, since it will always be visible when this page loads. So lazy loading doesn't make a lot of sense here, and we want to tell Next.js and the browser that this image should always be loaded as quickly as possible to make sure that we got no unnecessary content shift or flickering when the page loads. Therefore, on this image component, I'll now also add the priority property like this to make sure that this is loaded with priority. With that added, if we save that and reload, the page still looks as before, but this warning went away. And that is how we can use this image component. Now, as mentioned, you can definitely dive in deeper to explore all the different use cases of this component and all the different configuration options. For example, also if you're loading images from a third-party website or anything like this. Here for this website, this is all we have to do. Now, I mentioned that I also wanted to outsource this header background here into a separate component. And that's what I'll do next. For that, in that components folder, I'll add my main header background JS file. And in there, export a component that's named main header background, like this. And now I'll simply grab this div here from the root layout and return that here in that main header background component. As a little bonus, we can now also extract that CSS class, which is set up in that global CSS file, and put it into a CSS modules file so that we practice working with that again as well. So I'll add another file next to this main header background JS file, and I'll name it main header background.module.css. And now we should grab this header background class and this SVG selector here from the globals CSS file and cut it from there. And instead add it here to this main header background module CSS file. You should now also tweak that SVG selector and actually select SVGs inside of an element with header background as a class. Otherwise, this won't work with CSS modules. With that done, back in the main header background component file, we should import classes from /main header background module CSS like this, and replace this here, this class name, with classes, and then the class name here is header-background. Now that's an invalid JavaScript property name if used like this, and therefore I'll use that square bracket notation and access the property value like this. With that, we can save this and go back to layout.js, and then also output the main header background here. Or, since it, as the name suggests, belongs to the main header, we can actually not do that and get rid of the import and the usage in the root layout.js file and instead use it here in main header.js. There we could return a fragment so that we can add a sibling element next to the header, and that sibling is now that main header background, which I guess makes a lot of sense if we look at it like this. And with that, if we save everything, we got the same result as before, but now using another extra component, which you of course don't have to do, but which I did want to add here for practice purposes. Now I also want to group all these main header related files together into a separate subfolder inside of components so that we keep that components folder manageable and easy to navigate. And hence I'll add a main-header folder in that components folder and move all these main header related files into that main header subfolder inside of that components folder. With that, you then just have to make sure that in the root layout.js file, this import path here is updated, which in my case, my IDE did for me. And with that, the page still works as before. Now that we finished the header, let's continue working on this main page content, on this starting page content. And that means that we need to work on this page.js file inside of the app folder. So not any nested page.js file, but this main root page.js file directly in the app folder. Because that is that starting page we're seeing. That's the page that's being rendered if we visit our address /nothing. So if we have no segment thereafter. And here on this page, I actually don't want to have the content we currently have there. Instead, my goal is to have some header here. So not the main navigation header, but some nested page specific header that introduces users to this page, you could say. And then below that, the main section of this page. Now, since sibling JSX content is not allowed like this, we have to wrap that into a fragment in order to make this work. I also prepared some styles which we can use here, and therefore attached to find a page.module.css file. And yes, you can use CSS modules on pages as well, because in the end, that's also just a regular component file, just treated in a special way by Next.js. But with that, we can import our classes from this page.module CSS file, and then add a class to this header, for example, to be precise, add the header class here. Now in that header, I then later want to have a div, which should receive a class of slideshow, because here we'll soon have an image slideshow or a couple of images that change automatically that simply show different food images. So that's one thing. In addition here, I'll add another div below that other div here, which contains two more divs, where the first inner div here will receive a class name of hero, and that second div inside of a div will receive a class name of CTA for call to action. Now in that hero div here, I want to have my h1 title, where I'll say next level food for next level foodies, or any other catchy phrase of your choice. And below that, a paragraph where we could say, taste and share food from all over the world. So this is simply some marketing text here. In that CTA area, I then want to have two links that allow us to go to different places, and I'm still importing that link component, so we don't have to change anything there. The first link should say join the community, and therefore it should point to that community page with /community. And the second link should point to the meals page and say explore meals, like this. And that's now my header on this page. We'll work on that slideshow later. Now in that main area here, in that main section, I just want to have some dummy text, which I prepared for you. Attached you find my page.js file, which is the same file you see here, just also with some extra sections added into this main block here. And you can simply copy and paste those sections into your main area, or copy and paste the entire file, which you find attached, whatever you prefer. With that done, you should see something like this on the screen, which I would say looks a lot better than what we had before. But of course here we also have this blank space where I want to add that image slideshow, and that is therefore what we'll work on next. So I want to add a little image slideshow here, which basically automatically goes through some food images that should show up here. And for that, we'll build a new component. We could also build it in here, but to keep that file relatively lean, I will add a new component. And I'll do that here in my root components folder. There, I'll add a subfolder called images, and in there, I'll add a image-slideshow.js file. And now here, I actually already prepared the content for this file for you, and you therefore find my finished image-slideshow.js file attached. And you can simply paste the content of that file into your image slideshow.js file. Attached, you also find an image slideshow module.css file, which you should add next to your JavaScript file. Now, what's this JavaScript file doing though? Well, it's outputting some relatively simple markup where I have a div, and in that div, I go through a bunch of images and output the Next.js image component for every image. Now, those images are simply being imported from the assets folder. So we're talking about the images stored in that assets folder. Not all of them, but some of them, all those food images specifically. And then I'm setting up this images array here, which contains all these images and then some alt texts for the images. And then I'm outputting them here. Now, the most interesting part, therefore, is what we have above that JSX code. Because here I'm using useState, so the standard useState hook provided by React, to control some state which changes over time. To be precise, it changes with help of useEffect every 5 seconds with help of setInterval. And that interval is cleared whenever the component unmounts by using this cleanup function of useEffect. And that's standard useEffect and standard useState as you know it from vanilla JavaScript. Nothing Next.js specific here. The logic inside of this interval code here, inside of useEffect, is simply that we change the index of the visible image every 5 seconds, and we therefore cycle through all those images. That's all we're doing here. With that, we can go to that page.js file, to that div here where I'm saying slideshow, and in there we can now output that image slideshow component. Of course, you also must add that import though. But if you try to do that, you'll notice that you get an error if you want to preview the site. There in that error, you're learning that we're importing a component that needs useState and that only works in a client component, but that none of its parents are marked with useClient. So they're in a server component. And what does that now mean? Now that's something that's super important in Next.js. Next.js knows server components, React server components, and client components. And actually, that's technically not just Next.js. Instead, React itself has this differentiation, though in most React apps, in all those vanilla React apps, which you're building with help of Create React App or with help of Vite, you are using client components out of the box. Because in those projects, React.js is a pure client-side library running code in the browser, on the client. With Next.js, that changes because Next.js is a full-stack framework. It has a backend, not just a frontend. And therefore, code also executes on that backend when working with Next.js. And for example, by default, all those React components you have in your Next.js project, no matter if they're pages, layouts, or standard components, are only rendered on the server. That's why they're called React Server Components. Now, as mentioned, that's actually technically a feature built into React, but it must be unlocked, you could say, with a certain behind-the-scenes build process and structure that's not part of most React projects. But it is unlocked and it is the standard in Next.js projects. Therefore, there by default, all React components are such React Server components and are only rendered on the server. So that means that this component and this layout component, but also the slideshow component and the header components, all those components do not execute in the browser. Those component functions don't execute there, but instead on the server. And you can see that that's the case if you console log executing here in this main header component, for example. If you do that, and you then go to the page.js file and you temporarily comment out the image slideshow component, since it's causing an error, which we'll fix soon, and you also comment out that import, you will see that if you save everything and you reload, if you open your browser developer tools, you will not see that executing log here. So that executing log, which we are logging in the main header, it's not showing up here because the main header component function never executes in the browser. Instead, it executes on the server. And therefore, if you open that terminal where you started the development server, which is running that server-side code, therefore, you see those executing logs. So it's there where those components execute. And what's interesting is that this is not just the case for the initial page load, but also for subsequent navigations. So if I, for example, also log something on that meals page, if I console log meals page here, and I then reload the starting page, and I click on Explore Meals to be taken to that meals page, I don't see that log here either, even though I used that link and we therefore stayed in that single page application. We did not fetch a brand new page. But even though that's the case, I don't see the log here. Instead, I see it here in that backend log. And that's happening because even if you are in that single page application mode and you're navigating around, all the components will still be rendered on the server, on the backend. And in the end, it's kind of the finished HTML code that's then sent to the client to be rendered there. It's technically a bit different, but that is how you can think about it. And therefore, Next.js embraces this concept of having those server components. Now, that's an important concept and an important advantage of Next.js projects, because with server components, you have potentially less client-side JavaScript code that must be downloaded, hence possibly improving the performance of your website. And it's also great for search engine optimization, because web search crawlers now see pages that contain the complete finished content. Compare that with a vanilla JavaScript project where you're not using a framework like Next.js. There, if you take a look at the source code of a page, you'll see that it's essentially an empty page because all the content is created and populated on the client side by client-side code with help of those client-side components. In Next.js projects, that's different. If you take a look at the source code there, you will see that all the content is in there. All that text that's visible on the screen is part of the actual page source code. And that is also what web search engine crawlers will see. So that's why we have this concept of server components and why it's an important concept. Nonetheless, in Next.js projects, you can still also build client components. And that would be components that are still technically pre-rendered on the server, but then also potentially rendered on the client. And most importantly, these are components that must be rendered on the client because they contain some code or use some features that are only available on the client. Like, for example, here in this image slideshow.js file, the useState hook or the useEffect hook. These hooks are not available on the server side, which kind of makes sense if you think about it, because we're not interested in setting this interval on the server side. We want to run this in the browser so that the image swaps every 5 seconds after the page has been loaded. Another example for a feature that would only be available in client components would be event handlers. So if you would use the onClick prop to trigger some function, obviously, since you're waiting for some user interaction here, that would require to be a client component because that would require code that runs on the client. But since by default in Next.js all components are server components, you have to explicitly tell Next.js if you want to build a client component by using a special directive at the top of the file that holds that component. To be precise, you have to add the useClient directive. And that then allows you to use client-side features in your component, like event handlers or useEffect and useState. So therefore here, in order to make this slideshow component work, we have to add this useClient directive at the top of this file. And with that added, we can go back to that main page and bring back that import and bring back that component here. And now you will see that if you reload, this works, we no longer get an error, and we now have that image here, which changes every 5 seconds. And that's now the behavior I want here, now unlocked with help of client components. And it's super important to know about this difference and to understand that these two component types exist in general in React, but really only work and can be used when using a framework like Next.js. So now that we finished this starting page, let's as a next step work on this community page. And for that page, it's actually quite straightforward. I just want to populate it with some dummy content. And therefore attached, you find my finished page.js file, and you can simply replace yours with it. So replace your community page.js file with the one you find attached. Attached, you then also find a page.module.css file, which you should also add next to the community page.js file so that the required styles are available. Now in that page.js file, you then see that I got a community component function exported there, and in that component, I'm just outputting some dummy text and some images in the end. So that if you save everything, the community page should look something like this, simply outputting some dummy fallback text. Because of course the main logic of this overall demo project will be related to the meals. It's there where we'll fetch data and add new meals and so on. And we'll get back to that soon. That's why here I just provided some dummy content for you. Now with that community page populated, there's one thing about the header, or about this navigation specifically, that I'd like to improve. We currently don't see which page is active. I am on the community page, but this link here is not highlighted when I'm on it. And it would be nice if it were highlighted. And to achieve this, we can go back to this main header component, where we have this navigation, and edit this link a little bit. To be precise, I want to add a class conditionally to that link, depending on whether the page to which this link leads is the active page or not. Now for that, in that main header module CSS file, I did prepare a CSS class called active that can be added to a link to give it some active styling. Therefore, all we have to do here is find out whether this should be marked as active or not. And we can find out whether that's the case or not by taking a look at the current path name, so the part after the domain. For example, for this community link, the path is /community. Hence, we know that if the path is equal to this path, this link here should be marked as active. For the meals page and the meals related pages, we know that this link here should be marked as active if we are on /meals or /meals share or some other nested page. So if the currently active path starts with /meals. And therefore we just need to get hold of the currently active path. And that, thankfully, is also quite straightforward to do because Next.js gives you a use path name hook, which you can import from Next navigation. And this hook gives you the currently active path, so the part after the domain. And with that path available, we can then set this meals link here to active if the path, which I'm getting from use path name, if that path starts with /meals. So that this link here is marked as active no matter if we're on the meals page or some nested page. That's why I'm using starts with. Now if that yields true, I want to add the active CSS class, however not like this, but since we're using CSS modules, instead like this. And otherwise I'll add undefined as a class, so that no class is added. Well, and now we can repeat that process on the other link, and simply copy that class name code over there. Here I just want to check whether the path starts with community, or since we don't have any nested pages here, if the path is equal to /community. And then I still want to add the active class or no class at all. Now, if we do that though, you'll be greeted by an error, because it turns out that use path name also only works in client components. And that's, by the way, a convenient feature of Next.js. It will tell you if you're using a feature that doesn't work in server components in a server component, so that you can then add that use client directive. So here the fix is to add use client at the top of this header. But here's something to keep in mind. Whilst you can do that, and the error will then go away, and you can now see that the active link is highlighted, whilst that all works, you typically wanna add use client as far down the component tree as possible, so that you really only turn the components that need to be converted to client components into client components, so that the majority of your components can stay server components and are rendered on the server, so that you don't lose those server component advantages for most of your components. And therefore here, since this header component contains quite a lot of markup that does not need to be a client component, I'll take a different approach. I'll add a new component file, navlink.js, sounds like a fitting name, and I'll add a navlink.module.css file next to it. And the idea in this JavaScript file now is to export a component function that can be called navlink. That should simply output that navlink. So in the main header.js file, I'll simply grab this link here and only that. I'll cut it and return it here. Now for that, we must import the link component from nextLink. And of course, we should make navlink configurable. So here I want to get the ref prop, and I'll use the children prop for the actual text that's output between the link. And then here I'll use children, and here I'll use ref. And then here I'll also use this ref prop when I check whether this is the active link. Of course, in order for path to be available here, we now must use the use path name hook I just showed you before, so that we can get hold of the path. And we therefore have to convert this into a client component by adding use client like this. But now it's only that component, and therefore only this small piece of markup that will be rendered on the client side. We can go back to the main header.js file now and get rid of use client here, and get rid of that use path name import, and get rid of the use path name usage, because now there we can simply use that newly added navlink component. So I'm importing that from the navlink component file, and I'm then outputting it like this. And you can use client components inside of server components like this. We did do that before with the image slideshow. We're now doing it again here with the navlink. Now navlink then takes the link text here between those tags. So in this case, browse meals. And we must set this ref prop here to /meals. And of course, now we can also use that here for the community. Here, we now have our foodies community also turned into a navlink. We just have to make sure that we point to /community. And with that, we made sure that this main header component is not converted to a client component and is therefore still rendered on the server, and instead only this small part of it is rendered on the client. Now, of course, here I'm now getting an error that classes is not defined, because in navlink I'm referring to the active class, even though this class's object isn't available here. And to work around that, I'll simply add an import here, where I import classes from navlink.module.css. Of course, at the moment, this is an empty CSS file though, and therefore we should go to the main header module CSS file and grab the active class here and add that here in that navlink module CSS file. We can actually also grab the link related styles here and cut those, and also add them here in the navlink.module file, and change the selector from an anchor element nested in some element with a nav class to maybe link. So to elements that have the link class on them, like this, here and here. And with that back in navlink.js, we can add that link class to these links, so that we either have link and the active class added, or just link. And to make that work, I'll convert this here into a template literal string, into which we can easily inject dynamic values that will be converted to strings, so that here I have classes link and classes active being set on the link. And otherwise, if the link is not active, I just add classes link, like this. And that's now my adjusted navlink. And with that, everything works again, but now only the navlinks are also rendered on the client. All the rest is still only rendered on the server. Now that we worked on the starting page and the community page and improved the header, it's finally time to work on that meals page. And it's time to output some meals there before we then thereafter will make sure that users can also share meals. Now for that, it's this page.js file in the meals folder on which will work, and there I want to output a bunch of meals. A bunch of meals which will soon store in a database. But before we'll do that, let's set up the base markup of this page, the base structure of this page, you could say. And here I again want to have a header section, and then below that the main section of this page. I also again prepared some styles, and therefore attached you find another page.module CSS file, the page.module CSS file for this meals page. And we can and should then import this page.module CSS file, again using this special CSS modules import syntax so that we can access the CSS classes set up in that file. Because there, for example, should be a class added to this header. The header class, like this. I also want to add a class to the main section, and that is the main class that's added here. Now inside of that header, I then want to have an h1 element where I say delicious meals created and then a span by you. And I'm using that span for some extra styling because to that span I want to assign a class, to be precise, the highlight class, like this. Below this h1 element, we can then add a paragraph which simply outputs some dummy text like choose your favorite recipe and cook it yourself. It is easy and fun. You can of course output whatever you want. Now below that paragraph, I want to have yet another paragraph which should receive a class name of CTA for call to action, because in there I then want to have a link using the next link component, which therefore of course also is imported as it always is. And I'm using that link component to link to that share page. So to /meals/share, which will be the page that can be used by users later to share their own meals with the community. And therefore I'll say share your favorite recipe. So that's now this header area of this meals page. And we could, of course, put that into a separate component. If you wanted to, you could do that. You just have to make sure that you bring along the necessary styles. But here, I'll keep it all in one component. I will add a separate component for outputting the meals though. And therefore for that, back in my root components folder, I'll add a meals subfolder to store any meal related components. And there, I'll add a meals-grid.js file. Now the job of this meals grid.js file will be to output a bunch of meal items in a grid. So therefore, of course, we start by exporting a component function. I'll name it meals grid. And I expect to get the meals that should be output here as a prop. And then I'll output an unordered list. And in that list, I'll map through all meals so that for every meal, we can output a list item. Now every list item here needs a key, and the key can be meal.id because every meal will have an ID. And then inside of that list item, I want to output the meal item details. Now before we work on that, I also prepared a CSS file, mealsgrid.module, which you find attached, which you should then import into this mealsgrid.js file, just as we always did it with all those .module CSS files. So that we can add a class here to that unordered list. A class called meals, like this. And now I'll add another component here, the mealitem.js file. And I prepared a mealitem.module CSS file, which is also attached. And attached you also find my finished mealitem.js file, which is a relatively straightforward component that simply accepts a bunch of props and then outputs those props in a structured way. Now what's interesting about this component is, for one, that it then has a link that takes us to a specific meal detail page. And here the path is constructed dynamically with a dynamically injected segment that will be different for every meal because we have that dynamic meal details page. Here, this page, which expects a dynamic value for that path segment, so that we can visit that details page for different meals. And in the end here, where I'm constructing this path, it's this dynamic slug, which will be different for every meal, that will be used as a concrete value for this placeholder. So that's one interesting thing in this component, that will have this dynamic link that will lead us to different meal detail pages. The other interesting thing is this image component. It's this next image component, and it's interesting here because the images I'm outputting here will now not be imported manually from that assets folder. Instead, we'll be working with meals that are stored in a database, and their images are stored in the public folder. Now, it turns out that these are the same images as in the assets folder, but that's just a coincidence here. Later, users will be able to upload their own images and share their own meals, and that's something we have to keep in mind when using this image component, because this image component needs to know the underlying width and height of the image that's being output. So not the width and height you want to have on the screen, but the width and height of the image you're trying to render. And it's able to detect that automatically when you're using the image component, as we did it in the header, on an image that's imported from the local file system, as we're doing it here with the logo. In that case, Next.js is able to look up the width and height. But for those meal items, we'll load them dynamically from a database, and then in the database we'll have a path pointing to some image. And Next.js will not be able to resolve the width and height of such an image, of such a dynamically loaded and resolved image. Simply because the information is not available at build time, as it's the case for all imported images, but only at runtime. And that's why I added this special fill prop here. An alternative would have been to explicitly set the width and height of the images that will be output here, but the problem is that I don't know that in advance, because we'll also be dealing with images shared by the user. And in such scenarios, fill is an alternative. This then tells Next.js that it should simply fill the available space with that image, as defined by its parent component. And I set up appropriate CSS styles that make sure that this will look good. And I'm mentioning this here because it is, of course, a common scenario that you're displaying images where you might not know their dimensions in advance. And in such cases, fill is a great alternative to explicitly setting a width or height, which you should do, though, if you know the width and height in advance. So that's therefore this meal item component added, and with that added, we can output it here in the meals grid component. So here, between those li tags, I'll output the meal item like this, and I'll simply forward all those meal properties from that meal we have here to that meal item. So I use this syntax to pull out all the properties of that meal object and spread them as key value pairs, so as props in the end, onto this meal item. And since the meal I get here, since the meals I'll have in this meals array eventually will have all those properties that are expected as props here, this approach will work just fine. Now, of course, at the moment we have no data source yet, so at the moment we won't see anything on the screen. Nonetheless, we can already take this meals grid component here and go to this page.js file in the meals folder and output it here. But at the moment, I'll set meals to an empty array because, as mentioned, we have no meals yet. So if we save that and we go to that browse meals page, we see our header, which allows us to go to that share meal page, but we see no meals yet. But that's what we'll add next. So in order for this meals grid component to be useful, and in order to see something on the screen here, we need meals. And for that, I want to set up a basic database that will store some dummy meals and that will later also store meals shared by users. And for that, I'll stop my development server here with Ctrl+C, and I'll install a new dependency with npm install. And that dependency is the better-SQLite 3 package. And this is a package that will allow us to work with a SQLite database. And I'll use a SQLite database here because it's an amazing SQL database that can be used locally without setting up any extra database server or any other complex setup needed. Now, in order to create a database and populate it with some dummy data, I prepared an initdb.js file, which you find attached to this lecture. And you should store that file simply in your root project directory. This file uses the package we just installed to create a new database file if it doesn't exist yet. Otherwise, it'll use the existing one. And it then contains a bunch of dummy meals data so that we have some meals to get started, which are then written into that database. That happens down here. First, a new table is created if it doesn't exist yet, and the columns of that table are configured so that every meal has an ID, which is created automatically. Every meal has a unique slug. Every meal has a title, an image, though that will be the path to an image, not the file itself. And then also a summary, instructions, the name of the creator, and the email of the creator. And that's all data I have here in that dummy data, and that's all data we'll later collect from the website visitors. And then with that table created, I have this init data function, which is then executed to write some data into that database. I'm simply writing all those dummy meals into the database. And this prepare function, which you see here, is provided by that better SQLite 3 package. So that's how I'm preparing the database. And with that done, once you run this init.db.js file, you should have some meals available. So here in my root project folder, I'll execute this init.db.js file with Node, and it should work, and you should have such a meals.db file thereafter. That is that SQLite database that we'll use now. Now with that done, we can go back to our meals page and start loading meals from that database. And the question now, of course, is how we do that. Now, when it comes to loading data in a Next.js application, we got a couple of different options. We could fetch the data as we would do it in any vanilla React application. We could, for example, use the useEffect hook like this, and then in there use the fetch function to send a request to a backend. And on that backend, we could then reach out to that database which we just set up and get the data from here. Now, in a Next.js application, we actually already have a backend. We have backend and frontend combined, blended seamlessly together. So we don't need a separate backend. And as you also learned, in Next.js, all your components are by default server components that only execute on the server, unless you're using a feature that requires them to be a client component, like useEffect. But actually, because we have those server components as a default, we don't need useEffect, and we don't need to send a fetch request to get data. Instead, since this component by default runs on the server, and only there, we can directly reach out to the database from here. And that's definitely not something you're used to from other React apps, but that's absolutely fine in Next apps, because this is a server component that only runs on the server. So reaching out to a database is safe here. Now, in order to keep things separated, I'll not write my code in here though. Instead, I'll add a new folder in my root project folder, which I'll name lib. Though that name is up to you and not some kind of reserved name. But in there, I'll add a new file, which I'll name meals.js. And in here, I want to write the code that reaches out to a database and gets data from that database. For that, in here, I'll import SQL from this better SQLite free package. And I'll then establish the database connection by executing SQL as a function and then passing the name of the database here as a string to that function. And then we can work on this DB object to perform actions on that database. Now for that, I'll add a new exported function here, which I'll name getMeals, which should do what the name implies. It should get all the meals from that database. And for that, we can now use this DB object and then prepare a new statement, a new SQL statement that should be executed. And here it's a pretty simple statement. I want to select all columns from the meals table. Then we just have to run this, though you actually don't do that with the run method here, but with the all method. Run would be used if you were inserting data, for example, if you were changing data. All is used if you're fetching data and you want to get back all rows that are fetched by that statement. If you were looking for a single row, you could use get instead. But here it's multiple rows, so it's all. And then we just have to return this result. This also doesn't yield a promise or anything like that. Instead, you can just return it like this. But speaking of promises, it's worth knowing and understanding that even though we're not working with promises here, because the better SQLite free package doesn't use them, even though we're not using them here, we could use them in our component here with ease. Because server component functions can actually be converted to async functions. You can use the async keyword here, something you normally also can't do on your React components. But you can do it on server components. And if you then had some code that would use a promise, you could use await here. And to simulate this, I'll actually go back to meals.js and turn getMeals into async function. And therefore it will return a promise, even though this code here doesn't normally produce one. But now it will be wrapped into a promise. That is what async does. And I'll actually await another promise here, which simply adds an arbitrary delay, just to simulate an action that takes a bit longer, which is something that will help us later once we explore how we can handle loading states and so on in Next applications. This is of course not code you would normally add, because you would not want to slow things down, but here for this demo app I'll add it to add this extra delay. And this also allows me to show you that you can use async await here of course, because it's a regular function, but you can also use it here in this component function. And that's not something you can normally do in React, but you can do it with server components. So here we can then await the call to get meals, to get the meals data, and we'll get back our meals here. Just like that, without use effect, without any unnecessary fetch request being sent. And with that done, we can therefore then use these meals. Down here, where we have that meals grid, we can simply pass meals to meals grid. And with all that done, if you save everything and you restart that development server, you should be able to reload this meals page and see all those meals here. Now, just a brief note at this point, I had a tiny error in my styles when I recorded these videos, which is why for me, the meals look the way they do on the screen. For you, they should look like this, because I fixed that styling error in the attachment. Now, besides that, nothing changes. It was just a styling error. I just wanted to mention it here so that you're not wondering why you have those extra titles here and I don't have them. Now, navigating to their details will work, but will not show you anything, of course, because we haven't added that logic, but you can see those meals here. And that's now data being fetched from the databases and images being fetched from that public folder, because that's where we're storing them, and that's in the end where the paths that are stored in the database will point to. And those images work the way they do because of that setup we got in that meal item.js file. So now that we're able to load those meals, there's one thing you might notice. When we reload this /meals page, it takes a couple of seconds until we see something on the screen. And that hopefully makes sense because we added this delay here in that function where we fetch the meals from the database. So we added a 2-second delay here, and that's why we have this 2-second pause before the page updates. Obviously, if we would make this longer, let's say 5 seconds, we'd have to wait for 5 seconds before we see anything on the screen. However, you then might notice that if you then go to another page and you come back, the meals page is there instantly, pretty much. We don't have to wait those 5 seconds then. And that's the case because Next.js performs some pretty aggressive caching under the hood. To be precise, it caches any page you visited, including the data of that page. And if you then go to another page and come back, it loads that existing page from the cache, so that it can show it to you as quickly as possible. And only if you reload this page, if you leave the page and you come back essentially, only then is the page being recreated. Now that's of course great, but it would be nice if we had some loading indicator whilst this page is loading when we visit it. Because at the moment we have to wait for 5 seconds and we don't see anything during these 5 seconds. If I'm on the starting page, for example, and I reload that page, and I then go to browse meals, and it's therefore not in the cache, I'm sitting there and I'm not sure if my navigation request worked or not, because only after 5 seconds am I redirected to that page. And that's not a great user experience. This experience can be improved by adding another special file to our folder though. You can go to that page, which is loading data, which might take a bit longer, and next to it, you can add a loading.js file, which just like layout and page is a reserved file name. And this file will become active if the page next to it or any nested page or layout is loading data. And in that case, that loading.js content is shown as a fallback until the data is there. So here we can then therefore export a component function in that loading.js file and name it meals loading page or anything like that. And then in there, I want to return a paragraph where I say fetching meals. And I also want to have some styling for that, and therefore I prepared a loading.module CSS file, which you find attached, which sets up some basic styling for this loading.js file. In order to use it, we then just have to import classes from loading.module CSS and then add a class of the name loading, like this, to this paragraph. Well, and with that, if you save that and you then reload this page, you see this fetching meals text until the data is there. And if we were to go to the starting page and we then navigate to browse meals, we also see this immediately now, hence knowing that our navigation worked and what's going on. And that's now, of course, a better user experience than what we had before. Still, it's not perfect yet, because of course, whilst it works, the loading text basically occupies the entire screen. But if we take a closer look at this meals page, we actually have that header here, which does not depend on any loaded data at all. So it would be great if we could show that header instantly and only show that loading text whilst we're waiting for the meals to be fetched. And that is also something we can implement with help of Next.js. Now, one way of implementing it would be to copy this header code here, and also all the styles in the related CSS file, and add that to the loading.js file. That would work, but it would not be ideal. In addition, this loading.js file will also be used for any nested layouts and pages, and there we might not want that header whilst waiting for data. So a better solution is to not use this loading.js file here, and hence I'll name it loading-out, so that it does not have any special purpose anymore, because that's now not a file name Next.js will be looking for. And I renamed it instead of deleting it so that we can still see it and you still have that as an alternative. And I just noticed that I actually added the loading files in my root app directory. Now it still worked because, as I mentioned, it will be applied to any nested pages and layouts as well. So it worked for that meals page, but I actually wanted those files in the meals folder. So I will now move them there, even though I have now renamed it and we're not using it anymore. But that would have been the place where I wanted it, even though it worked either way because it does apply to nested pages. But now we're going to go to that meals page.js file here, because Next.js also gives us another way of handling loading states, a more granular way. Because we can simply go to the place where we have some operation that may take a bit longer, like here loading that data. And we can then create a separate component. Here I'll do it in the same file, since it'll be a component that's closely connected to this meals page. And I'll name this component meals. And the idea behind this component is that it's now this component that will fetch the data. So this code here goes into this component. And hence this must be an async component, which it can be because it's a server component by default. Now async can be removed here on the meals page because I'm not using a wait in there anymore. But now my idea is that meals is responsible for returning this meals grid. So I'll cut that from the meals page component and instead return that here where I'm fetching the meals. And it's now the meals component that can be used down there, like this. But what's now the advantage of this approach? The advantage is that we now outsourced the data fetching part into a separate component, and we can now wrap this component with a component that's built into React. We can wrap this here with the suspense component, like this. And suspense is a component that is provided by React, hence you must import it from React. Suspense is a component provided by React that allows you to handle loading states and show fallback content until some data or resource has been loaded. And Next.js embraces this suspense component and this React concept and makes sure that whenever you have a component like this one here, which performs some data fetching and returns such a promise here, that such components will trigger suspense to show the fallback until they're done. So you don't need to do anything else, you just have to set up the fallback prop on this suspense component and define the fallback content that should be shown whilst that wrapped component is loading some data. And in the end, this loading.js file, which we used before, is doing the same thing, just behind the scenes. It's wrapping the page content with this suspense component. And it's then showing this loading content here as a fallback. Now we can do this manually, and therefore I'll copy this paragraph, which I want to show as a fallback, and put that here. And for this loading class to be available, I'll go to my loading.module CSS file, copy all the code in there, and add it to my page module. For example, here at the end. Doesn't really matter. And with that, we're now telling React that it's now just for this part of the JSX code where we want to show our loading fallback. And therefore, if you save that, you'll see that now the header is there, but we have this loading text down there. And then that content is streamed in and rendered once it's there. So we don't reload the page or anything like that. Instead, Next.js partially renders this page with all the content that can already be rendered, and then streams in and renders this loaded content once it has been loaded. And that, of course, is now arguably a better user experience here. Now this loading.js file even though we're not using it anymore here, is not the only other special file you can add in that app folder in your next project. Because besides loading and page and layout, we, for example, can also add an error.js file, which will handle potential errors that might be generated by your pages and components. For example, if loading some data fails. And that, of course, could happen here. If our database is offline, which is unlikely for a SQLite database, but which could happen if it would be a remote database server, or if anything else goes wrong. And to simulate this, let's simply go to the lib folder and the meals.js file, and then here, let's throw an error. A new error where we say loading meals failed. Something like this, doesn't really matter. Now if I do that, and I remove this error.js file again, we'll re-add it soon, but if I remove it for now, you'll see that now if we reload this page, we'll load the data, and after 5 seconds, we'll get an error. And the error screen we see here is just the development version of this error screen. In production, this would look differently. We see this screen during development so that it's easier for us as a developer to find and fix the error. In production, this would look differently. Now, therefore, it's a good idea to also add some error handling to your application. And you can do that by adding an error.js file. And in that file, you then set up a component that will be rendered by Next.js whenever an error occurs. Though it will only handle errors that occur in the page that sits in the same folder as this error.js file or any nested page or layout. Therefore, you could of course also add this on the root level of your application to catch any error that's caused anywhere in any of your pages. Again, you can be as granular as needed. Here, I'll go down one level so that I don't replace the entire site with my error screen, but instead only a part of that site. And here, I'll then simply output some main element with a class name of error. And I'm setting this class name like this because that's not actually a class I prepared in this globals CSS file, which was part of the starting project. And we're importing that globally, not as a CSS module. Therefore, those classes from that file can be used just like this. And then here I'll add a h1 element where I say an error occurred, and then maybe some details about that error. And for that, to learn more about this error, we can actually use some props here in this error page component. Because when setting up such a component in such an error.js file, Next.js will pass some props to that component. Most importantly, it will provide an error prop, which can contain more details about the error. Now, the actual error message will actually be hidden by Next.js so that you can't accidentally expose any information that shouldn't be exposed to your end users. But if your error would be an object that also contains some error code or anything like that, you could use that here in this component to show a more fine-tuned error message. Here, I'll simply output a generic message and say, failed to fetch meal data. Please try again later. Now, if you add that and you reload this meals page here, you'll get something strange here. You'll get another error, where we learn that error.js must be a client component. And indeed, that's the case. This error component that's stored in an error.js file must be a client component simply because Next.js basically ensures that you can catch any errors with that component, including errors that happen on the client side. So after the pages were rendered on the server. That's why this directive must be added here. And with it added, you see that this goes away. If we now reload, we'll of course still get an error, but now we get our custom error page here. Which you of course now could fine-tune if you wanted to, but here I'll go with that. And that's how we can therefore now handle errors like this. With that, of course, I'll go back to that meals.js file in the lib folder and comment out that line of code. Because I don't want to throw an error, I just wanted to show you how you could handle them. Now, since we're already talking about errors, there's another kind of error that could occur. What happens if a user enters an invalid URL? Something like my-meals, which is a path we're not supporting here. In that case, we get this default 404 page, with which you might be happy, of course. No need to change it. But if you want to, you can change it. And to do that, you can add a not-found.js file, like this. And again, you can add that anywhere in your app folder, and it will automatically cover any sibling and nested pages. So if I add it here on the root level, we can simply catch all not found errors that might be generated from anywhere in this application. If you would want to be more granular and maybe show more granular error messages, you could nest it into some other folder. Now here I will go with that global level, and then again export a function here, which I'll name not found. And then here I'll simply return a main element with a class name of not-found, which is another CSS class I prepared in that globals CSS file. And I'll then add a title of not found, and I'll below that output a text, where I'll say, unfortunately, we could not find the requested page or resource. Like this. And with that added, you'll see that now, for invalid pages, we see our custom not found page here. But with that, I'll now go back to my meals, because as a next step, I want to make sure that we can not just see all meals, but that we can also browse the meal details. So let's now work on that meal details page here. For that, I'll go to this meals folder, and then there this dynamic segment folder, this meal slug folder, and then there this page.js file, because that is the component responsible for outputting the details about a meal. Now here I, again, then want to output a fragment, because I want to have a header and next to that, the main section, as we had it on many other pages as well. Now I also prepared some styles for this page, so attached you find a page.module CSS file, which you should store next to this page.js file. And then we can import our classes from that page.module CSS file. So that then we can, for example, add a class here to this header, a class named header. In that header, I then want to have a couple of things. For example, I want to have a div in there with a class of image, which will then be responsible for outputting the meal image that belongs to a meal. And we will output that image with help of the image component, which is provided by Next.js, imported from the Next image package. Now we'll configure this image later, because at the moment we don't have the meal yet. We'll add the logic for that soon though. The only thing I want to add already is this fill prop here, since again, I won't know the exact dimensions of the image file yet, and therefore I'll use this fill prop as a fallback or as a solution. Then below that, I'll add another div with a class of header text. Written like this, not with a dash, but instead camel case. That's how the CSS class name in the CSS file is named. In there, you should then add a h1 element, where we'll later output the meal title, and below that a paragraph, which receives another CSS class, a class of creator, where I want to output the text by, and then the name of the creator wrapped into a link. And here I'll use the regular anchor element, because this should actually be a link that allows us to send an email to that creator. Therefore, the actual href value will be a dynamically generated string, using this string literal syntax with those backticks here, where I'll say mail to, and then here I'll inject that email address once we have it later. And that's how we can set up a link that will open the mail program so that users can send an email to that person. Below that, we can add another paragraph, which also receives a class. And here the class should be the summary class, where I want to output the short summary text that summarizes a meal. And that's then this header. Of course, a lot of data is missing, but we'll take care of that soon. Now in that main section, I simply want to output one paragraph, which receives a CSS class name called instructions. And then here I want to output the instructions that are stored for every meal. And those should actually be output as HTML code, which can be achieved in React by targeting the dangerously set inner HTML prop on an element. And it's called like this because you open yourself up to cross-site scripting attacks when outputting content as HTML content, at least if you're not validating it. Now this prop then wants an object as a value, and that object should have an underscore HTML property, which then contains the actual HTML code that should be output on the screen. Now we'll get that code later from that meal once we fetched it, but that's how we'll output it on the screen. So that this is in the end our meal details page, without the data that we want to output. Now, in order to have some data to output on that meal detail screen, we should go back to that meals.js file in the lib folder. And there we can export another async function that could be called getMeal. And here I then expect to get the slug of the meal that identifies the meal that should be fetched. Well, and then we simply want to return db prepare and then select all columns from the meals table where the slug field is equal to the slug we're getting here. Now you could now add it like this, but that would be insecure. That opens yourself up to SQL injection. Instead, you should use a question mark as a placeholder here, and then call the get method here, since I only want to get a single record. And then you pass the value that should be inserted for that placeholder to get. In this case, that's slug, which we get here. Under the hood, this better SQLite 3 package we're using here will then protect you against SQL injection attacks. That's why you should add dynamic values into your statements like this. So that should then return a meal. So we can therefore go back to this meals detail page here. And now in there, call get meal and import that from that lib folder and the meals.js file there. Here we'll then get back a meal, which we can then use down there to, well, populate this JSX code. But getMeal, of course, needs that slug. And that slug is simply that part that's encoded in the URL. That is caught with help of this placeholder here, this meal slug placeholder. So how do we then get access to that concrete value that's part of the URL? With help of the props we're receiving on this page. I mentioned before that Next.js is passing some special props to these special files, or to these components in those special files. And for example, every component that's stored in a page.js file will receive a special params prop, which you can therefore destructure. And this params prop will then itself contain an object as a value, where any dynamic path segment that's configured for this route will be stored as a key value pair. And this name you chose here between those square brackets will be used as a key, and the actual value encoded in the URL will be used as a value for that key. And it is that value I need to get to look for that value in the database. So therefore, we can now pass params.mealSlug to getMeal. And that will be that identifier that hopefully allows us to fetch a meal from the database. Now to see whether that worked, let's try outputting a title here with meal.title, like this. If we do that and save everything, I don't get anything here. Now the reason for that is that getMeal actually returns a promise because I'm using this async keyword here. And I added that so that we could add such a delay again, if we wanted to, and if we wanted to set up a dedicated loading page or handle loading in any other way. Now, I actually won't do that here, and therefore we can simply get rid of the async keyword. Therefore, getMeal will no longer return a promise, and therefore now the code should work. Indeed, if I now go back, I now see that title here, which is now fetched from the database. And of course, that means that we can now also output all the other data. For example, on the image, we can set the src prop here to meal.image. Because we'll have such an image key in the database, and we're fetching that data now. The alt text can be set to meal.title. Here for the email address, we can use meal.creator_email, because that's the name I'm using in the database. You can see those names if you take a look at this init.db.js file. There I have these field names, and that's what I'm now accessing here in this meal detail page. And the name can therefore be output by using meal.creator. Now for the summary, it's meal.summary. And for the HTML code down there, it's meal.instructions, without those curly braces though. With all that done, if you now go back and reload, you should see this meal page here. Now you'll also see that this content down there is not formatted perfectly, and the reason for that is that the line breaks we got in these instructions are ignored. We can fix this by overriding meal.instructions with meal.instructions.replace, hence replacing parts of that string, And here we can then use a regular expression to look for all line breaks, which are identified by this special character. Look for all of them in this string, and by then replacing them with the BR tag, the line break tag. If we do that, you see that the line breaks are back. And that's now how we can load and display those meal details. Now it is possible that a user tries to look for a meal that doesn't exist, like Great Bolo. And in that case, I get this an error occurred page. Now I'm getting this error occurred page because I'm trying to access the instructions on undefined, because I wasn't able to load a meal. So it's good that we get some fallback page, but it's not actually an error that occurred if we look at it from a technical perspective. Instead, we simply did not find the requested meal. So a better way of handling this would be to go here and check if not meal, so if meal is undefined, if we didn't find a meal, and then show the closest not found page available in this project. And that can indeed be triggered by calling a special function that's provided by Next.js. The not found function, which is imported from Next Navigation. Calling this function will stop this component from executing and will show the closest not found or error page. So if we have an error page that's closer, as it's the case here, than the closest not found page, it will still show that. But we can work around that by also adding a not found.js file here inside of the meals folder, and then we can also set up some meal specific not found message, like meal not found. And then maybe say, maybe we could not find the requested page or meal data, something like this. And with that, if you now reload, you see that we get this not found page content here, this meal specific not found page content. And that's of course arguably a better user experience. So now that we're able to load meals and then also view the details of a meal, it would of course be nice if we could also add our own meals. And that's therefore what we'll work on next. For that, it is this page.js file in this share folder, in this meals folder, which we will now work on, because that's the page that is responsible for displaying what we can see here. Now, to save you some time, I already prepared this share meal page for you. So attached you find my share meal page component in this page.js file, and you can simply replace your share page.js file with that. In that page component, you see I'm outputting a header with some dummy text, and then a main section with a form. And that form then contains a couple of inputs with labels, and one special input here at the end, on which we'll work in a couple of minutes. An image picker, which will allow us to pick and upload an image, because that will be part of this form. Now this form won't work yet, we won't be able to submit it yet, or to be precise, we don't have any code that would handle the submission, but that's something we'll work on together later. Now attached you also find a page.module CSS file, which contains the necessary styles for this page. And therefore with all that added, if you save everything, you should see this form on the screen when you visit this page. And that doesn't look too bad. But I also mentioned this image picker, and that's something we'll work on next before we then thereafter make sure that this form can be submitted. Now to show a preview of the picked image, we need to handle the event that an image was picked, and then store some state so that we can update this UI and show a preview as soon as we have an image. So we need some state here in this component, and therefore we need to use state hook. This would require us to turn this component into a client component, but we already did this here, so no changes are needed. Now here with this state, I then want to manage the picked image. So I'll name this picked image and have a set picked image state updating function. And now we need a second event handler function here that could be called handle image change, which should be triggered whenever this input here has a new value. So whenever the change event on that input is emitted. And therefore we should add the onChange prop here and set handle image change as a value. Now here in handle image change, we'll then automatically get an event object, as you always do for those event handling functions in React. And we can use this event object to get hold of that picked image. We can get hold of that picked file by using event.target.files and then accessing the first file. This files property will exist because the target of this event is this input. And this file input object under the hood will have such a files property. That will be an array of all the files that have been picked, but here it'll only be one file that can be picked, and therefore I'll just access that first file. You could allow the user to pick multiple files by adding the multiple prop here to this file input, but since we don't have that here and don't want it here, it'll only be one file that we can access. Now it's possible that the user actually did not pick a file for some reason, so I'll check if the file is undefined, if we got no file, and in that case I'll just return and not continue. But if we make it past this if check, we know that some file has been selected. Now in order to show it as a preview here, I now want to convert it into a so-called data URL, which is simply a value that can be used as an input for an image element. So that can be used as a source for an image element. And we can generate such a data URL with help of a class built into JavaScript, the FileReader class. We can construct such a file reader and then do what its name implies. We can read our file. And we can simply call FileReader read as data URL and pass that file to that method. Now this method works in a bit of a strange way because it doesn't actually return anything. Not a promise, not the red file, and it also doesn't take a callback. Instead, we get hold of that data URL that's being generated by assigning a value to the onLoad property of this FileReader object. So we store a function as a value in onLoad, and this function will then be triggered by the FileReader once this method here, this read as data URL method, is done. But here we then won't get the generated URL as an input. Instead, we can access it by accessing FileReader.result. And that will then be that generated URL. And that's what I then want to store in my state. So I will set my picked image to the result of accessing FileReader.result inside of this onLoad function. Well, and with that, we can then use this picked image state to show a preview. So down here, in this controls div, I'll add another div with a class name of preview. And in that div, I now want to check if we don't have a picked image, in which case I'll simply output a paragraph where I say no image picked yet, or something like that. But if we do have a picked image, I want to show that image. And for that, I'll use the image component provided by Next. So you should import that from Next image. And then here, on that image, I'll set the source to my picked image, so to that data URL, and the alt text to the image selected by the user. And I'll add that fill prop because I don't know the dimensions of that image in advance. And that should then be all. With that, we should have that finished image picker component, and we can now take a look at it. Here in this application, I now got this preview area. And if I now click this button, the file picker opens up. And if I pick an image, I can see that preview here. So that is working. And with that, we're now finally ready to also work on the submission of this form. So I got this image picker placeholder here, and my idea here simply is to display an image picker that can be used by the user to attach an image to the form and to upload an image when the form is submitted. Now for that, I'll actually build a separate component, since this image picker is a bit more complex, and hence I'll go to this components folder, and then there in the meals folder, I'll add my image picker JS file. We could also add it in any other subfolder here, but since I'm only using it in this meal-related form, I'll add it here. Attached, you also find an imagepicker.module.css file with some styles we'll use. And then here, we can and should export a component function that can be called image picker, like this. And the job of this component function is to output some markup and then also handle the picking process. Now for the markup, I'll start with a div here with a class name of classes.picker. And for classes to be available, we should of course import classes from /imagepicker.module.css. And then in that div, I want to start by adding a label. A label with a configurable text, which is expected to be received via props. So I'll add the label prop here and then use that here for outputting that label text. Now I will add the HTML4 prop here to connect this label to some input, and I'll connect it to an input with a name of image, or with an ID of image to be precise. And therefore we of course also need such an input, but I will nest that input into a div here. A div to which I assign a class name of controls. And then in there I want to have an input element where the type should be set to file, because this should be an input that allows us to select a file. Now the ID here should be image, so that we connect this label to this input. And I'll add the accept prop to control which files are accepted. And here I only want to accept files that are of type image PNG or image JPEG. So no other files can be uploaded with help of that picker. I'll also give this input a name of image, which will later be important for extracting that uploaded image. Alternatively, we can also make this image picker a bit more configurable by accepting that name as a prop and then setting this like this. We could now also use this name as a value for the ID to make this even more configurable, and I will do that here. Also using it here for HTML4. Now with that we got a very basic unfinished version, but we can now use this image picker in our form. So back in Page.js, in this form here where I have this image picker, we can output the image picker using our own custom image picker component. Of course, for that you must import it from that components folder. And with that added, you will see that image picker here. Now this would work. You could now click it and then select images, but I actually want to make this image picker a bit more fancy. I want to make sure that it also shows a preview of the picked image, and I want to get rid of this ugly button here and instead display my own button over which I have full control. And therefore, back here in the image picker JS file, we can start by adding a class here to this input, and that should be the input class. And this class will essentially make sure that the input itself is hidden. So now we can't see it anymore down there, because I instead now want to render my own button. So therefore here, maybe after the input, we can output a button, which should receive a class of button, and which should be of type button, which is important so that it won't submit the surrounding form. If you would not set the type, it would by default be type submit, and it would submit the surrounding form, which I don't want to happen here. So the type should be button. And then we can set a text of pick an image here on that button. Now with that, we got this button here, which is great, but of course the button isn't doing anything. And what I want the button to do is click this input, which is not visible anymore, for me. It's still part of the DOM, it's just not visible because of the CSS styles I applied. And now I want to use my own button to click this input under the hood, so that I still leverage this input, but I don't show it because it's not looking that nice. Now to make that work, we of course need to handle clicks on this button and then forward them, so to say, to this input. Now we can handle clicks to this button by adding a function here to our image picker, like handle pick click or anything like that. And now we can assign this function as a value for the onClick prop here. Now if you do that, you'll be greeted by an error, because as I briefly mentioned earlier, event handlers like this, so whenever you are assigning a function or any value to the onClick prop or any other event handling prop, cannot be used in server components. Which kind of makes sense, because those interactions happen on the client, in the browser. The user clicks on the button in the browser. Therefore, we must mark this image picker as a client component by adding this useClient directive at the top of this file. With that done, the error goes away. But of course, we're not doing anything when the user clicks the button. What I want to do is, as mentioned, forward that click. I want to trigger a click on this input. And we can do that with help of refs, a feature built into React. We can create a ref with the useRef hook, which is imported from React, so which has nothing to do with Next.js, but which instead works the way you know it from React. which gives you a ref, like an image input ref, that you can then connect to an HTML element. And I'll actually just name it image input. But now we can use that ref and set it as a value for the ref prop on this image input field here, like this. And that now allows us to use this ref to trigger the click method. However, of course, we have to access .current first, because that then gives us access to the actual connected element and object. But that then is the code we can use to trigger a click on this input, which is connected to this ref. With that, if I now click my own button, this image picker opens up again. But now, as a final step, I want to make sure that as soon as I pick an image, I also show a preview of that here. So now that we got this form here, and we're able to pick images, it's time to make sure that this form can also be submitted, and that we then create and store a new meal when that happens. Now, when it comes to handling form submissions, we could do that as we do it in most React projects. We can go to the component that contains the form, and then we could add the onSubmit prop and define a function that should be executed when the form is submitted. There, we could then prevent the browser default, manually collect all the data, and send that data to a backend. But again, here we already are on the backend, at least kind of. We have a full stack application that has both backend and frontend. And that's why Next.js gives us a more powerful and convenient pattern than manually handling the form submission and collecting the data and sending it to a server. Instead, we can create a function in the component that holds the form, for example, which we could call share meal here, though the name is up to you. And we can then add a special directive in this function, so inside of this function body. And that's the use server directive. Now, we have seen the use client directive before, which, however, was not added inside of functions, but inside of files. And then when added there, use client made sure that the components created in that file would be client components. Use server inside of a function is different, because this creates a so-called server action, which is a function that's guaranteed to execute on the server, and only there. So just as components, by default, are server components, which only execute on the server, this is now a function that only executes on a server. But in case of functions, you must explicitly state that it belongs to the server by adding this directive inside of them, if you want to create such a server action. In addition, to really turn this into a so-called server action, you also must add the async keyword in front of it. And now this is a server action. But what's now the special thing about this server action? Why does this feature exist? Well, this feature exists in React, by the way, not just in Next.js, but like server components, it doesn't really work in vanilla React apps. Instead, you need a framework like Next to unlock this feature and use it. And this feature then exists because you can now take such a server action and assign this server action function as a value for the action prop on a function. So here I'm setting share meal as a value on that action prop of that form here. And that's of course something you might have never seen before, because normally the action prop is set to the path to which the request should be sent if you're relying on the browser's built-in form handling capabilities. Now that's not what we're doing here. Instead, we're setting it to an action, to such a server action function. And that's a pattern that's supported by Next and React here that will ensure that when this form is submitted, Next.js will, behind the scenes, create a request and send it to this Next.js server that's serving the website, so that this function gets triggered and you can then handle the form submission there, but on the server. So that function will then execute on the server, not in the client. And this function will then automatically receive that form data that was submitted. So the data that was gathered by the inputs in the form, collected in a form data object, using that form data class that's available in JavaScript. So we'll get such a form data object here, and we can then use that to handle the submitted data. For example, here we could create a meal by extracting meal data from that form data. So we could add a title property to this meal and as a value store form data get title. This form data object that we're getting will have a get method that allows us to get the value that was entered into a certain input field, and the input field is identified by its name. So if I get the value of the input field with the name title, I'm getting the value of this input field here, because this input field has that name title. And of course, we can now do that for all the data that makes up a meal. So all the data we're expecting in our database, like the image, the summary, the instructions, creator email, and so on. So for that here, we can also store the summary by getting hold of form data get summary, extracting the data from the input field with the name summary, get the instructions from form data get instructions, and get the image from form data get image. Now, for this to work, we have to make sure that we pass the appropriate name to our image picker component. And at the moment, I'm not doing that. Indeed, I'm using the image picker without setting either a label or a name. And I now want to change this. So here I'll set the label to your image and the name to image, let's say. And with that, we make sure that we can extract that image with help of form data get. Now that will then be the uploaded file, and we'll handle the storage of that file a little bit later. Now besides that, I'll also get the creator of that meal by accessing form data get name, because I'm getting that name of the person who created that meal from that name input field. So with a name of name. So that's why I'm extracting it like this. And we got the creator email with help of form data get email. Like this. And therefore, that will give us that email. So with that, we create such a form object. And the next step then would be to store that in a database. Though the image should actually be stored on the file system, and then a path to that image should be stored in a database. But either way, the storage of this data is now the next step. But what's important to understand here is that you can use this server actions feature to create such a function that will be triggered when a form is submitted. And in order to see this in action, we'll not store that data yet, but instead simply log it to the console, like this. And with that, we can give this a try. If we now reload this share your email page, and I then enter some data here, like this, and I then also pick an image. If I click share meal, and I open the developer tools before doing that, you see no log here, but you also see that the page didn't reload. So it looks like that default browser behavior, which normally would be to send a request automatically and therefore reload the page, was prevented. And instead, you'll see some output here on the server side in your terminal. In that terminal where you started the development server. There you see that meal data. You see all the data I entered and that file. And again, we'll store that file soon. But with that, that's how you can handle form submissions with help of server actions. So this is how we can add a server action. There also is another way of adding it though. You can add it in a component like this, but this will only work if the component in which you are adding it is not a client component. If you had use client here at the top, because somewhere else in the component you might be using some client-only feature, you would get an error that you're not allowed to have server actions in a client component file. So that would be a problem then. Of course, here we don't need use client, though actually later we will need it, but at the moment we would be fine like this. But nonetheless, this would be a potential problem. In addition, you also might not want to have your server-side form submission handling logic in the same file as your JSX code. You might want to separate that. And for those reasons, you can also store server actions in separate files. Therefore here, I'll actually go back to that root lib folder and add an actions.js file in there, though the file name does not matter. It doesn't have to be named actions.js. It could be any name. What's important in that file, though, is that it has that use server directive at the top. So now not inside of a function, but instead at the top of a file. When adding it at the top of a file like this, all the functions you might define in that file will be treated as server actions. So that simply now allows us to go back to that share page and grab that share meal function here and cut it from there and instead move it into this actions file. There it now must be exported so that it can be used in other files. And you can and should now remove use server in here because we already got that at the top of the file. And with that server action outsourced here, we can now go back to the share meal page and still use it as an action here on the forum by simply importing it. So by adding this import. And now you would be able to convert this to a client component if you needed to. Now you would not get an error when doing that. And that might sound strange, but the problem before was simply that you were defining client and server-side code in the same file. And the build process that's used by Next.js is essentially not able to separate that in a clean way. And therefore, server-side code could accidentally end up on the client side, which could pose security issues and cause other problems as well. That's why for technical reasons, you can't mix both in the same file, but you can absolutely import a server action from another file and then use it in such a client component. Again, here we don't need use client, but it is important to understand that you can blend these two worlds and mix these two worlds as I just described it. But with that, it's now finally time to make sure that we're not just logging the meal, but that we're actually storing it in a database. And that we store the image on the file system. So let's now work on storing that data. And to do that, I'll start in the meals.js file. Here we have functions for getting meals and getting a single meal. Now I want to export another function here, which is there to save a meal. And I expect a meal object as an input. A meal object that should have this shape here. Now inside of save meal, we therefore have to do a couple of things. For example, we'll need to generate a slug, because in my database I want to store a slug for every meal, and we don't get that from the forum. Instead, I want to generate it based on the title. Now to do that, I'll stop the development server and install an extra package, a package called Slugify. That will do what its name implies. But that's not the only package I'll install. Instead, I'll also install a package called XSS, which will help us protect against cross-site scripting attacks. Because you must not forget that we're storing user-generated content, and I'm then outputting these instructions that are generated by the user as HTML. Here in that meal detail page, I'm outputting those instructions as HTML. So we are vulnerable to cross-site scripting attacks, and that's why we should protect against them, and why we should sanitize the content that's sent by the user. Which is exactly what we can do with help of this XSS package. So therefore now with that installed, we can restart the development server. And back here in meals.js, I now want to import these two packages. So Slugify from Slugify and XSS from XSS. Now let's start with the Slugify function. Here I'll create a new slug by calling Slugify and passing meal.title to it. In addition, I'll pass a configuration object to slug where I set lower to true so that it forces all characters to be lowercase. That's the first step. As a next step, I want to remove any harmful content from those instructions. And for that, we can use this XSS thing which we imported, which turns out to be a function, to call it on meal.instructions, so that we sanitize and clean those instructions. And actually, instead of using these extra constants or variables, we can of course also add a slug property to meal on the fly like this, and override instructions with the sanitized instructions like this. Now with that done, we prepared all the data except for the image. Now the image should be stored on the file system, not in the database. Because storing files in databases is a bad idea. It's bad for performance because databases simply aren't built for that. Instead, I want to store the uploaded files in that public folder, because any images stored there, in that images folder, will be publicly available, so they can be rendered on the screen without problems. And therefore, we'll now need to perform a couple of steps. First, I'll start by getting the extension of the uploaded image, because it could be a JPEG or PNG file. So I'll dig into the meal image. Keep in mind that we're storing that image, which we got from the forum, under that image key. So I'm getting access to that here. And then on that, I'll call split to split it on the dot and pop the last element, which will be the file extension. Next, I also want to generate a unique file name and not use the file name of the user. So therefore here, what I'll do is I'll generate a string with those backticks using that string template literal notation, which we can use in JavaScript, to create a file name that uses that slug here. So meal.slug actually, and then a dot, and then the extension. So now with that, we got the file name. Now we need to write that to a file in that public folder. And we can do that with help of an API provided by Node.js. To be precise, the file system API, and for that I'll import fs from node:fs. This allows us to work with the file system. We can then use this fs module to call create_write_stream, which will create a stream that allows us to write data to a certain file. Now create_write_stream then needs a path to the file to which you want to write, and it will then return a string object, which you can then use to write to that path. So regarding that path, I'll create a dynamic string here, and I'll target public/images. So this images folder here in this public folder, slash, and then the file name to which you want to write must be included in that path. So we can inject that file name here, this file name which we constructed earlier. With that, we then get a stream, which we can store in a constant or variable, and which we can use to write to that path, so to that image in that path. Now we can write to that stream by calling the write method on it. And this write method then wants a chunk. Now what's that chunk? In case of our image here, it means that we should convert the image to a so-called buffer, to a buffered image, you could say. Which might sound fancy, but which thankfully isn't too difficult to do. You can use that image object, which we have here, which we're getting from our form after all, so that image that's being stored under that image key. And that object has an array buffer method you can call, which will give you such a buffer, which we need here for the write method. The only tricky thing here is that array buffer actually will give you a promise that eventually resolves to that buffer, and therefore we must await this here. And in order to use await here, we should add async in front of the save meal function here. And with that, we then got this buffered image. Now this is of type array buffer, and write actually wants a regular buffer. So therefore here we have to call buffer from and pass this array buffer, so this buffered image to it, like this. By the way, one other little error I just spotted is here where I split my image name to get the extension. Here we have to access meal.image.name.split. Because meal.image is simply that image which we get from the form, so that image object that's automatically generated by the browser. And that object will indeed have a couple of helpful properties. One of them is the name property, which carries the name of the image file that was uploaded. So that's something we should change here. But with that, back to the stream. Now we're writing this buffer to this path, including this file. And this write method now also takes a second argument. The first argument is the thing you want to write. The second argument is a function that will be executed once it's done writing. And here we get an error argument, which is null if everything worked, but which will hold some error information if something went wrong. So therefore here, we should check if error is truthy. So if we have an error, and in that case, I want to throw a new error, where I say saving image failed, or something like this. And with that, we wrote the image to this file. Now we just need to store the overall data in the database. And for that, I'll start by overriding the image that's stored in my meal object with a path to the image where we stored it. Because I don't want to store the image file itself in a database. Databases are not built for that. Instead, I just want to store the path. Hence, I'll override the image object in my meal with that path here, though there you should actually remove this public segment. Because all requests for images will be sent to the public folder automatically anyways, Or put in other words, the content of the public folder will be served as if it were served on the root level of your server anyways, and therefore public shouldn't be included here, so that it won't be included later when requests for that image will be sent. But with that, we now finished the preparations for this meal object, and we can now save it in the database. And to save it, I'll use my DB object, and then prepare another statement. And here I'll prepare a statement, and I'll use this template literal notation to split it across multiple lines, where I want to insert some data into the meals table, and I want to insert data into the following fields: into the title, into the summary field, into the instructions field, into the creator field and the creator email field, and into the image and slug fields. So basically into all fields that we configured when we created the table, except for the ID, because that will be populated automatically. Now we must specify the values that should be inserted into those fields. And here you could directly inject those values, but this is not recommended because that approach would be vulnerable to SQL injection attacks. Instead, you should use those placeholders, one for every field, though to make this a bit easier, you can also use another syntax here, supported by better SQLite, which I also used in the init.db.js file. This syntax here. You can target specific fields by their name, like this, and then later just pass an object to the run function, which we will call on this prepared statement, and better SQLite, the package we're using to execute this command here, will then look at those property names in that object you're passing to it to extract the values stored under those property names, and it will then use those values to store them in those fields. However, you must make sure that the order you got here is the same as you have it here, and therefore I'll reorder that and put title first, then the summary, then the instructions, then the creator email, and then the image and the slug. I also will remove that trailing comma and instead add one here. Getting those commas right is really important. You will get errors if you don't do it. Well, and then we can call run on that statement and pass our meal object to it. And thanks to this syntax we're using here, the data for those fields will automatically be extracted. And that's it then. This is a save meal function that will store both a file and the data in the database. With that done, we can go back to our server action, and there, instead of console logging that meal, we can call save meal. So we can call this function on which we just worked. Now save meal will return a promise, so we can also add async here, and then use await here. Though at the moment I then don't have any follow-up action that should be executed here, but that will come later. With that though, we're making sure to call save meal here in the server action. Therefore now we should pass the meal to save meal. And if we now save everything and you got that development server up and running, if you go to that share meal page, you should be able to enter some data here, like this, and then pick an image, and click share meal. And with that, nothing happens here, which is a good sign. At least we got no error, but of course, we also don't know whether it worked. Now, we'll take care of that in a second. For the moment, we can take a look at the public folder, and there indeed, I find my uploaded image. So that's a good hint that it seemed to have worked. I also got no error here in my terminal. And if we go back to the page and browse our meals again, we should also find our meal here. And that therefore proves that it did work. Now, to provide a better user experience, we might want to redirect the user once the meal data has been submitted. And for that, we can go back to our actions, and here after save meal, we can call redirect and import that from next navigation. This redirect function will do what its name implies. It will redirect the user to a different page. For that, you have to pass a path to redirect, and that of course should be the path of the page you want to redirect the user to. So for example, to /meals. With that added, if we reload our page here maybe, and browse all those meals that we got there, and I then add a new meal, and here I'll just quickly enter some dummy data to save some time. I'll use the same image though, because we'll use the title as a slug for the image name on the server anyways, so we won't overwrite the old image. But if I do all that and I then click share meal, initially still nothing happens. We'll take care of that soon, but after a short while, we are redirected. And I see my new meal here. So that all works. So now that we're able to save meals, it's time to further enhance the user experience here. And for example, as you saw before, it takes quite some time until we are redirected after adding our data. Now that will typically be a bit faster in production, but still, it would be nice to get some feedback as a user whilst the data is being submitted to see that everything's fine and a request is on its way. So it would be nice to, for example, update this button once we clicked it to tell us that the request is on its way. And to do that, we can use another hook provided by React. Yes, React, but again, a feature that really only works when using Next. For that, I'll go back to my share page here, where I have that form. And here, I want to conditionally update this button and, for example, show the text submitting when the request is on its way. And we can achieve this by using another special hook called useFormStatus. And this hook must be imported useFormStatus from React-DOM. So not from React, not from Next.js, but from React DOM. And this then gives you a status object, which, for example, has a pending property, which is true if there is an ongoing request and false otherwise. However, if you add that hook, you'll see that you'll get an error, because this hook requires a client component in order to work. Which makes sense because it is about updating the client-side UI based on any ongoing requests. Now, therefore, we would have to add useClient here. And we could do that. Wouldn't be a problem, everything would work. But we also might not want to turn this entire page into a client component just because we want to conditionally update this button. In addition, this hook here will actually only give us the status of a form if it's inside of that form for which it should give us the status. So it must be inside of this form here if we want to get the submission status of that form. And with inside this form, I mean inside of some component that's inside of that form. So it wouldn't work here anyways. And therefore, I will not add it here, and therefore remove it, and instead add a new component. A new component here in the meals folder, in the components folder, let's say, that could be named meals form submit or anything like this. And I'll export a component function here, which I'll name meals form submit. In this file, I'll then import this useFormStatus hook, and I'll add that client directive. And then we can get our status here by calling useFormStatus like this. Now, as mentioned, this status thing here is an object with various properties, and therefore we can actually use object destructuring here to pull out that one property I'm interested in here. And that's the pending property. Well, and then meals_form_submit should return a button which says share meal. So what I had on this button here before as well. But actually, it shouldn't always say that. Instead, I want to output some conditional content here and check if pending is truthy, in which case I want to output the text submitting, and otherwise I'll output the text share meal. In addition, I want to disable the button if we are submitting. So I'll set the disabled prop to pending, so that we do disable the button if the surrounding form is being submitted, and we enable it if that's not the case. And with that, we can go back to our form and replace this vanilla button here with our meals_form_submit button, this component we just worked on. With that done, if I reload this page, I can again enter some data here. Like this, and pick the same image as before. And if I click share meal, you now see this button changes, and therefore we get a better feedback. And then after a while, we're redirected and we see our new meal here. So that's better. So we're already providing better user feedback. But that's not all we should do here. One other thing you should typically do when handling user data and form submissions is validate the values you're getting. And at the moment, we're not performing any validation at all in our server action here. Now, we do have some validation because in that form, I'm using those built-in special attributes, those required props here to be precise, to make sure that we can't submit an empty form. So if I press submit here, I'm getting some errors automatically by the browser. And that's a useful behavior, but it's not enough. Because I can disable that by going to the DevTools and removing that. Now, of course, many users won't know about that, but some do, and in that case, those users could submit invalid values to my backend. Because now I would not get an error for this field anymore. And that's why client-side validation isn't enough. Instead, you should also validate on the server side. And here you can now, of course, set up some very complex validation rules. You can use a third-party package that helps you with that. I'll keep it fairly simple to not waste your time, but it's important to know that you should do that in your applications. So here we could, for example, check if meal.title, once we trim it to remove excess whitespace on the left and right, we could check if that's then equal to an empty string, which would mean that it's an invalid value. We could also check if meal title maybe even doesn't exist. So if it's falsy, so if it wasn't part of the submitted data at all. And therefore here we would now make it into this if block if we either don't have a title or if we have one but it's empty. And you should now probably do that for all those fields. And therefore here I'll actually add a helper function, is invalid text, could be a fitting name, where I expect to get some text and where I return the result of this check. So that I return true if the text we got is either falsy or it's an empty string after trimming it. And now I can use is invalid text down here and check if meal.title is an invalid text or if meal.summary is an invalid text and so on. We can now relatively easily do that for all those fields. So also do it for the instructions, for the creator, and also for the creator email. And of course, that should be meal.instructions, meal.creator, and meal.creator email. And we also might want to check whether that maybe exists but is an invalid email address. So I'll also check if meal.creator email does not include an @ symbol by adding an exclamation mark here at the beginning. So if the email does not include an @ symbol, we also make it into this if block. And last but not least, I want to check the image that we got. I want to check if maybe we don't have an image, so if it's undefined, or if that image here has a size that's equal to 0, which means it's some kind of invalid file. And in all those cases, I want to make it into this if block, and then do what? Well, then we could throw an error. So we could throw an error where we say invalid input. And by doing that, if you save that, you ensure that if you reload here, and you then enter values into all those fields except the email address, and we then get rid of the required attribute on that email field so that we can submit it. If we do all that, you see I get this error page. Now the error message here is a bit misleading because it's that main error page which we set up earlier. We should probably set up a specific error page for sharing a meal. So I will copy that here, paste it here, and say failed to create meal. That sounds better. But the important thing is that we got some error at all. However, that's just one way of handling this. Throwing an error, as we do it here, works, but it also means that we destroy the entire input of the user. So we throw away everything they entered. And that's not necessarily a great user experience. It would be better if we would stay on this page and just output some error message somewhere on this page, above the form or below the form, for example. And that's therefore what we'll implement next. So how can we handle validation errors like this in a more elegant way? Well, in server actions, as we have it here, you're not limited to redirecting or throwing errors. Instead, you can also return values. You can return response objects, to be precise. And I'll show you how to access those objects in your components in just a second. So here we could return an object, which maybe has a message field, which holds a value of invalid input. Though the shape of this object is totally up to you, it's just important that it's a serializable object, which means it, for example, shouldn't include any methods, because those would get lost whilst being sent to the client. But any simple values like strings, numbers, nested objects, or nested arrays, those values all work. So that's how we can return a response. How can we then use that response in that share page where we trigger that server action? Well, we can use it with help of another hook provided by React DOM, the useFormState hook. So not useFormStatus, which we had before, but useFormState. Sounds similar, but is a different hook. This hook also must be imported from React DOM, like this. And then this hook here works a little bit like the useState hook that's built into React. Because this hook is responsible for managing the state of this page or of this component, which uses a form that will be submitted with help of server actions. And that's precisely the use case where useFormState can help you. Because useFormState needs two arguments, and the first argument is the actual server action that should be triggered when the form is submitted. In this case, share meal. The second argument you pass to useFormState is the initial state of this component. And that simply means the initial value that should be returned by useFormState before this action has been triggered and yielded a response. So the initial value that should be used if we haven't received a response from this action yet. And that could be anything you want, for example null, or an object where you have a message field that holds a value of null, to resemble the shape of that response we will eventually send back. Eventually I'll send back an object with this shape, where the message holds a string, so our initial value here could be the same shape, but null as a value for the message. Then useFormState will give you an array with exactly 2 elements, which might sound familiar because the default useState hook provided by React also gives you 2 elements. And indeed here, the 2 elements we get here are kind of similar to the 2 elements we get from useState. Because we get the current state, the current response, you could say, of this page here, of this component here. So the latest response returned by the server action in the end, or this initial state if no response has been received yet. And we get another form action here, which we should actually set as a value for this action prop on the form now. So instead of setting share meal as a value for action down here, I'm now setting this form action, which I'm getting back from useFormState, as a value for the action down there. And this must be done so that useFormState can basically step in and manage that state for this component. And that state depends on the execution of that server action and its response. And that's why useFormState kind of needs to act as a man in the middle, you could say. With that, we can then use this state here, which will essentially be either this here or any response we got back from share meal, to output data in this component. Now, in this case, I know that state will therefore either be an object with a message that's a string, or it'll be an object with a message that's null. So we can use it down here at the end of the form, right before the submit button, let's say, to output an error message. For that, we can check if state.message is truthy, which means we have a message. And in that case, I want to output it here between my paragraph tags. Now with that, we also need to tweak the share meal action though, because when passing it as a value to useFormState, it must have a different shape than it did before. It should no longer just accept that form data. Instead, it should now actually accept 2 parameters, because useFormState will pass 2 parameters to share meal when it executes it when the form gets submitted. The second parameter will still be that submitted data, but the first parameter will be the previous state. So either that initial state that we set up here or any other previous responses that might have been generated. I don't care about it here, but still we need to accept it because foreign data is now the second argument we get, not the first. With that though, we got everything set up that needs to be set up, but we'll now get an error if we try to load the page. Because useFormState, since it in the end again deals with updating the client, needs to be executed in a client component. And therefore, we should add useClient here in our ShareMealPage component file. We could again try to outsource this into some nested component, but here I'll stick to this component, add useClient, and save that. And with that, this is looking good. We got no error, and therefore now we can try submitting an invalid form again. So here I'll enter some data like this, and if I now inspect my email field, and I remove the required prop here, and I click Share Meal, I now get this error message. Now, of course, we could make it pop more. We could make sure that it stands out, that it's more descriptive, and you can do all these things. You can, for example, tweak that message here, which in the end is the message that's showing up on the screen. But the main takeaway is that this is how you can show such an error message, that you can return responses in your server actions, and that you can get and handle them with help of the useFormState hook. So sharing meals works now, but there actually is one problem with our application. Everything works fine here during development, when using that development server. But things will change once we move to production. Now, to move from development to production, we should quit that development server here, and then run another script in the terminal, navigate it into our project folder still. And that's the npm run build script. This will build and prepare our Next.js application for production. It will essentially give us a project that we could then deploy onto a server. Now you can run that production server and that optimized code by then running npm start. So first npm run build and then thereafter npm start. This will start a server, but now not some development server, but instead the production server, which here is still served under the same address, but now it's serving that optimized code and so on. Now, therefore, you can revisit localhost 3000 and you should, for example, still see your meals there. But you'll now notice something strange when you add a new meal. For that here, I'll again going to enter some data, and I'll name my meal Tasty Bruschetta. Very delicious. Add my instructions, like this, and pick the same image as always. If I now click Share Meal, I'm redirected, and this is now quicker. As I mentioned before, that's great. It's quicker, better user experience. But the meal is missing here. I see the 3 meals I submitted before, but this new meal is missing. Keep in mind that I added a text of very delicious to it, and I don't see that text anywhere here. And there's one other thing that's pretty strange here on this site. If I go back to the starting page, for example, and I reload and I then go to Browse Meals, I'm there pretty much instantly. If I'm on this page and I reload, it also reloads pretty much instantly. You might recall that before, this took 5 seconds because I added this extra delay here in the meals.js file, this delay. Why is this missing here in production? And why is this meal we added missing? Well, because as mentioned earlier in this section, Next.js performs some pretty aggressive caching. And there is one extra step it performs and goes through when preparing the app for production that we didn't see when testing it with the development server. Because when you run this npm run build command to prepare the app for production, Next.js goes ahead and actually generates, pre-renders all the pages of your app that can be pre-generated. So basically all non-dynamic pages. So it, for example, pre-generated the meals page. So this page.js file in the meals folder. This page here, which outputs some meals, it was pre-generated. So all that data was fetched and rendered there during the build process. And Next.js is doing that because by pre-rendering all these pages, it of course has those pages available right from the start after being deployed. And so the very first visitor of your website is able to instantly see the finished page without having to wait for anything to render, which of course can be a great user experience. And Next.js then caches those pre-rendered pages so that it's able to serve them to all visitors. But the downside of this approach, of course, is that it never refetches the meals, because this code here never executes again. Instead, it just uses those pre-generated pages. And I can prove that. We can simply console log fetching meals here in that meals component that's being used by the meals page. And if I do that, and I then rebuild my project by running npm run build again, you will see that it generates all those pages. And then once it's done, if I start that production server, if I reload the meals page, I don't see fetching meals here. I get some warning that we might want to install some extra package when using that image component, but we can ignore that here. The main thing is that we don't see this message being logged. So that is not executing anymore because those pages were pre-generated and cached. But that's of course a problem if the data that's visible on that page changes, as it's the case for me here. Now you can see that latest meal I added earlier now because I regenerated all the pages. But if I would add another new meal here, it would again be missing. And that's of course absolutely not the behavior we want here. So how can we fix this problem of Next.js caching too aggressively? Well, we need to tell Next.js to throw away its cache or parts of its cache whenever we add a new meal. And of course, this is such a common requirement that there's a built-in method for that, a built-in function provided by Next.js. A function which I want to execute in my server action right after saving a meal before I redirect. And that function is called revalidatePath. This function tells Next.js to revalidate the cache that belongs to a certain route path. So for example, if I know that I want to visit the meals page and that the meals page depends on data that changed now, I can tell Next.js to revalidate the /meals path. And with that, that path would be revalidated. Now what's important is that by default, only that path will be revalidated, no nested paths. So if I had some nested path there in my meals folder that also depends on all the meals data, I would have to revalidate that separately. Alternatively, you can pass a second argument to revalidate path and set this to layout. The default is page, which means that simply this one page for this one path will be revalidated. If you set it to layout, it's the layout that will be revalidated, which, as you learned, also wraps nested pages, and therefore with this, all nested pages would be revalidated as well. And revalidate simply means that Next.js throws away the cache that is associated with those pages. So, for example, the cached pages themselves. Now here, I don't care about any nested pages, because the dynamic page here isn't pre-generated anyways in our current setup, and the share page doesn't depend on the meals data, so I'm fine with just revalidating /meals. If you would want to revalidate all the pages of your entire website, you could, by the way, do that by targeting / and then setting the mode to layout. But here I'm fine with just revalidating the meals path. Well, and with that done, if we now run npm run build again, to build all those pages again, they will still be pre-generated and cached, but now that cache should be revalidated and partially cleared once we added a new meal. So if I now run npm start again to start that development server, and I then add another new meal, like this, picking the same image as always, if I submit that, it takes a bit longer here, which is a good sign because it's taking longer because it loaded all those meals again. And here we are. Now the image is missing. We'll take care of that in just a second, but the meal is there. And that's of course a good sign. In addition, we got these fetching meals logs back here, which also proves that this is now working as intended. So now that we understood how caching worked and we fixed that problem related to it, let's focus on that missing image. Why was that image missing when we added a new meal whilst running this production server? Well, the image was missing because we store those images in this public folder and they're in the images folder. The problem with this approach just is that this folder is available during development, but for production, it's actually copied into this .next folder, and it's this .next folder, which also contains all those cached pages and so on, that will be used by the running Next.js production server. If you then thereafter add new images into the public folder, those will be ignored, because the production server doesn't care. So when you deploy your next project, you therefore technically don't even have to deploy the public folder. Next.js is not interested in it. Now that's of course a problem for our app here, because we do store images in that public folder. Well, this behavior is described in the official Next.js documentation, and there they therefore recommend that you should store any files that are generated at runtime, essentially, using extra file storage services like AWS S3. Now, since working with a provider like S3 is now really a bit beyond the scope of this course, we'll ignore this problem here. However, after this lecture, in the next lecture, you'll find a text lecture where I do describe how you could use AWS S3 for storing and serving your user-generated images. You don't have to implement that, you can ignore it for this demo, but if you're interested in learning how that would work, that next lecture is for you. All that, we're now finally pretty much done with this application here. Now, I will quickly fix a styling error, which I only just detected, which has been fixed in the attachments I provided to you though. So you already got the right styles earlier, but here I'll fix it by moving position relative in the meal item.module CSS file from this meal header selector to the image selector. Again, I did already fix that in the attachments I provided to you. So you don't have to do anything and you got the right styles all the time already. But now here for me, those meals also look a bit better. But that's just one thing. The more important last step I want to go through together with you is the page metadata that you can add to your pages. And you can see that in the root layout.js file. There we have a metadata constant that's being exported. And that's not some random constant, but instead Next.js is looking for exported variables or constants called metadata in all your page or layout files. And then in this metadata object, you can set some metadata fields, which is also described in the official documentation. There you can find details about all the fields you can set on this metadata object, and attached you find a link to this documentation, so that you can explore in depth which fields can be set there. In short, this metadata constant allows you to add a bunch of metadata, which is then, for example, exposed to search engine crawlers, or which shows up when you're sharing a link to a page on X or Facebook. Now here I'll keep it fairly simple, but I want to add a title and description to every page. Now if you add this metadata to a layout, it will automatically be added to all the pages that are wrapped by that layout, unless a page specifies its own metadata. In that case, the page metadata wins. Any nested layout metadata would also win over that root layout metadata. But by setting this metadata here, every page will at least have this basic metadata. But now, of course, I want to set more specific metadata for some of my pages. For example, for that all meals page. There, it would be nice to have some metadata, and we can therefore add it by simply exporting this metadata constant there as well. And then here we could set the title to all meals, and then maybe add a description of browse the delicious meals shared by our vibrant community. Something like this. If you do that, and you go to that meals page, you'll see that if you reload, you have this all meals title here. And if you take a look at the page source, you will also find this description meta tag in there, which contains your description text as content. Here it is. So that's how you can add metadata. But how can you add metadata to dynamic pages? where the title and the description depends on the concrete data that has been loaded. Adding static metadata like this typically doesn't do the trick there. For dynamic pages, you can add metadata by not exporting a constant or variable named metadata, but by instead exporting an async function called generate metadata. And it must be called like this because Next.js is also looking for functions like this. If it doesn't find any other metadata, it's checking whether there is such a function. And if there is such a function, Next.js will execute it for you. And then it's your job to return such a metadata object in that function. Now, how does that help us with dynamic data? Well, this function receives the same data our page component receives as props. So here we also get an object with a parents key. And that, of course, allows us to get the meal for which the metadata should be generated by simply accessing meal slug and passing that to getMeal. Well, and with that, we can then return a title that's set equal to meal title and a description that's set to meal.summary, for example. And that's how we can generate the metadata for a dynamic page. With that, if we now visit a meal, we can see its title, its name, represented here in the tab title. Now, if we enter some invalid slug here, we now get an error though, instead of the not found page. Because the metadata is actually generated first, and this now simply fails. When I try to access title on meal, that fails because meal is undefined. So therefore, we should actually add this if check here, where we check whether the meal is maybe not defined, and call the not found function if it isn't, inside of generate metadata, to ensure that we show the not found page if generating the metadata fails, which it does if we don't find that meal. With that, you see that now we get that meal not found page again. But that's how we can handle that metadata. And that's now it for this section. In this section, we had an in-depth look into Next.js using this app router. And you learned how you can set up routes by using the file system inside of app, and by using these special file names like page.js and layout.js. You also learned about other special files like error.js for handling errors, or notfound.js for handling not found errors, or the loading.js file, which I'm not using here, but which we used temporarily to show some loading state on the screen. Though you learned that you have more granular control by using suspense, which is what we then did. Now, you also learned how to configure dynamic routes, where some path segments aren't known in advance, like here, where we load pages for individual meals, where we don't know in advance how many meals we'll have. And most importantly, you learned that all those pages in the end just export standard React components, but that those components are kind of special when using Next.js. That they are server components that are executed on the server, that are rendered on the server, therefore. And it's not just those page components, but instead all components, unless you explicitly opt out of this behavior by adding this use client directive to convert a file and its components into a client component, which then is rendered on the client, and which then therefore may use client-side functionality like use state or handling user events. You therefore also learned that you can take advantage of those server components by fetching data directly inside of those components. There is no need to use useEffect and send requests to separate backends. Instead, you can fetch the data from right inside your server components. And you can not just fetch the data. You also learned about server actions. Async functions that either have the use server directive inside of them or that are stored in a file with use server at the top. And the special thing about those server actions is that you can assign them as values to the action prop on form elements, either directly or, as we're doing it here, with help of useFormState, which is a hook provided by React DOM to handle responses returned by the server action function and then potentially update the UI based on those responses. Like here, where we are conditionally showing an error message. Speaking of updating the UI based on server actions, you also learned about the useFormStatus hook, which can be used to find out whether a form is currently being submitted or not, which can then be used to update the UI accordingly. Now, related to all of that, you also learned that Next.js does some pretty aggressive caching. and that therefore you should call revalidate path whenever you change some data to make sure that the latest data is fetched and represented on your pages. And you also saw that it can be dangerous if you never test your app in production mode, because everything worked in development mode in our app here, but then suddenly the data was missing in production mode. So this is an important function and an important concept to understand in general. Now, last but not least, we also talked about metadata that can be added to pages, static metadata, as we have it here, or dynamically generated metadata. And therefore, at this point, you have a super solid Next.js foundation, and you're ready to use Next.js with its app router in your future projects. Now, at this point, you learned about all the important Next.js essentials you need to know when working with the app router. In this and the following sections, we'll now switch to the pages router, that different approach of building Next.js applications. And we'll start from the ground up again, from the very basics, as if you had never watched that other section, so that you learn about this approach in depth as well. Now, the sections you're about to see are the original course. I added this app router section before this section here after the initial course was released, because when I released the course, the app router simply didn't exist yet. Now, I will add more app router content, more in-depth content, for example, also taking a look at authentication with the app router over the next weeks and months, and I will always let you know when new content is added. No worries, and you will also get it for free. But since this pages router is still being used in many projects, and is, in my opinion, also a bit more stable than the app router, you should definitely also go through this and the next sections so that you do learn about both ways of building Next.js applications, because you never know on which kind of project you'll be working, and you'll be building amazing full-stack React applications no matter which approach you prefer or use. So therefore, let's now get started with the pages router. So now it's time to dive into Next.js, or to dive into its core features. And we are going to start with routing in Next.js applications, because that is one of the main things it changes compared to regular React apps, and it changes it to the better, I would say. It makes it easier. We are going to move from code-based routing and route configurations to file-based routing. And in this course section, you are of course going to learn what exactly that means and how that works. Now, for that, we are going to understand what exactly file-based routing is and how it works. We are going to explore static and dynamic routes, because both can be handled by Next.js routing, and I will explain what the differences are. And we are going to navigate between different pages, so we're also going to see how that works. Now, to get started, I created a brand new project, a brand new Next.js project, and I created it just as shown in the last course section. I did attach this project here though, which I created because I pre-configured it a little bit. I cleaned it up a bit, to be precise. The pages folder is pretty empty here. The styles folder only has one styles file with some predefined styles I set up for you. And therefore, I do recommend that you do download this attached snapshot so that we're all starting with the same base. And once you did download it, make sure that, for example, through the integrated terminal here, you then run npm install to install all the dependencies that are required for this project. For this command to succeed, you need to make sure that npm, and therefore Node.js, is installed on your system from nodejs.org, for example. Now, once you did that, we're all ready to go. And now let's dive into file-based routing and understand how that works in Next.js applications. In traditional React apps, so in React apps where you are not using Next.js, you set up routing like this. You have some code in one of your React components where you do add various route-related components from React Router DOM, which is a great library. And there, of course, isn't necessarily anything wrong with this setup, but this is not how we'll do it with Next.js. There, we don't install React Router, and we won't write any JSX code or any JavaScript code at all when it comes to defining our routes and our page structure. Instead, with Next.js, we create React component files. So regular React component files in a special folder, as you will see, and we will then let Next.js infer our routes in our project from that folder structure we set up there. We use the special pages folder for that because Next.js will automatically look into that pages folder to infer our route structure. Now, how does this work? Well, let's consider this example pages folder. Here in this pages folder, we would have an index.js file, and then as a sibling to that file, we have the about.js file. And then we have the products folder as a sibling to the index and about.js files, so as a subfolder in pages. And in products, we have two additional JavaScript files. The index.js file again, but now in products instead of just pages. And then a file with a rather strange file name, square brackets, and then ID inside of those square brackets, .js. Now I'll come back to this strange looking file name in a second. Let's first of all have a look at what Next.js would do. It would look at this pages folder and now infer a couple of routes we want to support. For example, based on index.js, it would infer that this should be our main starting page for requests to our domain /nothing, so for an empty path. For about.js, it would infer that we, for example, want to load an about page here, so it would in the end just render the component returned in the about.js file, and it would load that component for our domain.com/about. So it takes the file name as a path, as you can tell, with the exception of index.js, that's a special file name which it will assume as the root path for the given folder in which you are. So directly in the pages folder, index.js would be our root path, an empty slash after the domain. Inside of products, for example, index.js would be loaded for mydomain.com/products. So not /products/index, but just /products/nothing loads index, just as just mydomain/nothing loads index in the pages folder. If we have a file named differently, like about.js here, then this file name is used as a path segment. An alternative to naming a file about.js, therefore, would also be to create a subfolder named about with an index.js file inside of it. That would lead to the same result, because index.js files are treated in that special way I just explained. And of course, we're going to see all of that in action soon. Now, what about this strange square bracket file name here? This is a special notation we can use to add a dynamic path. So for example, if we have the product detail page here, so if we show some content for a selected product, then of course we want to show that same page for different products. So our URL would look something like this: ourdomain.com/products/ and then the ID of a given product. And of course we can have multiple products and therefore multiple IDs. And that's why this is dynamic. The ID isn't always the same. And as a developer, we can't predefine our different detail pages for the different products because A, we might not know in advance how many products we'll have, and B, even if we knew, it's always the same page, just the data on the page will be different. And that's why Next.js supports such dynamic paths as well, with that special file name. So that is the equivalent to defining such a dynamic path with React Router like this. So now that we had a first glimpse at this file-based routing system in theory, let's apply it in practice to this demo project we set up here so that we really understand it. This pages folder is important, as you learned. And in this pages folder, we can add a new file. We can, for example, name it index.js. You learned that index.js is a special file name such that Next.js will not use the file name as a path then, but instead will load the index.js component as the main component for /nothing. So here in this case, we have index.js, and this file would be loaded if we just visit our domain, and then we have no other path after our domain, so just our domain /nothing. But what goes into this index.js file? Well, as mentioned before, just a regular React component. There's nothing special to that. You don't need any special code in here. You just add a normal React component, you export this component, and then with that, Next.js will render that component when a request reaches this file through Next.js routing system. So therefore, in this file, we can add a component, and we can add a class-based component or a function-based component, and I will stick to function-based components only in this course. So therefore, we can add a new component, a new function here, and name this homepage, for example. Now, the name is totally up to you. This doesn't have to be named homepage. Any name is okay. I'm just using homepage as a name here because it will be the root page loaded, and whilst it is a regular component, technically we will treat it as a page. It will occupy the entire page, and that's why I add page in the component name. But you can name this component however you want. Now in this component, we then want to return our JSX code just as we know it. So here I will return, let's say, a div, and in that div, a simple h1 tag where I say the home page. Definitely not too inspiring yet, but we'll get there. Now we need to export this function as the file default. So either like this, or what I like to do, but it's up to you, like this. We need to export this function, this component, so that Next.js knows which component should be rendered as a page, because in theory, you could of course define multiple components and have multiple functions in that file. Now with all of that, once you save that file, we can see it in action. For this, in your terminal here, simply run npm run dev to bring up the development server for this Next.js application. It will open up on localhost 3000 by default. And therefore, once you visit that in the browser, you should see this. And it's just a bit big here for me because I zoomed in quite a lot so that you can see this. So that's what you should see on the screen. And of course, that's the content returned by this component in our index.js file. And we do see this on the screen because we're visiting our domain /nothing. There's nothing after that slash. If I would enter about here, it would crash and we would get this default 404 page, which we get here during development because we didn't define a component for that yet. Well, that's what we're going to do next, though. So now that we understood how we can generally add our page components, let's add a second page. For this, let's add a new page file, so a new file in the pages folder, and we can name this one about.js. And the file name does matter here, just as it did for index.js, because index.js was a special file name. About.js is not, but now, since it's a file name different than index.js, now that file name will later be used as a path. Now in here we can add a new function, name it about page, and then return another div here where we have a h1 tag and say the about page. And we're going to build some more exciting apps later in the course, but to get started I want to keep that simple for now. And then we also export this. We export this about page here. Now if we save this about page, we can go back and visit localhost 3000 about. Of course, this npm run dev process still has to be up and running for that to work. And you see that this now works, and we get this about page, and we no longer get this 404 error, because we added this about.js file. So that's how we can add multiple pages. There is a different way of doing that, though. Now we can add more and more pages by adding more and more files here. But at some point you might want to structure your pages in a different way, or you need some deeply nested path consisting of multiple segments. In such cases, you can add folders to the pages folder. For example, here we could add the portfolio folder, and in that folder, inside of the portfolio folder, add an index.js file. So again, this special name, but now nested in the portfolio. Now in there, we can again create a function, the portfolio page function. And of course, that's just another React component which we're adding. And here we could add the portfolio page as the content and then export this default portfolio page like this. If we do that and save everything, we can also visit /portfolio here and we see the portfolio page. Therefore, this is an equivalent to creating a file named portfolio.js one level above that folder. So instead of about.js, we could have created an about folder, and in that about folder, We could have added an index.js file, and then we could also have our about page component in this index.js file in the about folder, instead of having the about.js file here. So now I deleted this about.js file, and if we save everything, we can still visit /about. So that is a perfect replacement. That is an alternative, and it's up to you what you prefer. If you want to have subfolders to structure that, or if you want to have files with that name. Now, subfolders don't just exist so that we have an alternative to a file named about, though. Instead, we need them if we want to create paths that consist of multiple segments. For example, in Portfolio, if we want to have, let's say, a list.js file, so that we can have a URL of /portfolio/list, then there is no way around having a subfolder. Because in there, we can now create our list page and return our JSX code here, the list page. And of course, just as before, then export this list page. But now with that, we can visit /portfolio/list, and we see that, but there wouldn't have been another way of getting this to work. Without that portfolio folder, we could not create this nested path. So that is a use case where we then definitely need nested folders. And of course, in general, having some kind of structure in the pages folder and working with subfolders for grouping files together isn't a bad idea in general, because of course that allows you to keep your files more organized, especially if you're working on websites with dozens or hundreds of pages. So now we also learned about those nested folders to construct nested, more complex paths, or as an alternative to having a file of the same name. But maybe you also remember that last use case down there with the square brackets. This can be used to have a dynamic path with a dynamic path segment. And that's another key feature Next.js offers to us. Let's say here in this very simple dummy application we are working on, in our portfolio folder, we don't just want to have the root path for /portfolio and the list path, but we also have different portfolio items, different portfolio projects, let's say. And those projects might have different IDs or slugs, and we want to load the different data in the same kind of component for those different slugs or IDs. That's exactly where we would create such a dynamic route component. And here, the naming pattern is always exactly the same. You use square brackets, and then of course still .js because it's still a JavaScript file. And inside of the square brackets, any identifier of your choice. So this is up to you. It doesn't have to be ID. It just very often will be some kind of ID, but that's up to you. It could, for example, be project ID, just to really emphasize that this can be any term you want. The square brackets matter though, because those tell Next.js that here we don't want to have /portfolio/project ID, but that instead this is a placeholder for any kind of value, which we then will have access to in the component to load different kinds of data. But that will be the next step. So therefore, let's now save this. And even though this might look strange, this is a perfectly valid file name. And now in here, we can create a new function, the portfolio project page function maybe, where we return another div where we say the portfolio project page. And then just as before, we simply export this page component. Now, how can we load this component or this page? Well, it's a placeholder, as I said, and it's in the portfolio folder. Hence, what we can do is we can enter portfolio / and then any value of your choice. For example, something. And you see the portfolio project page. Also, if we use /1 instead of /something or /hello. So whatever value we enter here, this is valid because here we defined that we want to accept any value, that we just have a placeholder here. And now we're filling in a concrete value for that placeholder. Please also notice though that /list still loads the list page, since Next.js is smart and checks your other files as well. So if it sees that a value could be treated as a value for this placeholder, it also checks if you maybe have a more concrete file for that exact value. So for /list after /portfolio, it sees that there is a list file in the portfolio folder, and it prioritizes that file over this dynamic file. And that's a great behavior, because it means that you can have static predefined route page files next to dynamic ones like this one. But what can we now do with that file? It's a placeholder, but what's the real benefit we get by using such a placeholder? As I said, a common scenario for using such a dynamic page would be that you have the same kind of page that should be loaded for different pieces of data, different products in a shop or different blog posts in a blog, or like in this case, different projects we want to show on our portfolio page, for example. So therefore now inside of this page component, we typically now want to use the concrete value that was entered, so the concrete project ID here, and then probably reach out to some database or something like this, fetch data from there, and then use that concrete data in this component to bring that data to the screen. So how do we then get access to the concrete value that was entered by the user in the URL? For this, Next.js gives us a special hook we can use. For this, we need to import something from next/router. So from the Next library and there from the router subpackage. And we need to import the useRouter hook. So that's a React hook defined by the Next.js team, which we can use in any functional component. Alternatively, if you're working with class-based components, there also is a withRouter higher order component which you can wrap around your class-based component to get a special router prop injected into your component. But we're using the more modern functional component only approach here, and therefore we will use this useRouter hook. Now inside of the functional component, we can then call useRouter like this, and this will return a router object to us. Again, if you would be using withRouter, you would be getting that router key here on your props object. Now, what does this router object give us, which we're getting here? This router object exposes various pieces of data and various methods we can use. Now, we'll have a look at the methods later when we dive into navigating between pages, but when it comes to the data properties, we, for example, get the path name. And let's see what's inside of that by simply console logging it here, so that we can see what we get there as a value. And let's also console log something else. Let's console log router.query. That's another interesting property we can access on that router object. With that, if we save this updated project ID page here, if we go to /portfolio/something or anything like that, and we then open up the developer tools, we see the path here, and the interesting thing here is that we don't see the path we entered in the URL /portfolio/something, but the path inferred by Next.js. So the path to the component file that had to be loaded to bring this to the screen. The portfolio folder and then the square bracket project ID.js file, if you want to read it like this. And that, of course, is the path Next.js had to take to reach this component, which is responsible for what we see here. So that is the encoded, the inferred path Next.js took. Then here we have an empty object, but we can ignore this double output we're getting here for the moment. Instead, if we have a look at the last log here, we see that it's actually not an empty object, but it is an object with a project ID property and then a value of something. And that's the interesting part now. This query property on the router gives us access to the concrete data that is encoded in the URL. So it gives us access to the concrete value we get for this dynamic path segment. So we entered portfolio/something, and therefore something is the concrete value for this project ID placeholder. And that's why on this query object, we get project ID as a key name, because I picked project ID here as a value between the square brackets. And then something, so what we entered in the URL, as a value. And that means that we can use this router query property to get access to the concrete value encoded in the URL. And if this would be the ID of some database object, we could then send a request to some backend server to fetch the piece of data with an ID of router.query.projectID in this case. That's how we could use this encoded value. And that, of course, is how we will use it later once we also dive into data fetching. Here, I just want you to understand how that routing works and how we can get access to the different pieces of data we might need. And that is how we can get access to this dynamic segment value. Now, when working with such dynamic routes, such dynamic paths, there are two interesting variations or extensions of that concept you should be aware of. One variation or extension is that you can, of course, also have nested dynamic paths. So let's say, besides portfolio/project ID, we also have another folder, the clients folder, let's say, and we want to construct a nested path here, where we have a dynamic client ID, which can be different for the different clients. And then for every client ID, we have some static pages, like a list of all projects we did with that client, but then also dynamic nested paths for the individual projects we did with the client. Not clear what I mean? Let me show it to you. So for clients, I might want an index.js file where I list all my clients. So here we could have a function which I name clients page, and then I return a div here with a h1 tag of the clients page, and close the div, of course, and I export that. And of course, that's nothing new here at this point. But then I want to have a dynamic path, but a dynamic path with nested paths. So not a file named square bracket something.js, but instead we can have a subfolder which also has this square bracket name. So here we could then have the ID of a client, but now that's not a file, that's a folder with this special name. And then here again, we could have an index.js file, and that could, for example, list all the projects or all the client projects. So all the projects for a given selected client. And hence here I have a div where I say the projects of a given client. And we export this as well. And we could have more static files here, like an overview.js file or whatever. But we can now also have another dynamic folder or file nested inside of this already dynamic folder. For example, let's say for a selected client, we then have different projects. So here we have the client project ID identifier. And of course, as always, what you write between the square brackets is up to you. So this could then be a page for an individual project for a selected client. So the selected client project page, whatever. That could be a name here. And I'm just coming up with some examples here because, of course, these are use cases you could encounter in a real app you're building. So the project page for a specific project for a selected client. And we can also export that. Okay, so with that, I added a bunch of new folders and files. And the interesting thing, of course, is that we have this dynamic folder name. How could we now reach those different files and pages? Well, we can enter /clients to reach this index.js file. And there's nothing special about this. If I enter /clients, I see the clients page, which is the output of this functional component. But now we have this dynamic ID segment folder, and in there we have an index.js file as well, where we, for example, want to list all the projects of a given client. So therefore, we could enter clients/max, if that would be the identifier of a given client, and we see the projects of a given client, which is the output of this page here. And then we can also drill even deeper with yet another dynamic segment with clients/max project 1, if that would then be the ID of a specific project for this specific client. And therefore, we now see this output. And in all these pages, we can, of course, get access to the concrete values entered in the URL. So here in the selected client project page, we can again import use router from next router. And then in here, simply get access to the router by calling use router and then console logging router query. And if we do that, we see that we need to get an object with two properties now, because I am logging this in a component that is loaded for a file name with a dynamic segment, which is inside of a folder with a dynamic segment. And you always get access to all the concrete values for the different placeholders that might have been part of the overall path for which this component was loaded. So therefore, we get access to the concrete ID value, since we're in that dynamic ID folder. And then since we're in this dynamic client project ID file, we also get access to that concrete value. so that we can use all these values in our project or in our component file here to then fetch the specific project for this specific client, for example. Now, if I would use router in the index.js file instead of the ID folder here, and therefore, of course, we also need to import use router here as well. So if we import use router from next/router, if I do that, then you will see that if I visit just/max, and therefore this index.js file, we of course only get access to the ID property here, because that is, well, just in the ID folder and not inside of this client project ID JavaScript file now. So that's how we can load pages dynamically for various dynamic parameters and how we can get access to these parameter values. And as mentioned before, in the upcoming sections about data fetching and so on, we are of course also going to leverage those dynamic values. Now, I did mention two extensions or variations of this concept here. And the nested dynamic segments, that was one important aspect of routing in Next.js when it comes to dynamic routes. The other important variation or extension is that you can also define collect all routes or catch all routes. And what does this mean? Let's say we also have a blog subfolder, and now we might have different ways of loading blog posts. For example, we could get just the slug, just the ID of a blog post. So therefore, of course, in there, we could add a file named ID.js. But maybe we also want to support other URLs for loading a single blog post. For example, we want to support /blog/ the ID of a post, but maybe we also want to support /blog/ 2020/12/ the ID of a post to only search for this post if it was released in December 2020. Or we just want to load blog/ 2020/12 to load all blog posts for that specific month in that year. So we have different URL formats which we want to support, and maybe we want to support them all with the same component. So no matter what the path is and how many segments it has, we always want to load the same component. And that's what we can do with such a catch-all route. Instead of just using square brackets and then any identifier of our choice, we can add a syntax here or a special notation here, which you might know from JavaScript. We can add 3 dots here, like the spread operator in JavaScript, and then again, any name of your choice. So that could be ID, that could be slug. I'll go for slug here. But again, that name is up to you. The 3 dots are not, though. This, of course, is no special file name from the operating system's perspective, but Next.js will treat it in a special way, just as it treats all files with square brackets in the file name in a special way. So how does it treat that file? Well, we still define a React component in there. So we could have the blog posts page here, for example, to load all the blog posts, but then we don't know if we get, for example, a path with the year and the month, or just with the year, or with a specific blog post already, or some other filter criteria, depending on what we want to support in our page. So here I'll return my good old div with the h1 tag of the blog posts, and then export this as a default. And I will already import use router here, use router from next router, so that we can look into what the next router gives us here. So therefore, I'll get access to my router by calling use router, and then console log the good old router query value again, like this. And if we now do that and save this, and we go to /blog/ 2020/12, for example, you see I do load the blog posts page. And here we get our query object with that slug property, because I chose slug as a name here after the 3 dots, but the 3 dots are not part of that property name, as you can tell. And then here we get an array now. And that's different. Before we always got a single value, a single string. Now it's an array of strings for the different segments that were caught. So here we caught the 2020 and the 12 segment, separated by slashes in the URL. But because we defined this as a catch-all path with the 3 dots here, Next.js does catch anything after blog, because we're defining this in the blog folder. Anything after blog is caught by this page component and is made available as an array through that slug property on that query object in the router object. And now we could be using these values to send a request to our database to filter for blog posts where the year is 2020 and the month is 12. And of course, you could encode whatever you want here, and you get those values. So that's how this works and how you can utilize that. And that's another important feature which sometimes can become important and which sometimes can be helpful, since it allows you to write very dynamic paths where not just the individual segment values are dynamic, but even the number of segments are dynamic. And that's not always what you need, but sometimes it is. And therefore it is important to know that Next.js supports this syntax as well. So now we built a bunch of dummy components, a bunch of dummy page components here. Of course, our application, if you want to call it like that, isn't doing anything useful though. And it's not doing anything useful on purpose, because I just want to show these core features first before we then later combine what we know to build something more realistic, to build a real application. Now, up to this point, we have all those different pages and components, but we can only navigate between them by manually changing the URL. And that's, of course, not very realistic. In reality, we typically want to navigate through links or programmatically when some action completed. And therefore, that's what we're going to have a look at right now. And for this, let's go to our main index.js file. So directly in the pages folder, this homepage component here. There, let's say we now also want to add a bunch of links. So we can add an unordered list component with a couple of list items. And then in every list item, we want to have a link to some of those pages we created here. For example, we could add links to the portfolio index and to our clients index. Now, how do we do that? Normally, we add links with an anchor tag. We can do this here as well. We could add a link like this and it would work, but this has a disadvantage. Now let's add it like this though. Let's add a link as an anchor tag. Hence, if we go back to just our domain/nothing, we see that link. If I click it, I'm taken to the portfolio page. It works, but it has a disadvantage. The disadvantage here is that with such a standard link, we in the end send a brand new HTTP request to load this new page, which means that any application state we might have on our running React app would be lost. If we have some app-wide state, which is stored with React context or Redux, it would be lost since we send a brand new request and we get a brand new HTML page. And that's not really the idea of building a React app, no matter if you're using Next.js or not. You want to stay in that app and you want to manage app-wide state. That shouldn't change just because you use Next.js. Because if that would not work this way anymore, it would actually be a disadvantage and not an improvement. So therefore, we typically don't want to use links like this. Instead, when using React Router in a non-Next application, we import a link component from React Router. And with Next.js, it's the same. For this, we again import something from Next, but now not from Next Router, but from Next Link. And we import link. Important here, not between curly braces, because link is the default export of this link package from the Next library. So we import link, and link is a component which we can use. And we can use it as a replacement for the anchor tag. So we can simply replace A with link. Now link has a ref prop, which we can set, so we don't even need to change this. And the ref prop also takes a string with the path to which we want to navigate. Now if we save that, therefore, and we go back to our starting page, if I now click on portfolio, I still go to the portfolio page, but now without sending a HTTP request behind the scenes, without losing any app state we might have. And the link component actually also has a couple of other tricks up its sleeve. It has a couple of other improvements. For example, it automatically prefetches any data off the page we might navigate to as soon as we hover over the link and so on. So these are some advanced optimizations which will become important later. Now on this link component, we can also set a couple of other props. For example, we can set the replace prop to not push this new page, but replace the current page with it, so that we can't go back. That can sometimes be useful. And we can also set a couple of other options, which we'll dive in later. For the moment, ref is the most important option. And therefore, of course, now we can add another list item with another link where we want to go to our clients. So here we could then set ref2/clients to be taken to that clients page. If we go back and reload this and go to clients, here we are. Now on that clients page, we might want to go to our individual clients. So we want to plug in a value for that dynamic ID. And therefore in index.js in the clients folder, here I also want to add a couple of links and I want to now navigate to dynamic routes. And that's what we're going to take a look at in the next lecture. So to navigate to dynamic pages, we can still use this link component, which we import from next link. We use it just as before. So here again, we can add an unordered list and add the link component and then say our first client is Maximilian. And here the ID of that client could be Max. So therefore we can simply set this to /clients/Max, for example. And then this simply is taken as a concrete value for this ID here in the squared brackets. And of course we can have a second client here, let's say Manuel, where the ID then could be Manu. And if we save that and have a look at our clients page, now we can click on Maximilian to be taken to the overview page with all the projects for this client for Max, as you can see here on the right. Or if I click on Manual, I go to the same page, but with a value of Manu for that ID. So that's how this works and how we can, of course, also navigate to pages with dynamic parameters. Now, in reality, you often need to generate a list like this dynamically. So you might have some piece of data, let's say a clients array here, and every client is an object here with an ID of Max and a name of Maximilian. And then we have another client here with a name of Manuel and an ID of Manu. So what I already have down there, but in reality, you would of course often get such data from a database, for example, and you want to generate that dynamically. You can do this as well, just as you know it from standard React, because this is standard React. Inside of this component, it is a standard React component, nothing special about that. So therefore, we can map our clients to list items just as we know it, set a key as we should, to ensure that React is able to fully understand this list and update this list efficiently, and set this to client.id, for example, since that is a unique identifier. And then in the list item, we can use our link, and between the link tags, output client.name, and for the link, set a ref, which we also set to a dynamic value, where we, for example, use backticks to create a template literal, to set this path to /clients/ and then inject a dynamic value here, which is client ID. So with that, we render a bunch of list items with a bunch of links where inside of the link, as a text which is visible to the user, we output the client name. And as a value for the target, for the destination of that link, we create a string with a template literal by having the hard-coded /clients part, and then the dynamically injected client ID, which is different for every client we're looping through. Hence, with that, if we save this, and we go back to our clients page, it looks like before and it works like before, but now that list is generated dynamically. And that works just as you know it from standard React. So now we know how to use the link. Now for longer paths, constructing a link destination like this, so by building a string like this, can be cumbersome or annoying. That's why Next.js also gives you an alternative an alternative value you can provide for the ref prop on the link. Instead of providing a string, which is the path you want to go to, you can provide an object. So now this is not a special double curly brace syntax, this is still single curly braces to evaluate a JavaScript expression, and the expression here then just is a new object which I'm creating. And here, that's a special kind of object Next.js expects as an alternative to a string, as a value for the ref. And here we can set various properties Next.js is expecting. For example, the path name property, which here would be /clients/ and then important, ID in square brackets. So we describe the path as it would lead to our file in the pages folder. So here we want to go in the clients folder, and then into the ID folder with square brackets around ID, and then to the index.js file, but as you learned, that is then the default file Next.js will be looking for, hence the path name here is /clients/square brackets ID. And then we need to let Next.js know what the concrete value should be that should be plugged in for this ID here for this link which we're building. And we do this through the query property, which we can set in this ref object. And that then is an object, just as it is when we retrieve it with useRouter. There, query is also an object we can retrieve to have key value pairs, where the keys are our dynamic segment identifiers and the values are the concrete values entered. And it's the same here when we define a link. We then have a key, which is our dynamic segment identifier, so ID in this case, and then the concrete value for this concrete link which we're building here. So in this case, client.id. And that is then an alternative way of building that link. Now it's totally up to you if you prefer this over creating a string or not. This is totally up to you, but you can build it like this. And if you then save this and reload, you still have the client's page with those working links. And I'm just showing these alternatives so that you know all these different ways of using Next, and in this case, of using the link component. So now we learned about links, which allow us to navigate from A to B. Sometimes you need to navigate programmatically, because a form was submitted, for example. And I want to show this as well. So let's say on the page for a specific client, we now also have a button. And when this button is pressed, we want to load project A for this client. Now we could absolutely use a link here if we just want to have a clickable thing that navigates somewhere else. I'm just using this here, this button here, to show how you could navigate imperatively. Typically, of course, you would not do that to replace a link, but to navigate in code when some action completed, when you parsed a form that was submitted, for example. But here, to learn how imperative navigation works, a button will do. So we have this button, and when the button is clicked, we want to navigate away. So therefore, first of all, we can define another function here in this component function, so a nested function, which should be triggered when the button is clicked. So the load project handler function, for example. Now we want to assign this function to this button here, and we do this through the onClick prop. Again, that is just standard React, nothing Next.js specific. Now in this function here, we might be doing all kinds of things, load data or anything like that. And once we're done, we want to navigate away. So when we do need to navigate in code, like we do here, then we can again use this router object, which we get from useRouter. And this object has a couple of properties, a couple of values we already saw before, but it also has a couple of methods that help us. For example, it has the push method to navigate to a different page. So using router push is like using the link component, just programmatically. And therefore here we can then go to /clients/max/project A, for example. If we now save this, and I go to Maximilian page and I click on load project A, I'm taken to /clients/max/project A. So that's how we can navigate programmatically. If we use router replace instead of push, then we replace the current page with that one, which means we can't go back after the navigation. And we can also not just pass in a string here, but again, just as before for the link, we can also pass in an object here where we then set a path name to /clients/ID /client project ID to encode these two dynamic segments into this path. And then set our query object to a nested object where we provide a concrete value for ID, in this case max, and a concrete value for client project ID, in this case, let's say project A. And that would simply be an alternative to creating or using a string. And if I do that, and I go back and reload, if I click load project A, that still works. So that's how we can navigate programmatically, which is also sometimes required, especially, as mentioned, for example, after submitting a form. Now, to conclude this module, there is one last special page I want to have a look at, and that's the 404 page. If I enter something here, then I get the 404 page and a 404 error because we're not supporting that value, we're not supporting that path. Now, of course, you might want to ship your own 404 page with your own content and style. And Next.js makes that easy. You just need to add a special file in your pages folder. So on the root level of your pages folder, next to this _app.js file and this index.js file. And here in this folder, we now want to add a 404.js file. And it must be named like this because Next.js will then always load the component returned by this file or exported from this file when a 404 error arises. So here we can have our not found page. And in there, simply return a div where I say page not found. And of course, the content is up to you. And then here, I export this. And by doing that, by adding this page, this special file, if I now reload localhost 3000/something, I see my custom not found page. So that is how you can customize that. And that is it for this course section. We now had a detailed look at file-based routing and how we set up pages and how we navigate between pages with Next.js. We had a look at the pages directory and that the files and folders in there have a special meaning. Index.js is always treated as a root page for the given folder, so either the overall root page, if it's an index.js file in pages, or in portfolio or other subfolders, index.js would be loaded for /portfolio/nothing. We also can have other file names to, for example, load /portfolio/list and then load this list page component. And we can also have dynamic segments by enclosing placeholder identifiers in square brackets and then loading different kinds of data for different concrete values we might be getting. And we get access to the concrete value entered for a path segment through the useRouter hook, as you learned. Now we can also have nested dynamic segments, as we did with clients. And we can also have such catch-all files here by having square brackets and then 3 dots in front of any identifier of our choice. And that allows us to catch multiple dynamic segments in one go. And all these are very powerful features for loading pages in exactly the way you need. Now for navigating around, we want to use the link component provided by Next.js, or if we need to navigate programmatically, we can do that through that router object, which we get through useRouter, or in class-based components through the withRouter higher order component. And therefore, we now know what file-based routing is and how that works. But is that now better than the code-based approach we know from standard React projects that do not use Next.js? Ultimately, that is of course up to you to decide, but I want to give you my perspective on that and a small comparison I came up with. When we compare file-based routing, which we get with Next.js, to this standard code-based routing we have in standard React apps with React Router, then in the case of file-based routing, we have no extra boilerplate code that needs to be written. So this kind of route configuration, which we need to write in our React components when using React Router, that is not required with Next.js and the file-based routing system. Instead of writing this boilerplate code, we simply create component files, which we would need to do anyways, and we just store them in a structure that replicates the path we want to have in our URL in the end. And that, in my opinion, is a very natural way of, well, setting up our page components and of storing our page components. So therefore, we do something we need to do anyways, and we save the other part of creating extra code just to tell React which component should be loaded for which path. We combine that into one step instead. Therefore, in my opinion, that's a very intuitive system of creating components and of storing components and of setting up routing. Therefore, we don't need to do anything for that. We get the routing for free, if you want to call it like that. So with file-based routing, the file and folder structure we have is everything. That influences our routes, and we therefore fully control the paths we support in our application through our folder structure in that pages folder. Now, for navigating around, we use a link component, and we can also navigate imperatively, so there's nothing special about that. Now, for code-based routing, we do have that extra boilerplate set up in code. Though, of course, you could argue that by doing that, you have some code where you can see which routes are supported. You don't need to look at the file system, though I would argue that looking at the file system wouldn't be too difficult. But of course, ultimately, that's of course up to you to judge. Now, it is definitely straightforward, don't get me wrong, but it includes new components and concepts which you need to learn, like that switch component and that route component, and how to order your routes, and so on. So that can be annoying. Now, a potential advantage, of course, is that the file and folder setup does not matter at all. In my opinion, having the folder structure dictate the paths is an advantage, but you could see this as a disadvantage as well. And with code-based routing, you can store your component files wherever you want. They won't have any influence on your routes or your paths. Now, navigation works pretty much as it does with Next.js. You have a link component, and you can also navigate imperatively there, so no differences there. Therefore, overall, in my opinion, file-based routing is more intuitive and is easier to set up, but it is of course up to you to judge. Either way, it is how Next.js thinks about pages and routes, and therefore when working with Next.js, you want to embrace that file-based approach. Now that we did learn about one of the most important Next.js features, the file-based routing, it is time to practice what we learned. It is time to apply what we learned in theory to a small demo project. And therefore now it's project time. We're going to apply what we learned. Now in this course section here, we are going to build this little events app where we can browse a list of events, where we can then select a single event, and where we can also filter for events. And we're going to build that with Next.js, of course, and with what we learned thus far. Therefore, in detail, we are going to create this complete project from the ground up together, step by step, so that we really get that practical experience with Next.js. We are going to add both static and dynamic routes to this project because we will need both. And we are also going to add regular React components, so non-page components to this project, something we haven't done thus far. We didn't add normal components in the last course section. Now we are going to do that, and we are going to connect everything. And therefore, of course, the primary purpose of this project is to practice what we learned, but you will also learn a couple of new things. For example, where to store regular React components. And hence, I definitely recommend that you follow along and go through that project together with me. Of course, if you're feeling super fancy, also definitely pause from time to time and try out the next steps on your own. But with that, let's dive right in and let's create and plan our project. So let's get started with that project. And for this, again, attached you find a starting project, which I did create through the command line as shown in the first course section. But again, it's a slightly cleaned up starting project, which simply ensures that we all start with the same foundation, with exactly the same starting point. So download that attached project snapshot and then open up the terminal, navigate into this project folder. You are already navigated there if you use the built-in terminal in Visual Studio Code. And then run npm install to install all those third-party packages which we need, like Next.js, for example. And with that, we're ready to go. But before we write any code, let's plan our project and let's plan which pages we need, for example. Now, this project will only have 4 routes. But with those 4 routes, we are going to practice all the things we learned in the last course section. We will need a starting page, of course. So for our domain /nothing, I want to reach the starting page, and on that starting page, a list of featured events should be shown. And keep in mind that we are building an application where we show events, where users can browse events, and where they potentially in the future might also be able to book events. That's not the focus of this first demo though. But therefore, of course, we want to show a list of events which users can take a closer look at. And therefore, we want to present such events on the starting page. And in the data which we'll use, we'll basically set a flag determining whether an event is featured or not. And if it's featured, it should show up on that starting page. But therefore, we'll also add a /events route, so our domain /events, which should load a different page, a page with all events. So here we then list all the events we currently offer in our application. Now, of course, users hopefully then also click on some event to get more details about that event and to potentially sign up for it and book it. And therefore, we will also add an events detail page for /events/ and then some dynamic ID. So that will not be hard-coded. Instead, that ID should be dynamic so that we can load the same page, the same detail page for different events and show data about that selected event. And last but not least, I also want to add a feature where users can filter events by year and month. so that I can not just see all events or just the featured events, but that I can also search for all the events that take place in May 2021, let's say. And therefore we'll add another route, another page with such a dynamic slug segment, which will load the filtered events page, where we then show all the events matching our filter here. And we're going to build all these things together in that project. But as I mentioned, of course, also feel free to not jump into the next video immediately, where we will get started with all of that together, but instead try setting up those pages, those routes on your own, even if you don't add all the other logic yet, but try creating those route files on your own and add some dummy data, some dummy output to those page components. And then once you did that, move on to the next lecture where we will build this together. So let's now implement those pages, those routes together. And for this, of course, we go to this pages folder, and in there we can add a new file for our root page, for our home page, so to say, the index.js file. This will then hold the component that should be loaded if we visit localhost or whatever our domain is, /nothing. And therefore in here, I'll add the homepage function, so a functional component, which I simply name homepage. And of course, we also want to export this as a default. We need to do that for Next.js to find that component. And then in there, we return the JSX code that belongs to this component. And for the moment, I'll just return a div here with a h1 tag where I say the homepage. But in this course section, unlike in the last course section, we are also going to add more output and more logic to our application. So we'll not stick to such dummy output. But for the moment we will, and we will continue adding the other routes. Now we also need a route for all events, and then for that slug, so for consuming all dynamic segments, and for a single dynamic segment for a single event. Hence we can add an events.js file for our events page, which lists all events, or alternatively, instead of adding that file, we add an events folder in the pages folder, and in that folder, we then add an index.js file. And that's the exact equivalent to adding an events.js file. And I will go for this approach also because we'll need that folder later to set up nested routes for a single event, for example. Because keep in mind that for a single event, for that event detail page, I want to have /events/some dynamic segment. So for that nested route, like for all nested routes, we will need this subfolder, this events subfolder. Otherwise, we won't be able to set up such a route. Hence, we'll need that events folder anyways, and therefore we can already create it for the all events page as well. So in there, we add another functional component, and I'll name it all events page. Of course, those names are up to you though. You can name your page components however you want, but I'll go with this name and then return another div here where I say all events. Again, that's just some dummy content. We'll replace that with actual output and some logic later. Now, two more routes, two more pages to go. And the first one will be the page for a single event. So when we selected an event for displaying all the detail information for this event. Now we want to select that event dynamically by ID, and therefore the page should have a dynamic segment in its URL, so in its path. And you learned how that works. We set up a file with square brackets in the file name, and then between the square brackets, any identifier of our choice. For example, ID, or simply event ID, whatever you want. And I'll go for event ID written like this, within capital I, so that I can then later extract that actual event ID from the router, from the query property, as you learned it, by that key, so by using that key. And hence in this square bracket event ID file, we add the event detail page. And we of course also export that page, the event detail page. And then here for the moment, I'll also just return a div where I say event detail. Now the last page, the last route I want to add therefore is this slug route. So which consumes all segments, even if that would be multiple segments after, in this case, events, because I'll create it in the events subfolder. And for this, the syntax also is to use square brackets. But then We also add free dots like the spread operator in JavaScript or the REST parameters syntax from JavaScript, and then any identifier of our choice, for example, slug. But again, that's just something you will see quite a lot, slug, but you can of course use any identifier you want. Now you might think that this maybe clashes with the event ID, but as long as we enter more than one dynamic parameter after /events, it won't. And that's exactly how we're going to use that. If we just have /events/something, so just one segment after /events, then the slug will not kick in. Instead, this event ID route will then handle such a request or such a URL in the end, as you will see throughout this section. So therefore here in this slug file, I'll name this filtered events page, because here I want to show a list of filtered events, and then we can export this here as well. And of course, in the component, also return some dummy content here, filtered events like this. And I did spend a lot of time explaining this, but these are of course some key features of Next.js, so I want to make sure that we're all on the same page regarding them. Now with all of that, we can start the development server with npm run dev, and this will now start it up, and we can now open the browser and visit localhost 3000, and we see the home page. Now if we visit localhost 3000/events, we see the all events page. If I enter /events/ let's say E1 as a dummy event ID, I see the event detail page. And if we try out this slug concept, and we try to filter for events that take place in 2021 and then May by adding the segments /2021/05 after events, I see the filtered events page. Of course, it will be our job throughout this section to make sure that on that filtered events page, we then extract the actual segment values from the URL and then find appropriate events. But that's exactly part of what we build throughout this section. And therefore with that, we now got the basic setup we need. Now we can gradually start filling that with life. Now to fill that all with some life, we need some data. We need some dummy events. Now later in this course, we will learn how we can fetch data from a database or from the file system, but we haven't learned about this yet, and therefore for the moment, we'll just use a dummy JavaScript array as a data source, but again, that will of course change throughout the course. Nonetheless, for the moment, attached you find a dummy-data.js file attached to this lecture, and you can download this file and add it to your root project folder. So here I added dummy-data.js to my project, next to the package.json file, and this is a file with an array of dummy data, which I prepared for you, and with some functions that allow us to query that data. And I'll dive into those functions once we start using them. Now in that dummy-data.js file, this dummy data, which is set up there, also uses some images. It also needs some images to be part of the project to then later correctly display our events. And therefore, you also need to add a couple of images to your project. Now for that, you can use any images you want. Just make sure that you do store them in the same folder I will store them in a second, and that you give them the same name. But you can then use any images you want. A great source, if you don't know where to get images from, is unsplash.com. There you can get free images, and that is where I will collect a couple of images. For example, if you search for programming, I'll use this image from James Harrison. And in my project, in the public folder now, I'll add an images subfolder and download and store the image in there. This coding event JPEG file now. And make sure you name your file also coding-event. So download any image you want, maybe also this one, but name it coding-event and store it in the images folder. Or if you named it differently or have a different extension, go to the dummy-data.js file and adjust this image path appropriately. So the image name and extension. And with that, I'll collect 2 more images for my other 2 pieces of dummy data. For the next one, I'll search for introvert, because the next event is about introverts, just so that you don't have a strange impression of me. And here, I'll pick this image from Ahmed Nishat, and you can download this one as well, and store this in the images folder. In my case, under a name of introvert-event.jpg. Again, if you have a different name, adjust it in the dummy-data.js file appropriately. And last but not least, you can search for networking on Unsplash, And then you might also find the same image I'm using here, this image here about a networking event as it seems, which I now also downloaded and stored here. But again, you can of course use any images you want. So now we got the dummy data and we got the images set up. And it's important that the images are stored in the public folder. It doesn't have to be a folder named images then. It can be any folder or directly in the public folder, but you should store them in the public folder because the public folder also is a special folder in Next.js projects. Whatever is stored in there, typically images or fonts or something like this, is then served statically by Next.js, which means you can reference it in your CSS code or in your HTML code. You can easily include images stored in the public folder because Next.js will make sure to serve any content that's stored in the public folder as part of your overall application. So it will statically serve any content in there. It makes the content in there available to the visitors of your website, and therefore you can easily then embed public content in your HTML code and so on. And we will utilize that throughout this course. Therefore, now we got the images and the dummy data in place. Let's now start working on those page components and let's fill them with some life. Now let's start with the home page. The goal here is to show the featured events, and therefore here we want to get all featured events. For this, in the dummy data.js file, I did prepare a get featured events function which is exported, which accesses the dummy events array and then filters for events where the isFeatured flag is set to true. And all these event objects do have a isFeatured flag, which is either false or true. Hence here, we can now get all our featured events by using this getFeaturedEvents function. Now for this, you need to import it from dummy data, of course. You need to import getFeaturedEvents from dummy data. So call getFeaturedEvents, it's a function, so make sure you execute it and store the result in a featured events constant. And now that we got the featured events, we want to output them down there. Now for this, we can add an unordered list here where we loop through all the featured events, but I will actually create a brand new standard React component for that. Because it is generally a good practice to split your application and your JSX code into multiple smaller building blocks, into multiple components therefore, and then combine those components to compose your overall application from those components. Hence, we want to add a regular React component, and the question now is, where do we store such a component? That is generally up to you, but it should not be in the pages folder. In the pages folder, you should only have page components, because whichever files you create in here, those files will then automatically lead to routes being generated. So Next.js will pick up any files stored in pages and generate routes for them. And for the regular components, we don't want that. A list component here should not be reachable through a route. Instead, I want to use it in the JSX code of some other component, of this homepage component, for example. And therefore, you don't store regular components in the pages folder, but instead we create a brand new folder, for example, one named components. But you can use any name you want, but components is a name that of course makes sense, I would argue. Now in there, I will add an events subfolder where I want to store all my events related components. And then in this events subfolder, I will add a file, an event list.js file, which will hold the event list component. Regarding the file naming, it's up to you how you want to name this. You will also often see a file naming convention like this for JavaScript files that hold React components. For example, I use this notation in my React course. In Next projects, I often saw this notation, so all lowercase cap uppercase, and therefore I will stick to it, but it is totally up to you. There is no best practice or a bad way of doing it. You can name those files however you want. And now in the event list.js file, I want to set up my event list functional component, which will be responsible for rendering a list of events. Hence, it will use props because those events should be passed in from outside so that we can reuse the same event list component on the home page, where we then have some featured events, and on the all events page where we have a long list of all events. The event list component shouldn't care about where the events are coming from, but it should only care about outputting the events. Hence, it receives props so that the actual event items are passed in from outside, from the place where the event data is fetched. Hence, in here, I just in the end want to return an unordered list with all those events, and then simply expect that on the props, we get our, let's say, items prop. And I'm using object destructuring to pull that prop out of the props object. Of course, you don't need to do that. You could also just write props.items down there. I used object destructuring, so I will just write items, but that's up to you. Of course, the key here, the key name you use, is also up to you. It doesn't have to be items. That's just a name I will be using here, but since it's your component, you can name this however you want. So then we have those items, and now we want to map through them to output multiple list items. So to map our item object data, which has this shape here, into a list item, into a JSX element. And therefore, we go through all the events in the end, we pass an anonymous function to map, and then create a list item for every event we're getting here. Now, before we continue working on that, I will export this event list component, and I now want to create a brand new component which actually defines the JSX code for such a single event list item. So therefore, I'll add a new file next to the event list JavaScript file, and that's the event item.js file. Now again, the file name, of course, is up to you. And in here, in this file, I'll add a function, event item. I also expect some props here, because the concrete data for a single rendered event item also should be coming from outside of this component here. And of course, we also want to export this event item. And now in here, I want to return a list item and then set up all the HTML code in the end that defines how such an event item should be output. We'll work on that in a second. First of all, in event list.js, we can now import event item from ./event item, so from that file we just added, and then map our events to event item objects like this, so to event item components in the end. And now we need to pass some data into event item, the event data we're getting here in the event list component, and in event item we then define the JSX structure for this. And that's what we're going to do in the next lecture. So let's now work on the HTML, the JSX code of an event item. Now here you should follow along closely because I will also provide finished styles to you in a second, and those styles will only do their job correctly if you have the same HTML code. So therefore make sure you follow along closely. Of course, you can also always use the code snapshots you find attached to the last lecture of every module to compare your code to mine in case you have some deviation somewhere. And therefore, let's get started. I want to have an image here, an image element in every list item where we display the image of a chosen event or of a rendered event here. So we'll need to set up a source here and some alt text, and we'll work on the data in a second. For the moment, let's just create the HTML code. And then below that, I want to have a div below that image. In there, I want to have two more divs. And in the first div in here, I start with a title, an h2 element here, where we output the title of that event. Then below that, another div where I want to add a time element, which is a regular HTML element, where the time or the date should be output. And also then below this div, another div where the address should be output. For this, we can use the address HTML element, which is also a regular element, where we will soon render the address. With that, we can move on to the other main div, which we added side by side to this first div. And here in this div, I in the end want to have a clickable link. So for this, we can use the link component, which we need to import. We import link from next link, as you learned, so that we can set up a link that takes us to another page. So here we'll then need to set up the URL, the path to which it should navigate. We'll do this later. And then as a text, it could say explore event. That's the general markup, the general HTML code which I want to use. Now, of course, it's lacking the concrete data though. So for this, we're getting props because that data should be passed in from outside. And I'll again use object destructuring to pull out that data from the props. And I do expect that we get a title, that we get an image, that we get the date and a location and an ID. Of course, we could also just expect one event prop and pull out the data from there, but I expect multiple props here. You can, of course, expect whichever props you want. So now we got that, and now here, for example, we can output the title constant here, which we get from props. Now for date and address, I don't just want to output the data like this. Instead, I want to transform it a little bit first. For example, I want to set up a human readable date. And for this, I'll create a new date object and pass date to it, because date, as we're getting it here, will have this format, which is kind of human readable, but not really pretty. But thankfully, that is a format which we can pass to the date constructor to turn it in a JavaScript date object. And on such a date object, we can then call toLocale date string and then transform this into a human readable date string. The first argument here is the locale we want to use, and I will use enus. And the second argument then is an object where we configure how the different parts of the date should be output. For example, that a day should be output in numeric format, month should be output in a long form, and year should be output in numeric format as well. Now, if you want to learn more about this toLocale date string method, you can of course search for MDN toLocale date string and find the kind of official docs on that. And here you learn how that works and which other options you would have when it comes to configuring the output. The configuration I chose here should work really well though, and therefore now here instead of date, I'll output the human readable date like this. Now for the address, I also want to format this, and I'll create a formatted address where I use the location, so this location prop we're getting, this one, and then on that I call replace, and I replace comma whitespace with \n. Now all the locations have such a comma in there to separate the street from the postal code and city, and I'm simply replacing that with \n, which adds a line break. So that's what I'm doing here. And therefore now we can use this formatted address down there. Now we'll need to add some styling for this line break to have an effect, but we're going to do that later as well. Now we also have an image, of course, which we want to set up here. And the image is just a string in the dummy data, which is a path to an image which we added locally here. So we have that images/image name path in our public folder. That's why you should make sure that this image path and name matches your path you added your image in. But now that we do have this link here, we now can bind source to / image. Image is our prop here, and image will be a string like this, and I'm just adding a / at the beginning. And since all the content in the public folder will be served statically by Next.js, this request to /images/image name will succeed. We don't need to add public at the beginning here, so it's not /public/, but just /, because it's the content of the public folder which will be served statically. So public should be excluded because we don't need to dive into that folder first. It's the content of the folder which is being served by Next.js. So we can navigate as if we already were inside of that folder. Now for the alt text, I'll use my title again. With that, we're almost done, but we also want to wire up that link address, that link target here. And for this, I want to construct a link which takes this ID into account. I'll add a new constant here and name this explore link. Of course, this name is up to you. And here I'll use a template literal and start with /events/, and then inject something dynamic into this string. I'll inject the ID, the value which we get on the ID prop here. So that explore link is a string that includes that ID, and then it's this explore link which I bind here as a value to ref. And then with all that done, this component lacks styling, but is generally ready to go. So now in event list, we need to pass all that data, which is expected by event item. We need to pass those props into event item here now. So here I add the ID prop and pass in event.id. I add the title prop and pass in event.title. We add the location prop and pass in event location, and so on. Do the same for the date with event date, and the same for the image with event image. And then since we're mapping here, and since we're creating a list of items, we should also set the key prop, which is not expected by our component, but by React, whenever you output a list dynamically. And here we pass in event ID as well, since that will be a unique identifier per list item. And now with all of that, we can use this event list component in our starting page component, so in the home page component. For this, we import the event list component from going up one level, diving into components, events, event list. And then here, instead of this unordered list, we can simply output event list like that. And now, last but not least, we just need to make sure that we pass in items to event list. So here in the homepage component, we set the items prop and pass our featured events into event list. And if we now save all files and reload, I get an error, numeric is not defined, because an event item, that should also be a string wrapped by quotes. Now if I save this, now we have a large image here. And yeah, if we scroll, we see the data is there. But of course, it's lacking styling. And that's therefore what we're going to work on next. How do we style our next application? How do we style our components? Generally, that is totally up to you. Next.js supports styled components. You can use regular HTML code with regular selectors, classes, and so on. And you can also use CSS modules. And the support for the latter is actually already built into a Next.js project. Now that is what I'm going to use here, so that we have scoped CSS styles, scoped to specific components, at least if we want to, but you can definitely also explore other approaches for styling components. Now you will notice that we have this styles folder here, and in there we have a globals CSS file. Now here I set up some global CSS styles for you, and as I just said, you could of course add more classes here and then simply, set up any styles you want here. And you can also add more CSS files and, for example, import them in this app.js file where we are also already importing globals CSS. We haven't really learned what the role of this app.js file is, but for the moment you can keep in mind that here you could definitely import all your global CSS files. But I want to be able to scope styles to components, and therefore I will use the built-in CSS module support. Now, in case you don't know, CSS modules is all about setting up CSS code, which is then bound to a single component. So it does only affect that component and no other component. And that's a nice little feature which ensures that our styles don't spill over to other components. Now, therefore, I will create a separate CSS file for the event item component, a CSS file where I will define the styles for that component. And I could create that CSS file in the styles folder and import it from there, and that would work. But I will create it next to the event item.js file so that component code and component styles are located in the same place. That is a convention I like to follow. It makes it easier to find the styles for a given component. Therefore, here we add a new CSS file. We could name it event item, but to unlock this CSS module feature, this file actually has to end with .module.css. So event-item.module.css. The part here, event-item, that's up to you. That does not matter. But the ending, .module.css, that is important. Now with that, we can save this file, and now in event-item.js, we can import this file. We can import a CSS file into a JavaScript file, and behind the scenes, the Next.js build process will take care about that. It will basically extract the CSS code, change the selectors a little bit to scope them to this component HTML code, and inject it into the running page. We don't need to worry about that. We just need to import our CSS file, our event-item.module.css file. However, not just like this. Instead, we import classes or styles, the name is up to you, I'll go with classes, from event-item.module.css. This is required for using this CSS modules feature. This classes thing here will be an object where all the CSS classes we define in this CSS file will be exposed under their class names so that we can assign them to HTML elements. This is required because the CSS class names we will add in this CSS file will be transformed under the hood by the build process to make them unique for this component. I also do talk about that in my React the Complete Guide course, in case you want to dive a bit deeper. Therefore, we import classes from this CSS file, And then we can, for example, go to our list item here, add the class name property, the class name attribute, and set this equal not to a string, but instead to a dynamic value, specifically to some key we get from this class's object. And here that should be the item key. Now in the CSS file, we can add an item class selector. So that name here has to match that name, which we're accessing here. And now we can define the styles in here, which will be applied to only this list item. So even if we would use the item class here, let's say in the event list component, if I would add this kind of class name here, even then the style setup here would not affect this one here, this unordered list item. Because with the CSS modules feature, the class name we assign here in the CSS file will be changed under the hood behind the scenes, and it will no longer be item once the application runs in the browser. Therefore, to get this magically changed file name, we get access to those transformed class names under this imported classes object, and we then access our originally assigned class name and get access to the actual transformed class name and assign this as a class name to the list item then. This sounds confusing? Let me show it to you. If we temporarily give this a color of red, so if that's the style we assign, and we then save all the files, if I now reload and I then inspect this here, you will see that this list item has a class of event-item _item _ some unique hash. And that's not the class name we defined in the CSS file. Instead, that is this transformed class name, and the link is made through our assignment of classes.item here. So that's now working under the hood, and it allows us to scope our CSS styles to a selected component. Now with that, attached you find two CSS files which I prepared for you. Because this course is no CSS course, I don't want to bore you with writing CSS code, and therefore attached you find the event-item.module CSS file and the event-list.module CSS file. And you should replace your event-item.module.css file with the attached one, and also add the event-list module CSS file to this events folder in this components folder. Then, back in the event-item.js file, we now need to assign more CSS class names. We should add classes.item on the list item, so on the li element, but then on this first div here, you should also add a class name of classes.content. Then on the div in there, add a class name of classes.summary. No class name on the h2 tag. On this div here, we add a class name of classes.date. No class name on the time element. On this div here, we add a class name of classes.address. And then here on this div, which holds the link, we add a class name of classes.actions. So these are a couple of class names we assign. And now we also need to go to the event list component and add some styles there. For this, in this event list component, we first of all also need to import classes from /event-list.module.css. And then on the unordered list item element, we add the class name prop and set this to classes.list. Because in this CSS file which I provided to you, there is a list class defined. And then with that, you should see that if you now reload, you have something like this on the screen. Still not the final look of everything, but a good step closer. Now, as a next step, let's work on this link and let's add a couple of icons. Let's continue working on our project here, and let's continue with this link. At the moment, it looks a bit boring, and I would like to have that link look like a button. Now, we'll also use a button in some other places of our project, and therefore, instead of styling it here in the event item component, I'll add a new component, which we can then reuse, which I'll add in a new folder, which I'll name UI for user interface. And in there, I'll add a button.js file to create a button component in there, which sets up this button so that we have a reusable button. For this, in this button.js file, we create a button component like this, a functional component, which we of course also export. And then in here, I will return a link. And for this, we need to import link from next link. And that link should, of course, hold a text which is passed in from outside, so between the opening and closing tags of our button component. Hence, we can use props children here. And of course, it should also lead somewhere, and I expect to get a link prop on this button, which holds the actual link we want to go to, and set this as a value for the ref prop here. Now we got this button component. Attached, you now find this button.module.css file with some styles for this button. And just as before, to apply them, we now need to import classes from /button.module.css. And then to add those classes here, we need to actually add an element inside of the link component. We need to add an anchor tag element. And then on this anchor tag element, we can set the class name and set this to classes.button. Now, if we don't add the anchor tag, then the link automatically renders an anchor tag under the hood. An anchor tag where it basically controls what happens when that link is clicked though, so that we don't send a request for a new file, but instead it captures that request and loads a new page with JavaScript only. But if you want to apply custom styling, then you need to add that anchor tag on your own. And the link component will basically detect that there now is an anchor tag inside of it, and it will no longer render its own anchor tag, but instead render yours, but then add all that functionality where it captures clicks on that link and so on for you. So it will add that functionality, that all works. We just add our own anchor tag to add classes. We don't, and that's important, we don't set the ref attribute on this anchor tag though. As I just said, that will be added automatically by the link component, which is wrapped around that. So we just set it up like this. And now we can use this button component in the event item component. Here, instead of this link, we can now use our own button. And of course, for that, make sure you also import button from the UI folder and the button file. And then here we can still say explore event. And now we set the link prop on the button component, because that's what I'm expecting here. I'm expecting a link prop. And I set this here equal to the explore link, just as before. And of course, this button technically now isn't a button but a link, but it will look like a button, hence the component name. If you now save all files, you should have this button look here. Now, adding a button was one important thing. I also want to add a couple of icons to ensure that the event items we're rendering look a bit nicer. For this, I prepared some icons for you, some icon components which you find attached. To be precise, attached you find an icons zip file which you can extract into your components folder, so that you end up with a third folder in the components folder, this icons folder, which holds free JavaScript files, which hold React component functions, which return SVG icons. Now, these icons are not created by me. I'm just sharing them with you so that we don't have to write that code together. Instead, these are icons from heroicons.com. Here, I picked this location marker icon, I picked the calendar icon, and this arrow right icon. These icons are taken from heroicons.com, and I just pre-created these components for you so that we don't have to write all that code together. But I just copied the JSX code from heroicons.com. It's super easy to do. You even get a button for that here, and I created these components. Now, with these components added, we can go back to eventitem.js, and there I now got a couple of places where these icons should be inserted. For example, here in front of the time. There, I want to render the date icon, so I'll add it here, and we now need to import it. We need to import date icon from, and then go up one level into icons, date icon like this. We can now also remove the link import, by the way, since we're not using the link component in this component anymore. So that's the date icon added. Above the address, I want to add the address icon like this. And for that, you, of course, also need to add the appropriate import. And we can also already import the arrow right icon from icons arrow right icon, because I will render that in my button. Here in this button, I don't just want to have this explore event text. Instead, this text should sit side by side to an icon. Hence, I'll wrap this text in a span, and then add another span here. And in that second span, I'll render this arrow right icon, which I just imported. And this second span, important, also receives a class. It receives the icon class, like this. Again, if you save all files and you go back, you now should see these icons as part of these event cards here. And that is now the final look of the event items. We spent quite some time on them, but we will use them in a lot of different places of this application, and therefore that is of course something which I did want to make look good. Now let's work on the other pages, because thus far we never left the starting page. And we got more pages. For example, we got the page for a single event. And we can reach that page for a given event ID if we click those buttons, the Explore Event buttons. That sets the URL to /events/ID and loads the event detail page. So time to work on that. And of course, feel free to start working on that on your own, output some event data there. In the next lecture, we're going to work on it together. And we're then also going to add some styles together, of course. So let's work on this event detail page now. We reach this page if in the URL we have something like events/ and then some event ID. So the goal is now to output the detailed data about this event. And for that, we of course need to fetch that data. Now we do have our dummy data array with all the events, and now we want to get an event by ID in the end. Now for this, I did provide this getEventById helper function here, which finds an event by ID, and hence we can call this function and pass an ID to that function to get an event by ID. That means that in the event detail page component, we now just need a way of getting hold of that ID, which is part of the URL. And you'll learn how that works. We can use the useRouter hook for that. We can import useRouter from nextRouter, like this, and then call useRouter to get hold of a router object provided by Next.js. And then you learned that on that router object, we can get access to a query property, which has all those dynamic path segments that led to this page as keys. So here we have event ID with a capital I as a name for this dynamic path segment. Hence on router.query, we can access event ID. This gives us access to the concrete value that was inserted in the URL when this page was loaded. So in this case, for example, it would be E2. And therefore this now is the event ID we're looking for. Now we can call getEventById, and for that we need to import that from the dummy data file, so make sure you add that import statement. And we pass the event ID as an argument to that function. And that will give us the event we're looking for. At least hopefully. Of course we could fail. If I, for example, manually enter something like test here, then we would not find an event for that, because in my dummy data, I have no event with an ID of test. So we should handle that case and check if event is maybe falsy by adding an exclamation mark here, in which case I want to return some error message that we didn't find an event. For the moment, I'll just return a paragraph here where I say no event found, just like that. But if we make it past this if check, we know that we did find an event, and now we want to return and output data for that event. And for this, of course, it's totally up to you how you want that page to look like. I prepared a couple of components which we can use for outputting that event detailed data. Now, these are regular React components, and I don't want to bore you with writing them, therefore you find them attached. Attached, you find an event-detailed zip file, which you can extract into your components folder. So that in the components folder, you have that brand new event-detail folder. In there, you'll find 4 component files, which in the end output some content, and also some styles for those files. Now, again, you can definitely go through them. This is all just standard React code, nothing Next.js specific in there, which is why I'm skipping this component creation, because in this course, whilst we of course also talk about React in general, I of course also want to focus on Next.js as much as possible. Therefore, these components are pre-built for you, and we can now use those components in this square bracket event ID file. Here, I'll replace this overall div with a fragment which we import from React. So you need to add this import to use the built-in fragment wrapper component, which is needed if you have adjacent JSX elements, because normally that would lead to an error. With the fragment wrapper, you are allowed to have adjacent elements. And then here I'll start by adding the event summary component. Now that's one of the components I provided to you, so we need to import event summary here from going up one level and another level, diving into components, event detail, and then there's this event summary file. And from that we import event summary. And whilst we're here, we can already import another component, the event logistics component, from going up, components, event detail, event logistics, and import the event content component from going up, components, event detail, event content. Now with those components imported, down here we output event summary, event logistics, and event content. Now between the opening and closing tags of event content, we pass in a paragraph, which then receives event.description as a value. And event is this event we're fetching here from our dummy data by ID. And now we're accessing the description key to output that description text between the event content tags. Event summary needs a title property. You see that if you have a look at the component. Here I want the title property. So we pass in a title, and that is event.title therefore. And for the event logistics, there we need to pass in the date, the address, the image, and the image alt tag. So here I'll pass in event.date, then pass in an address prop, which has a value of event.location, pass in the image prop, event.image, and the image alt prop with event.title as a value. And just as before, you can of course have a look at event logistics and you see which props I'm expecting here and how I'm using them. In the end, the date is in the end just getting transformed again, same for the address text. And then I'm just outputting those different pieces of data, also with some icons and another component which is involved, which then also just handles how the icons and the text next to them is being rendered. That's what we do here. And with all of that done and added, if we now save this, if we save all these files, if I go to events/test, I get no event found. But if I go to M1, for example, as an ID, I mean E1, not M1. If I go to E1, then we see this content here. Now, if you zoom in a bit more, this will kind of break because I did not optimize it for all screen sizes, just some basic CSS code, because of course this is not primarily about the styling, but about, well, the logic and about Next.js. So this now is the output for a single event. Now from this page, we have no easy way of getting back to the other pages though. We can always manually change the URL, but we have no navigation bar, for example. Therefore, that's what we're going to dive in next. So some kind of general layout would be nice, a general navigation bar, which we have on all our pages, because at the moment we don't have that. Now for that, we can of course dive into all our page components and start adding some header at the top. So above our main content, we could add a header with a nav bar and so on. And we could do that, but we would repeat that code for all our page components in the end, since I want to have the same navigation bar in all those components. And that is where this _app.js file now becomes important. This in the end is the root component where the different page components are rendered in. This component, which is rendered here, that's your page component in the end. Next.js will use this _app component to hand your page content to it to then display it whenever you switch the page. So that's your page being rendered, this component. That means that we of course can wrap this component with some general layout component. We could wrap it with a fragment and add a header on top of it. And that is exactly what we're now going to do. For this, in the components folder, I'll add a new subfolder side by side to event detail, events, icons, and UI, and I will name it layout. And in this folder, I'll now add a layout.js file and a main header.js file. Now, the layout.js file will be fairly trivial. It holds a functional component, the layout component, and that component will receive some props. And of course, we also export this layout component here. And then here, I just want to return a fragment, which we import from React. So we import from React, we import the fragment, and then a main HTML element between which I output props.children, but then above that also my header. And I'll create that header in a separate file, in the main header.js file. In there, we add another component, the main header component, which we also export as a default here. And then in here, in this main header component, we return our header code. So here we'll have a header wrapper HTML element, and then in there a div which holds our logo text in this case, since we'll not have any image logo in this application. And next to that logo, we'll then have a nav bar with our navigation items. Now let's start with the logo. That will be fairly trivial. I'll make it clickable by adding a link here, and hence we need to import link from next link. And I'll say next events here. That's my logo text. And it should be clickable and always take us back to the starting page. Hence ref here is just /nothing. /nothing so that when we click the logo, we're taken back to the starting page. Now in the nav part here, I'll add an unordered list of all the navigation items, though here it'll only be one nav item, which also is a link, because it also should be clickable. And here I'll say all events, because this should take me to the all events page. Or we say browse all events. And therefore here, ref is /events to take us to this events page. Now some styling would be nice, and therefore again attached you'll find a CSS file. You find the main header.module CSS file attached, which contains some styles for this main header component. And hence we should import classes from /main-header.module.css here and assign these classes to the HTML code. On the header element, for example, you should assign a class of .header, so classes.header. On that div with the logo, it's classes.logo. On the nav, it's classes.navigation. And that's it. These are the three classes which are added here. With that, we prepared the main header component. And now in the layout component, we can add the main header here above our main HTML element. So for this, we need to import main header and then render it here. And now we just want to wrap our overall layout around all the page content. And that is exactly what we can do with this _app.js file. We simply wrap this component, which is our page content, with layout. So with our own layout component like this. And for this, of course, you should make sure that you import layout, this layout component, which we just worked on. And we can wrap layout around that because in layout, we do pass props children, so the content between the opening and closing layout tags, on to this main HTML element. So we render it between those main tags. And hence now if you save all files, you should see this navigation bar at the top. And if I click on next events, I'm taken back to the starting page. If I click on browse all events, I'm taken to the all events page, where we haven't added any content yet. And therefore that's the next step. Let's work on this all events page now. So let's now work on this all events page. So on this index.js file in the events folder. Here we want to render all events, not filtered, not featured, all events. And therefore, of course, we want to get all events. So here we grab all our events by reaching out to get all events, which is another helper function defined in the dummy data.js file. Here I have the get all events function, which returns the entire dummy events array. So here we call that, and in order to call it, we need to import it from dummy data. Now that we got the events here, we want to render a list of those events. And that is where we can reuse our event list component. So at the top, we just need to import event list from, and then go up 2 levels, dive into components, events, event list, and then simply output this event list component again here. Event list, like this. And to event list, we still need to pass an items prop, just as we did before on the starting page, and we pass in all the events we loaded. So with that, if we save this, we see all the events here on this page. And that was super easy to do and super easy to add because we already did work on the event items before in the earlier course lectures. Therefore, we now added a lot of functionality, but one crucial piece of functionality is missing. We also have this slug page where we want to filter for events and where we want to consume multiple path segments. So therefore, that will be the last main feature which we add before we'll then polish the overall app thereafter. Now my goal here is to add a filter area on this all events page above that list of events where we can select a year and a month in drop-down menus. And when we selected a combination and clicked on Find Events, we change the URL and we go to this filter URL, to this slug page here. And on that page, we then read the filter values from the URL to pick the correct events. Sounds cryptic? Well, let's implement it together step by step. And the first step for that is to add a little filter box, a search box above that list of events on the All Events page. Now for this, I'll add a new component in this events folder and I'll name it events-search.js. Now this will hold a functional component, the events search component, which receives props and which we, as always, export, of course, like this. And then in here, we'll have a couple of things which we need to do. First of all, I'll start with the JSX code that should be returned. Here, I want to return a form because we'll have a couple of inputs and those inputs can take different values and ultimately they are submitted. So we have a form. And in that form, I have a div with another div inside with a label inside where I say year. And this label will then be for a select element, so for a drop-down, which allows us to select a year. Therefore, I'll give this label the HTML4 attribute and set this to year, and give this the ID attribute and set it to year so that we have this connection for accessibility reasons. Now in this select input here, for the year, I want to present two options, 2021 and 2022. Of course, you can pick any years here, though I picked these years because I have dummy data for those years here in my dummy data array. So these are my two options. I'll then give these options a value key each, which is the internal identifier, which I'll get access to later. And I'll set this to 21 and 2022 as well, like this. So that's now the first dropdown. Now next to this div, so to this div here, which holds that first dropdown, I'll add another div with a second dropdown for the month. So here we'll have a label for the month, and hence I'll set the HTML4 attribute to month. And then below that, I'll add another select element. And looks like I accidentally deleted a div here, so let me re-add it. So then here I have another dropdown, and this will get an ID of month, like this. And then we need to add the options. And here we'll have 12 options because we have 12 months. So I'll start with January and set the internal value here to 1. And then replicate this a couple of times so that here we also have February and set this to 2. Here we have 3 and March, and well, you can probably guess what comes after, April and May, and 4 and 5, and then 6 and June, and so on. So I'll quickly complete this list here, July, and then also here we have August, and then we also need September, and October, and November, and December, and then also update those numbers so that here we have 9, and 10, and 11, 11, and 12. So now these are the options for the second drop down here. And now below that, below all the divs, but inside of the form, I'll then also add my button again. So my button component, and therefore, of course, we need to import that. At the top, we want to import button from going up one level, diving into UI, and then the button file. So that here we then have this button component, and on the button we can say find events. However, this button here shouldn't be a link. It should be a real button which submits the form of which it is part. And hence we need to go back into this button component in the UI folder and tweak it a little bit. Because this button component should either render a link, as it currently does, or a normal button. And it should render a link if the link prop is set. If it is not set, it should render a normal button. So here I will simply check if props link is truthy, so if that is set, and if it is, I'll return my link as I did before. Otherwise, if we make it past this if check, we don't have a link, and then I'll return a regular button. A button where we output props.children, so where we still pass on the content passed between the tags, and where we then set the onClick prop to props onClick, so that we can use our own button just as the built-in button. I also want to add a class name here and set this to classes.button as well, so that we still apply those CSS classes. With that, we can go back to the event search component, and here we are now therefore done with this JSX code. Again, some styling would be nice, and therefore just as before, attached you'll find some styles for this component. So attached you'll find an events-search.module.css file, which you should add next to the events-search.js file, and then here we import classes from /events-search.module.css, and then add a couple of class names to this JSX code. To the form, for example, we add classes.form. To this first div, we then add classes.controls, and those divs only exist for the styling. That's why I have these nested divs. Then here I'll have another div with a class of control. So the outer div has controls, the inner div has control. And we don't need to add anything to the label and so on, but this div here, which holds the month, also receives classes.control like this. And with that, we're done though. That adds all the styling that needs to be added. At the moment, of course, this component is missing any logic, but it at least has the JSX code and the styling. So we can already include it in this index.js file in the events folder in the pages folder, so on this all events page. Here we can import events search from going up, components, events, and then there events search. And now above the event list here, I'll add events search like this. We can now also replace this div, by the way, with a fragment if we want to import it from React. That's not mandatory, but I'll do it here because we don't really need that extra div. Now if we save all files, we should have this filter area or this search area above our events. Now it's therefore time to add some logic. Let's add some logic to the events search component. We got this form, but at the moment when this button is pressed and the form is submitted, we're not doing anything with that submitted data. And that should change. Therefore, I'll start by adding a nested function in the event search component, and I'll name this function submitHandler. That's the function that should be triggered when the form is submitted. So on the form element, we can add the onSubmit prop and point at submitHandler like this. Don't execute it, just point at it, so that submitHandler is executed by React when the form is submitted. Now, as you know, for example from my React course, we automatically get an event object here, because we're listening to a default DOM event. And here we should call event.preventDefault to prevent the browser default of sending an HTTP request, which I don't want to do here, and which would reload our page and therefore lose all our application state. Instead, I want to handle this submission with JavaScript, and therefore we prevent that default. And once that is prevented, we can now read the selected year and month. Now for that, we could set up two-way binding with useState and so on, but since I'm only interested in the values once when the form is submitted, I'll instead work with refs. Another key React feature which you should be aware of. If you're not, definitely take a React refresher or take my React the Complete Guide course where I dive into all React concepts in great depth. So here we'll then import useRef from React, and then we can set up our refs here. And we'll need two refs since we have two inputs. We'll have the year input ref, and hence I'll create my first ref with useRef, and the month input ref, and hence here I'll create this as well. And now that we got these two refs created, we need to connect them to the select elements. So on the year select element, I'll add the special ref prop and point at the year input ref. And on the month select element, I'll also add the ref prop and point at the month input ref. Now the refs are connected, and therefore now in this submit handler, we can get the selected year by accessing year input ref.current. You always use .current to get access to the actual value the ref is connected to, so in this case to the select element. And then, since this gives us access to the select element, so to the JavaScript object representing that select element, we can access the value property, which every select JavaScript object has. So every JavaScript object representing a select element has a value property. Therefore, we can access this here to get access to the selected value. And we repeat that for the selected month. So with month input_ref.current.value, we get access to the selected value on the month select element. And now we just need to kind of do something with those values. And I don't want to utilize them here in events search, even though we could do that, but instead I want to pass them to my all events page. And in there, I then want to programmatically navigate to that slug page here. And here we need programmatic navigation because we want to do that once some action completed. In this case, once the form submission completed and we extracted all the form values. So that's a typical example for programmatic navigation. Hence, as a first step, I do expect that on the props of this events search component, I have a prop, let's say, named onSearch. This name is up to you, but I'll name it onSearch following this convention because I expect that onSearch, the value for this prop, is a function, which I therefore can execute here. And it should be a function which accepts two parameters, the selected year and the selected month. So I'll call this function, and now we need to make sure that such a function is passed into events search through the onSearch prop. So in this index.js file in the events folder, so therefore on the all events page, we now need to set up this function here. Here we need to add a new function in this component, the find events handler function, for example, which expects a year and a month in this order, because that's how I'm then calling this function here. We're calling this function and we're passing in a year as a first argument and a month as a second argument. Hence, that's what I expect here. And then we do something with that. And it's now this function which is passed to the events search component through the onSearch prop, which we just used in there. So here I then pass at find events handler. We don't execute it here, we just point at it so that it's executed for us by this events search component here with this line of code after the form was submitted and we extracted our values. So then here, find events handler will execute. And in here, we now want to programmatically navigate. So for that, we can import use router from next/router like this, and then call use router here outside of this inner function directly in the component function. All React hooks need to be called directly in your component function, not in any nested block statements. And that gives us access to the router like this. And on this router, inside of the find events handler, we can then call push to go to a different page. That's what you also learned in the previous course section. Now I'll construct the full path I want to go to here with a template literal. And the full path will be /events/ and now two dynamic segments so that we reach this slug here. And the first dynamic segment will be my year, and then / and then the second dynamic segment, which is month. Now, just to be clear, we could have more segments here, and this slug route would still be triggered. It simply consumes an unlimited amount of segments after /events. If we only have one segment, slug will not be triggered because we have a more specific route for that with the event ID file. And Next.js is pretty smart about that, and it sees that for one argument, for one dynamic parameter after events, we have a specific page, but for two or more, we have no specific pages, and therefore then this slug will kick in. So for this path, we'll reach the slug page here. And therefore that's the full path I want to navigate to. And with all that, if we now save this, if we now select, let's say, May 2021, and I click on Find Events, we are taken to /events/2021/5, which is May 2021, and we are on that filtered events page, just as expected. So now, as a last step before the final polishing, let's now load the proper events for this filter criteria. So let's now display our filtered events. So let's work on this slug page, therefore. On this page, we now got a couple of things to do. We need to extract the dynamic segment values, which are part of the URL that led to this page. And we need to extract the year and the month and then find the events that meet this year and month. Now in the dummy data.js file, I already prepared a getFilteredEvents function, which expects an object with a year and a month key, where I then look for the events that have the respective year and month. And they need to have both. So this is not an or filter, but an and filter. I'm looking for events that have both the selected year and the selected month. So that logic is already in place. But in the Slack component, we now need to extract the data from the URL. And for this, we again can use the useRouter hook. This gives us access to the data encoded in the URL, and this Slack page is no exception. So here we now import useRouter from NextRouter, and then we create our router object by calling useRouter like this. Now here we can get our filter data by accessing router.query.slug. But what is that filter data? Well, let's recall what it is by quickly logging it to the console. That filter data. Let's log it to the console, go back here to this events page, to this filtered events page for events/2021/5, and open the DevTools and reload, and we see that it's such an array. It's an array with 2 elements, and the first element is the first segment, the second element is the second segment, and if we had more segments, we would have more items in that array. We also have undefined being logged here, because actually, this component is rendered twice, because of how React works and how that route data is extracted. Effectively, this hook extracting the route data runs after the component was rendered for the first time. So the first time the component renders, we don't have access to that URL data yet. That's not a problem per se, but we'll have to make sure that we only look for filtered events once we got access to the URL data. And in addition, of course, we want to make sure that we don't try to look for events if there is a third parameter, if there is ABC at the end. Or at least we don't want to include that in our query, in our filter logic. So to make sure that this works appropriately, I'll first of all check if filter data is falsy by adding an exclamation mark here, so that when it is undefined, which it will be when the component is rendered for the first time, it's then automatically rendered again, but it is rendered without filter data when it is rendered for the first time. And when that happens, I want to return, let's say, a paragraph where I say loading. And we can give this paragraph a class name of center. And here that's a regular string because that is a globally defined CSS class in the globals CSS file. So here it's a regular string, which I set as a class name to apply this global CSS class, so not a scoped class. And with that, we take care that we don't get an error just because we don't have access to the URL data yet. That's simply how the useRouter hook works internally. But now, of course, when the component is then automatically rendered for the second time, we do have access to the data, and therefore now we do want to look for the appropriate events. For this, I'm only interested in the first 2 segments, which I know will be the year and the month. So I'll get my filtered year by accessing filtered data, the first element, and we get the filtered month by accessing the second element with index 1. Now, the data which we get here is in a string format. It's always a string because it's encoded in the URL. And I need numbers. Therefore, I'll set up my num year by transforming filtered year to a number by adding a plus in front of it. And the same here for the month. With num month, I transform this to a number by adding a plus in front of filtered month. So that transforms that data to numbers. Now, of course, for some reason, we could fail to do that because, for example, someone manually entered /events/abc/5. And in that case, ABC would of course not be a valid year. So we also want to handle that scenario. And therefore I'll add an if check where I check if my num year, so my year transformed to a number, is not a number, which would happen if that is a string like ABC, for example. Then we can't convert it to a number, and this year would produce not a number as a type. So I'll check if my num year is not a number, or if my num month is not a number. If either of the 2 failed, something is wrong about that URL. I'll also check, as an additional condition under which I want to fail, if my year, let's say, is greater than 2030, let's say that's the highest year I want to support, or if it's below 2021. And I'll also check if my month is maybe smaller than 1, which makes no sense, or if the month is greater than 12, which also makes no sense. If either of these things is true, if either of these conditions is met, I don't want to continue, because then something is wrong with the filter. So then I'll just return some output where I, for example, say, invalid filter, please adjust your values. So now with that, if we save this, and I would load this page for /events/abc5, I would get invalid filter, please adjust your values. Now, assuming that we do have a valid year and a valid month, I now can expect to find events though, at least if such events exist for the chosen year and months. So now I can get my events, my filtered events here. I can add this constant by executing getFilteredEvents, which is this function we have to import from the dummy data file, that function I showed you a couple of seconds ago. We execute this function, and this function wants to get an object with a year and a month field. So here I'll set the year field to num year and the month field to num month, passing on those converted year and month values as numbers to getFilteredEvents. That then gives us our filtered events array. Now, of course, that could be an empty array though, if we don't find any events for the chosen year and month. So therefore, we want to check if filtered events are falsy for some reason, or if they're not falsy but an empty array. So if filtered events length is maybe equal to 0. If either of these two conditions is met, then we had a valid filter, but we simply don't find any events for that filter. And in this case here, I also want to return some text where I simply say no events found for the chosen filter. Something like that. And now if we made it past this if check as well, we know that we do have valid events. So therefore now in the next lecture, we'll then output those events. So let's now output the filtered events we identified. For this, of course, we can again use our event list component, which we created at the beginning of this module. So I'll import event list from going up, components, events, event list. And then here I'll output event list like this, and set my items equal to the filtered events array, which we're producing here. Now, if we save this, and I do enter a valid combination, like /events/2021/5, I'm looking for events from May 2021, and you see I do render 2 events here, because indeed I do have 2 events which date is in May 2021. So these are being displayed here then. So that's working as it should, and therefore now let's just finish this app up, polish it a little bit, add a couple of extra styles and components, and then wrap up this module. So to polish this all a little bit, I'll start by adding a new component which I prepared for you. Attached you find a results title zip file which contains a results title component and its styles, and you should drag the JavaScript and the CSS file, which is part of that attached zip file, into your events folder. So that in there you then have the results title JS file and the results title module CSS file. And that's a very simple component which I just want to render on top of the event list here in the slug component. So here I'll then output the results title and replace that div with a fragment, and make sure that we import both results title as well as fragment in this component now. Fragment from React and results title from this file we just added. Now results title, this component, actually wants a date property, a date prop, which it then outputs in a human readable way, and therefore we should make sure that we provide this date prop. And to pass that to results title, down here, I'll create a date constant where I instantiate a new date object to which I pass my num year and num month. That is a way of creating a date based on a year and month. The only important thing here is that you need to deduct 1 from the month because that is a 0-based index here for the month. The date constructor function expects the month to begin at 0, not at 1, which is why I deduct 1 here. And then we can set the date prop on results title and pass in our date object. And with that, we just have this little extra detail on top of that, and we can now go back to all events again. Now, I also want to polish messages like this one here, when we didn't find any events, or when we have an invalid filter, like for ABC. I want to present this in a nicer way and also provide a button to go back to the all events page then. And therefore for this, in this slug page component, let's work on this error message here when we don't find any matching events. I'll wrap this paragraph in a fragment. So we need to import fragment from React, but we already did so before, so that should already be there. And we put the paragraph in there so that below the paragraph, we can also output a button. So we need to import button from our own component file. And then with the button added here on the button, I'll say show all events, and there should be a link. So I'll set the link prop to /events. Now that button should actually be centered, so I'll wrap it in a div with that global center class I showed you in one of the last lectures. And I'll do the same thing for this invalid filter error. I'll wrap this in a fragment as well and add my button here as well as this paragraph, move that all into the fragment so that here we also got a way of going back. Now we have the button, but the message still looks ugly. And for that, I prepared another component for you, which you also find attached. It's a component you should move into your UI folder, the error alert component, which is attached. This error alert component gives us a nice container for error messages like this. And therefore, in the slug component, we should import error alert from, and then dive into the UI folder in the components folder and into the error alert file. And then simply wrap the paragraph here for the invalid filter, for example, with error alert with this component. Simply wrap it around this paragraph. And if you do so, this now looks nicer. Now, for the case that we don't find any events, I also want to use that component. So therefore, for this error message down here, for the no events found message, we can also wrap this into an error alert like that. I also want to use that error alert in the event ID page here, because here we also have the case that we didn't find an event for a chosen event ID. And therefore here, just as before, I'll import error alert from going up, components, UI, error alert, and then wrap this paragraph with it. So error alert wrapped around this paragraph, so that if we do look for an event which doesn't exist, for example, /events/test, so just one dynamic segment after events, but a segment value which doesn't match any event ID, I get no event found. And with that, we should be good. Now we wired up all those different values and pages, and they're now all working the way they should work. We can filter, we can show all events, we can dive into a single event, and we made that work with standard React and Next.js. So this is it for this course section. We wrote quite a bit of code, added quite a bit of components, most importantly, of course, a couple of page components. And hopefully all those core features, which we had a look at in this module, now make a lot of sense to you. It should be clear how routing works with Next.js, how these different page files are translated in different routes, how such slug routes work, and how the single dynamic parameter routes work, and how we can wire up all those different things with each other. It should also be clear now how you can mix regular React components, which have no Next.js specific features in them, with Next.js page components, which in the end are also just regular React components though, just treated in a special way because they're in a special folder. We also again saw how we can use the useRouter hook to get access to the router and through the router either navigate programmatically or get access to data encoded in the URL. And how with all those features, we could make sure that we build a basic application like this. Now with all of that, we learned a lot, but we're still only scratching the surface, because we now had a detailed look at file-based routing, which is one of the main features Next.js offers. Let's now also take a closer look at data fetching, another key Next.js feature. Up to this point in the course, we learned about pages and we learned about routing, and that Next.js helps us with routing and that it allows us to define a route structure and define our routes in general by setting up files and folders in the pages folder. But as you see here on this slide as well, Next.js is not just about routing, and that's also what I already explained in the first course section of this course. Whilst this is a major building block of Next.js, and whilst this is already a pretty amazing feature that could be a good reason for using Next.js, it's not the only reason why we might want to use Next.js. Instead, Next.js helps us with building full-stack React apps, as I also mentioned before in the course already. And it helps us with that by, for example, pre-rendering pages on the server side. And that's important. And in this section, we're going to explore what exactly that means. But in the end, Next.js will help us with executing code not just on the client side, so in the React app that runs in the browsers of our users, but it helps us with running code on the server side as well. For example, for preparing data or for loading data that is then needed by the page that should be displayed. Therefore, this course section is about data fetching. It is about how Next.js helps us blend server-side with client-side code and why we might want to do that. And we're going to explore what exactly data fetching means and why it matters and how Next.js helps us with that. And we're then specifically going to explore static generation versus server-side generation, what these concepts are and when to use which and how to use them, of course. And we're going to see how exactly we do prepare and fetch data with Next.js and how that differs from traditional React apps. Now for this section, I want to start with a traditional React app, and I want to come back to one of the main assets, one of the main reasons for using Next.js, which I did already talk about in the first course section as well. This here is a dummy page rendered by a standard React application. To be precise, by this React application here. I just created a very simple React app with one component, the app component, and there I fetch data from a dummy backend, which is a JSON file in my public folder, which is therefore served by this development server. And in there I got some dummy data, but the important thing is that I'm not loading the data in my JavaScript code by importing that file or anything like that, but that instead I send a HTTP request to that file once everything is up and running in the browser. And then I load data, extract it, set my state, and render the data. Now, what we see therefore is that dummy data on the screen, but if we then view the page source of this file, we see that on there, in this page source code, the data is nowhere to be found. We only got this empty div here with the ID root, which is the div in which our React application is actually rendered in. And we can see that rendered application if we inspect the page, where we then see the actual DOM as it's currently rendered. There inside of the div with the ID root, we do see the unordered list with the list items. But that's only the DOM as it was rendered by JavaScript and by the React app, therefore, after we loaded this page. The actual HTML content served by the server, so loaded by the browser initially, is this HTML code instead. And that code did not include any data. Now that can have a couple of disadvantages, as I already mentioned in the first course section. For example, our users need to wait for the data to be loaded to actually see something on the screen. Now here that's super fast because that dummy backend file is served by my local development server, which runs on the same machine as the user is here during development, and therefore we don't really see a difference here. But for real pages where we fetch data from some backend API, loading that data could take a second or so, and therefore we might have a delay. We might have a loading spinner, which our users have to see before the data arrives. So the user experience could be suboptimal when fetching data like this. Not necessarily, often it's fine, but it could be. Now, an even bigger problem could be search engine optimization though. If you are building an app where search engines like Google should be aware of your content, you'll have a problem because this HTML code, which is initially sent back by the server to the client, that is what search engines will see. And in there we got no content at all. So if our content matters, and we want search engines to see and index that content, sending back this is bad. Now again, that is not a problem for all websites and web apps, For example, if you have a web app where users need to log in anyways, if you have some admin dashboard built with React, then search engines might not matter to you because users are not going to find your page, your admin dashboard, through a search engine. But if you do have a content-heavy app, like a blog or a shop, then you of course typically do want search engines to find your content, and sending back something like this then is bad. Now, I did talk about that in the first course section already. I just wanted to bring it back into your memory because it does matter. That is an issue which we can have with standard React. And the problem is that we fetch data in our component after the component was loaded. So we fetch data from the client side, we send a request to the server after something was rendered to the screen. The initial response, the initial HTML page, which is sent back by the server to the client when the user first visits the page, does not yet contain that data. And that can be a problem. And that is something where Next.js, with its server-side capabilities and its built-in features, can help us. So I outlined a potential problem we could be facing in the last lecture. Now, Next.js can help us with a concept called pre-rendering. Imagine that you have some page, some route, which then loads some page file in the pages folder, which needs data. Now, when a request is sent to this route, so if a user wants to visit this page, then what Next.js does is it will return a pre-rendered page. And that's a difference to standard React. With standard React, you get back an empty HTML file and all the JavaScript code, and then that JavaScript code runs and brings something onto the screen, and that happens super fast, so users won't really see a problem there. But then any data which might be needed, in addition to the general DOM structure that should be shown, such data then is loaded from a server, and that can take a while. Now, not if the page is pre-rendered, and that is what Next.js does for us. Instead of loading data only after the page was sent back to the client, Next.js pre-renders a page and pre-renders all the HTML content with all the data that might be needed. It loads that in advance and then pre-generates the finished HTML page so that it's this finished, fully populated HTML page which can be sent back to the client, so to the visitor. So that's great for SEO. Now, we also, of course, still want to have an interactive React app. After all, there is a reason why we use React, and we don't just build a HTML and CSS app. Instead, we might be using React for handling user interaction, for watching a forum and showing validation errors, for reacting to button clicks. And therefore, Next.js will not just send back this pre-rendered page, but it will also send back all the JavaScript code that belongs to it. And it will do something which is called hydrating that page. So it will send back that JavaScript code, and that code will then take over that pre-rendered page and again let React do its job. That is great because now we have an interactive page or app. But we did send back that pre-rendered page initially so that all the core content was already there right from the start, and so that search engine crawlers, for example, also see that entire page with all the content. If it's not interactive at that point, that doesn't matter to those crawlers because they are only interested in the content anyways. So that's the idea of pre-rendering. We, or to be precise, Next.js, prepare a page in advance by pre-building all the HTML content and by preloading all the data that will eventually be needed. And it is worth pointing out that this pre-rendering only affects the initial load. So when we visit a page and we load our first page, this page is pre-rendered. Once we are on a website that's powered by Next.js and React, and once that page is hydrated, which happens right after this first rendering, once that is the case, we have a standard single page application again. So then React takes over and handles everything on the front end. If the page changes thereafter, if we visit a different page of that same website, that page is not pre-rendered, but instead created in the client with React. It's just this initial page which we visit, which is pre-rendered, so that there we don't get this empty page until React is ready, but we get this pre-rendered page which contains all that initial content already. And for achieving this, Next.js has two forms of pre-rendering, and we are, of course, going to learn about both, which you can choose from. So you can choose which form you want to use. The first form, and the recommended form, is static generation. The other form, the alternative, is server-side rendering. Now, that might not tell you much right now. I will explain both throughout this section. The main difference is that with static generation, all the pages are pre-generated in advance during build time. So when you build your application for production, before you deploy it, you prepare all those pages. With server-side rendering, pages are created just in time after deployment when a request reaches the server. Now, there also are ways of mixing that, and I will dive deeply into both concepts and when to use which throughout this section. I hope it's clear what the core idea behind pre-rendering is, though, and therefore let's now explore these different concepts of pre-rendering pages. So let's explore this first form of pre-rendering or of data fetching with Next.js. And that would be the static generation, which I did mention is typically recommended, but of course I will explain all the details now and throughout this section. Now, with static generation, there is a simple idea. The idea is that you pre-generate a page during build time. And pre-generate means that all the HTML code and all the data that makes up the content is prepared in advance. So on the server side, though that can be confusing here, with that I really mean during the build process where you are allowed to execute code that would normally only run on the server side though. Code that interacts with the file system, for example. And you're going to see it in action very soon. So data and pages are prepared during build time, when you build your application before you deploy it. Now, because pages are then pre-built during build time, once you deployed them, they can be cached by the server, by the CDN that might be serving your app, and therefore incoming requests can be served instantly with those pre-built pages. Now, then, as I mentioned before, those pages after they were served are still hydrated with your React app, so you still have a regular React app in the end. The only difference is that the pages which are sent to your clients are not empty initially, but pre-populated with content. Thereafter, you can still do whatever you want to do. It's still a regular React app. So therefore, now one main question, of course, is how do we tell Next.js that a certain page should be pre-generated? And how do we tell Next.js which data is needed to pre-generate a page? And the answer is, there is a specific function which we can export from inside our page components. And that's important, only from inside our page components, not from other React components, but only from inside the component files that live in our pages folder. From in there, we can export the special async function getStaticProps. Now, that name matters. It must be written exactly like this, getStaticProps, because that is then a function Next.js will watch out for. It's async, which means it returns a promise, and you can use the await keyword in there. And then the special thing is that in this function, you can run any code that would normally run on the server side only. So in that function, you don't run client-side code, you're not restricted to that, and you don't have access to certain client-side API, you don't have access to the window object, for example, but instead you can run any code you want that normally would only run on the server side. And even better than that, code that you write inside of this getStaticProps function will not be included in the code bundle that's sent back to your clients. So any code you put in there will never be seen by your clients. So if you, for example, have code in there that contains database credentials, you typically wouldn't want to expose those credentials on the client side. You can safely write it inside of getStaticProps because that code will never end up on the client side. And therefore, let's now take a closer look at that and let's start writing some code there so that we fully understand this function and how it works. Now to write some code, I'm back here in an empty Next.js project, which you again find attached to this lecture so that we all start with exactly the same starting state. It's very similar to the starting projects from the last course sections, but I did already add an index.js file in the pages folder, which lists some dummy content. Now, if we run npm install here to install all dependencies, and then we run npm run dev, we bring up that development server again. And once I do that, we see product 1, product 2, product 3, and that's just the dummy content I have in there. Now, before we add this getStaticProps function, I already want to show you something important. If we view the page source of this page here, so of this page generated by Next.js, then we see that it looks very different than what we had a look at before with the standard React app. And whilst this is a bit hard to read, we see that in there, indeed, we do have the unordered list with the list items here. Here it is. We do have that in here in this page. And keep in mind that this page source we're seeing here is the actual response we got back from the server, in this case from the development server, when this page was loaded, when this request was initially sent. And that is the kind of content a search engine would see as well. And that's of course great. It already contains the content. Of course, this is not content that was fetched with useEffect or anything like that, but before in the React app, we didn't see any content, not just the content that was fetched with useEffect. We also didn't see an empty unordered list. We saw no content at all. Now we see all the HTML code, all the JSX code returned by our component. We see that here. And that already shows us that there is a difference. This page, which we're getting here with Next.js, was already pre-rendered by Next.js without us doing anything. It was already pre-rendered because by default, Next.js pre-renders all pages that have no dynamic data. And this page, of course, does not have any dynamic data. Everything here is just hard-coded. And if you have a page like this, Next.js will automatically pre-render it for you, which is great because now any content which you encode in your component will be visible to search engines and to your website visitors right from the start. So that's not even the main thing of this section, but it's already important. However, let's now get back to getStaticProps. The getStaticProps function can be added to any page file, and only there, as I mentioned, and you need to export it. And when you do so, then Next.js will also call this getStaticProps function on your behalf when it pre-generates a page. And this function also signals to Next.js that this is a page that should be pre-generated. Now, I just said that Next.js would pre-render any page by default, and that's true, but we'll later learn about a way of telling Next.js to not pre-render a page, and therefore it's important to understand that getStaticProps will not tell Next.js to not pre-render, but instead it kind of confirms to Next.js that this page still should be pre-generated. But in addition to just running through the component and returning the JSX code, Next.js will then also call this getStaticProps function if it finds one in your component file. So therefore here, let's say we want to load this product data dynamically, but not in the way we would do it in a standard React app with useEffect, what I showed you before. And therefore attached you find another file, the dummy backend JSON file, which is this example dummy file I used in the React example a second ago. And you should add that in your main project folder. Not in public, not in pages, just in your folder like this. Or actually maybe add a data folder. Whoops, a folder, not a file. Add a data folder and move that file into there so that you have a data folder. And in that data folder, you have the dummy backend JSON file. And now we want to load data from that file for this index.js file, but we don't want to load it through a HTTP request that's only sent from the client side after the page was loaded. Instead, we want to pre-fetch the data before we create this component and before this component page gets pre-rendered by Next.js. And that's exactly why we then add this function which we export, the async function called getStaticProps. And again, it needs to be called exactly like this. Now in this function, you then always need to return an object that has a props key, because the function is named getStaticProps. And actually what this function does is it prepares the props for your component, so this props object. It prepares that because Next.js, if you have a getStaticProps function in your file, will first execute this function, and then in a second step, execute the component function. Now, in a second step, because that first step prepares the props for this component function. And therefore, in this getStaticProps function, you can run any code you want, again, code that will never be visible on the client side, that fetches data and exposes data through props to this homepage component. So here I could set props equal to an object, so that the props I get here are still an object. where I have my products, and that could be an array where I, for example, have one object in that array with an ID of P1 and a title of of product 1. Something like this. So now getStaticProps returns an object with a props key. That's always required. You always must return an object with a props key. And then the data in the props key is up to you, but it should be an object. And here it's an object with a products key, which holds an array of product objects. And now we'll receive that here on props on this home page because Next.js first calls this getStaticProps function and then executes this component function. And it does both things in advance. So none of that code here runs on the client side. Instead, that all happens during build time or in development as part of this development server, which we're using. So here on the homepage component, we can then expect that we do get a products key on our props. So I can use object destructuring to pull products out of props. And I use products here because that's the key I used down there. And then we can render this list dynamically by accessing products and mapping that such that every product is mapped into a list item where the key is the product ID. So this ID we got down there. And as a value between the opening and closing list item tags, I output the title like this. And with this in place, if we now visit our Next.js application, we see product 1 here. Now, of course, we're currently not fetching that data from any file. I have it hard-coded in there, but we already implemented getStaticProps with that. And if we now again view the page source of this page, we see that this data, this product 1 data, is part of the page that was sent to the client. So fetching that product data did not happen on the client, it happened on the server. And if we would dive into the sources tab of the DevTools and look through the JavaScript code files, you wouldn't find that code anywhere in those files because it's not part of the code that's shipped to the client side. And that means that the code in getStaticProps can do server-side things because it's not executed on the client side. So you can use credentials which your users shouldn't see, and you can also run code that wouldn't work in the browser. Code that accesses the file system, for example. And that's exactly what we're going to do next. So we added getStaticProps with some dummy code, but at the moment we're really just, well, not doing anything that would require us to add that function. We could just prepare dummy data like this in the component function as well. Well, of course, I started with such a simple example to just get started with getStaticProps. A more realistic example would be that we have a data file like this dummy backend JSON file from which we want to load data. But we do want to load the data when the page is prepared. We don't want to reach out to that file through a HTTP request or anything like that from the client side. And therefore, we'll now utilize the fact that any code inside of getStaticProps is executed on the server side, so to say, with server-side capabilities. And that means that we can now, for example, work with the file system. For this, I'll add an import at the top, and I'll import fs from fs. Now this imports the file system module from Node.js. This is not a third-party package which we needed to install. It's one of the core Node.js modules instead. And working with the fs module would fail if you tried to do it on the client side, because browser-side JavaScript can't access the file system. And especially not our project file system here, because the entire project is not served to our visitors. But we can import this here nonetheless and use the file system module inside of getStaticProps. So we can use fs here. And Next.js is very clever and sees which imports you only use in getStaticProps or similar functions, which we'll learn about later. And then those imports are basically stripped out of the client-side code bundle. So when the code for the client side, the React app code for the browser side, when that is prepared, that import will not be part of it. Next.js will ignore it for the client side. It will split your code in a clever way. So the component code in general will be part of the client-side code. This import and this code won't be. And now we can use fs to get access to this dummy backend JSON file with the read file or the read file sync function. Read file sync synchronously reads the file and blocks the execution until it's done. Read file, on the other hand, wants a callback to continue. And we can actually also import the file system from fs/promises, which is a special version of this Node.js module that uses promises. And when we do so, read file actually returns a promise. And since this is an async function, we can then just await this. Now, read file just needs a path to the file which you want to read. So we can construct this path here, and this path, or let's name it file path, this path should lead to the dummy backend JSON file. Now, to construct this path, we can import another module from Node.js, the path module from path. And that's a module with helpful functionalities for building paths. Now here we can use path and execute the join method to build a path that can be consumed by read file. And here I want to start from inside the current directory and then basically work my way to this data directory and the dummy backend JSON file. Now for this, we basically want to dive into the data folder and then grab this dummy backend JSON file. And to do this, we first of all need to tell path join in which path we're starting. And we can get the current working directory by using another Node.js object or concept, and that's the process object, which is globally available in Node.js. And then on process, we can execute the CWD method, which stands for current working directory. And this gives you the current working directory of this code file when it's executed. Now, the important thing here is that this current working directory will not be the pages folder. Instead, when this file is executed, Next.js will be executing it, and it will basically treat all the files as if they sit in our root project folder. So the current working directory will be the overall project folder instead of the pages folder. That's important to know. So with that, we tell Node.js, or the path join method to be precise, that we start in this overall project directory. Then we add a comma, and the next argument is data, because we want to dive into the data folder. We want to build a path which starts at the current working directory, so the project directory, and then dives into the data directory. And then we add another argument. We can add an infinite amount of arguments here, which holds the file name we want to use. So in this case, dummy backend.json. This now builds an absolute path to this file, and that's now the path which we pass to read file. So this will now read this file. So with that, we get our JSON data from that JSON file. And now to get our actual data, we can call JSON parse on the JSON data. JSON is a globally available object, just as it is on the browser side. You can use it in Node.js as well. And this parses this JSON data. It converts it into a regular JavaScript object. And now that data will be an object with a products key, which holds an array. So now we can return our props, which are now based on that data. And the products, which are part of my props, are now data.products. So the products I fetch from this file are now passed as a value to products here in this object and are therefore ultimately passed through props to this component function when Next.js executes this function for us. But it will first of all go through that function. And hence now if we save everything, and you reload localhost 3000, you'll see 3 products here. Again, if you view the page source, you see that all the data is there right from the start. Here it is. So it was pre-rendered. And it was pre-rendered with help of getStaticProps, which now executes a bunch of server-side code that never reaches the client. It's only executed when Next.js pre-renders our page. Now, up to this point, I explained a lot about pre-rendering and how Next.js does that. But we haven't really seen it in action other than on the running website in development mode. But I do want to show you what exactly Next.js does do for you when you build the application. Now, I did mention this build script before. This build script, that's a script you execute when you're ready to deploy your next application, your Next.js project. And this build step here, this next build command, which is executed in the end, this will then pre-generate your pages. And to show this to you, here I quit my development server and I'll run npm run build here. So I'll execute this build script and therefore next build in this project folder. And what you'll see now is that it's now creating that optimized production build, and that can take a couple of seconds. And after a while, this build process will complete. Now we get a couple of pieces of information here. We see that it was successful in the end because we have no error here. And we see that it generated 2 static pages here. And we see the detailed output down there. We also have a legend here at the bottom telling us that a filled dot stands for static site generation. So for a pre-generated page that was pre-generated during development or during the build process because it uses getStaticProps. A lambda symbol would stand for a server-side only page, something we're going to see later. An empty dot stands for static, so also a page pre-generated, but a page that doesn't even need any data and therefore doesn't use getStaticProps or anything like that. And if we scroll back up again, we see that in the end, the 2 pages that were pre-generated is the starting page, so /nothing, so index.js, and then a 404 page. We haven't added one, but you get one for free automatically. We can ignore this _app thing here. Now the 404 page has an empty dot, which means it was pre-generated without any data, which makes sense. We didn't add our own one, and the default one is not fetching any data. And index.js, so /nothing, was statically pre-generated with help of getStaticProps. That's why we have that filled dot here. That's how we can read this. And we can also see this if we have a look at the .next folder, which was generated now, which holds this production-ready code, so which holds the output of the npm run build command. Then in there we do have a server folder into which we can dive. And in there we see those pre-generated HTML files, the 2 pre-generated HTML files. And in index.html, if you open that, you also find that product data in the end in there. Because that's the pre-generated page, which we also see if we would visit this page in the browser. And that's that pre-generated page, which is sent back on the initial request to the search engine crawler or to the visitors of our page. And we can even preview this production-ready page here by running npm start. npm start starts the production-ready page with a Node.js server, and whilst we typically would do that on some remote computer to expose it to the world, we can also do that locally on our machine. And then again, it starts on localhost 3000, but this now is not the development server, but the real server serving the production-ready page. So if I visit localhost 3000, if I enter this in the browser, I still see this page with the pre-rendered products because we just saw that in the pages folder in this .next folder, which holds this production-ready site. Side note, in the page source, you also see there is some script tag injected by Next.js, which in the end includes that data with which the data was populated. That is needed for this hydration, where the pre-rendered HTML code is then connected with the React application. And that data which was prefetched is handed off to that React application so that the React application knows that this was dynamic data and which kind of data should be rendered. So that if you continued working with that data and you would be updating that data through React.js, React would know which kind of data was received originally. That's just a side note. It's all done automatically. We don't need to do anything for that. But that is how Next.js does work here and how it pre-renders pages for you. So we did learn about getStaticProps and how we can use it to prepare data on the server side, so to say, for pre-rendering the page. However, when I say on the server side, that's only partially correct. We can execute server-side code here, but in the end, the code will not run on the actual server which serves our application. Instead, it runs on our machine when the page is built, when the application is built with Next. So in the end, when you run npm run build, when you execute that prepared script here, which executes next build, then this code is executed. Now, that's still good, because since we have Node.js installed, all that Node.js code does work here, so that's perfect, but it has one potential downside. What if you have data that changes frequently? Because, I mean, pre-generating the pages sounds great if you're building something fairly static. If you're building a blog where data doesn't change too often, then, of course, whenever you add a new blog post, you can just pre-generate your project again, you can run npm run build again, and deploy the updated project. So that would work. But if you have data that changes more frequently, if we add a 4th product here after the page was deployed, then we have to rebuild and redeploy the page all the time. And that doesn't sound like a great thing to do. Well, Next.js also has solutions for this. Solution number 1 is that you do pre-build your page, But then you still include standard React code in your React components, where you use useEffect for then fetching updated data from a server. So you would always serve back a page with some pre-rendered data, but that data might be outdated, so you fetch the latest data in the background and then update the loaded page after that data arrived. That's a pattern you could implement. Then you at least show something to your users, but it might be a bit outdated, but that's why you're fetching data in the background so that you can update the page with the latest data once you get that. That might be a perfectly valid pattern. But there is an alternative which often is better. This getStaticProps function, as I mentioned, does execute when you build your project with next build, so with this build script. Well, that's not entirely true. It does execute there, but that is not necessarily the only time it executes. Instead, Next.js has a built-in feature which is called incremental static generation. It means that you don't just generate your page statically once at build time, but that it's continuously updated even after deployment without you redeploying it. So you pre-generate a page, but then you can also tell Next.js that a given page should be regenerated again for every incoming request at most every X seconds. So every 60 seconds, for example. That means that if a request is made for a certain page and it's, let's say, less than 60 seconds since it was last regenerated, the existing page would be served to the visitor. But if it's past those 60 seconds, and the amount of seconds, of course, is up to you, then this page would be pre-generated on the server instead. So that means that you either serve the old page if it's not that old yet, or you serve the latest page and brand new page which was generated again on the server otherwise. And if that page was pre-generated again on the server because it was outdated, then this newly generated page will replace the existing old page on the server. It will be cached and future visitors will see that regenerated page instead, until 60 seconds passed again and a new page is pre-generated again. So you can have ongoing pre-rendering on the server for incoming requests. And all you need to do to unlock this is in the object which you return in getStaticProps, you don't just return props, but you also add a second key, which is called revalidate. And as a value, you set a number here, which is the time in seconds that Next.js should wait until it regenerates this page. So for example, if I enter 10 here, we would tell Next.js that for every incoming request to this page, it should be regenerated unless it's less than 10 seconds ago that it was last regenerated. So it's recreated at most once every 10 seconds. And of course, the higher that this number is, the less this page will be regenerated. And it's totally up to you which value you want here. It will, of course, depend on which kind of application you're building. For a highly dynamic page where content changes all the time, you want a very low value, maybe just 1 second. For pages where the content is less dynamic, maybe 10 minutes is enough. So that is then really something you have to decide. Now, during development, the page will be regenerated for every request, no matter what you enter here. So with the development server, we will always see the latest page with the latest data, and this will always run again. But in production, this number will matter. So here, if I add regenerating here in a console log instead of getStaticProps, if I now rerun the development server, we will see here in this terminal, since that is the server-side terminal, so to say, we see regenerating because I started the dev server, so that's equivalent to the build process. It was now pre-generated. But if I now visit this page by reloading, for example, we see this again. Because as I just said, during development, the revalidate number doesn't matter. It will regenerate it every time. In production, it will matter, and then you have the best of both worlds. You have a pre-rendered page, which then still is updated after deployment, just as defined by you. Now, just as before, I also want to show you this revalidation in production, so to say. So again, we're going to execute this build script here, now that we did add revalidate to our getStaticProps return object. And keep in mind that we have this console log statement in here. So now if I run npm run build, Again, this entire project is prepared for production, and Next.js goes ahead and pre-renders pages, but it will now also do this incremental static generation here. And if we scroll up a bit, what we indeed see is that we're generating static pages here as part of the build process, and that was done before as well. We therefore see our regenerating console log statement here. But then you also see that this option here is checked for ISR, which stands for incremental static regeneration. And here we see that 10 seconds is logged in. So basically Next.js recognized that we set this to 10 seconds here, and hence it is aware that this page / nothing, so the starting page, the index page, should be regenerated every 10 seconds. That's what it's saying here. So it's aware of that. Now we can run our build website here locally on our machine with npm start. So not npm run dev, that would start the development server with better debugging support and so on. But with npm start, we can run this build production ready site. So after npm run build, we can run npm start to view this production ready site on our local machine. So now I started this prepared page. And if we now visit localhost 3000 in the browser, because that production demo server here still runs on localhost 3000, as you see here. If we visit that, we see our product data here. So we see this pre-rendered page, which makes sense because it was pre-rendered as part of the build process. But if I now reload this page here, you see regenerating here in this log, in this terminal. And keep in mind that this terminal represents the server side, because here I started the server with npm start. So what we see here is output from the code that runs on the server. And since we see regenerating here after we built our project with npm run build, this proves that indeed getStaticProps was executed again on the server which is running our production ready site. So exactly what I explained over and over again over the last lectures, you see it in action here. This getStaticProps function did run again on the server, not in the browser, and not during the build process, but on the server after it was deployed, so to say, with npm start. And therefore we see this was revalidated. It was rebuilt because of our 10 seconds setting. Now I talked more than 10 seconds, so if I reload this again, we again see regenerating. If I quickly reload again a couple of times though, we don't see 10 times regenerating here though, because I was below those 10 seconds. So I hope this all makes sense and it's clear how that works. Now, before we explore more static functions Next.js offers to us and when we need them, let's take another closer look at getStaticProps. On this slide, you see that I added a parameter called context there. Because indeed, this function, which is called by Next.js, receives an argument. We just haven't used it thus far. But we do actually get an object here as an argument, as a parameter, with some extra information about this page when it's executed by Next.js. For example, we would get any dynamic params, any dynamic path segment values, which we'll see in a second, so we'll ignore that for now. And we also get a couple of other pieces of information, which at the moment, though, don't matter to us. So let's ignore this for now. You will see context in action throughout the next lectures, though. Instead, let's take a closer look at this return object again. In there, we see props and revalidate. Now, there are two other keys which you can set on this object. One key is the not found key, which wants a Boolean value, which is either true or false. If you set this to true, this page will return a 404 error and therefore render the 404 error page instead of the normal page. So if I add not found true here and save this, if we reload, we get the 404 page. Now, why might we want to do that? Well, if the code here, where you fetch data, fails to fetch the data for whatever reason, then you could, for example, do that. So we could check if data products length, if that is 0, so if we have no products, then maybe we want to return an object here in getStaticProps, which has not found set to true, so that we show the not found page. And only if we have at least one product in the fetched data, we return the regular page. That would be a typical use case where you sometimes want to render the 404 page because you failed to fetch data. So if I save this and reload, now I see that page again because of course we do have products. Another key you can set is the redirect key. The redirect key allows you to redirect the user. So instead of rendering the page content, instead of rendering this component content, you can redirect to another page, to another route. And that could also be needed because maybe you failed to fetch data. Let's say the problem is not that there is no data, but instead you weren't able to access the database or anything like that. So if there is no data to begin with, so not just no products, but no data in general, then maybe you want to redirect. And you can do this by returning an object where the redirect key is set to an object where you then set a destination to some route, for example, to the no data route, which we don't have here, but which you could have in a project of yours, of course, and where then therefore that route would be loaded with a redirect status code returned by Next.js instead of this page component. Now we don't need either of the two here, but I wanted to mention them here so that you are aware of these special options, which basically can come in handy if something goes wrong with fetching your data. And with that, that's enough for getStaticProps for this very moment. Let's now have a look at another very important use case and very important problem you often face in Next.js projects. In this project which we have here, we currently have only one page, the index.js page. Now there we're rendering some dummy product data. And it's very simple dummy product data, of course. Now what if our data there was a bit more complex? So every product also had a description, let's say. And I'll keep this very simple here since I want to focus on the Next.js features, not on this concrete example. So here the description is, this is product 1. It's one extra JSON key added here. And on the second product, this is product 2. And you might be able to imagine what it will be on the third product. Yes, this is product 3. Now the idea could be that on the index.js file, we render a list of products, and every product is a clickable link, which takes us to a detail page where we then also see the description of the product. So similar to what we built before in our project with the events, we have a detail page for the products. And for this, we can of course add a new page with a dynamic segment between square brackets. And here we could name this PID for product ID, but that identifier is up to you, .js. So that's now a dynamic page. Alternatively, we create a folder named PID like this, and in there we then have an index.js file, but I'll stick to this setup. And here we could now add a component function, which is the product detail page, let's say. And the idea is that in this component, on this page, we show the product details. So to keep this simple, I just want to return, let's say, a fragment here, imported from React. And there I then have a h1 tag with the title of the product, and below that a paragraph with the description. But that data should now be fetched from the dummy backend JSON file as well. Now again, of course, we could write standard React code here, so to say, and use useEffect, imported from React, to send a HTTP request to some server which might provide this product data. But then we're back in the world where that data is not there when this page is initially rendered. So search engines still wouldn't see it. So that's not what we'll do here. Instead, what we will do here is we will again use this async prop function. So we'll export this async function getStaticProps. This function is again a function we can use here. And here we then again want to reach out to the backend JSON file, but now instead of reading the entire file and returning all products, I want to read the file and only return one product from that file. That will be the difference. And therefore, of course, we need to know which product should be returned here. And of course, that's something we can determine by looking at the concrete value, which is in the URL. So the concrete value for this PID key here. That's where this context parameter again becomes important, because I did briefly mention before that we can use this context parameter, which is exposed to us by Next.js, to get hold of the concrete param values, so the concrete values for these dynamic segments in our paths. We do get access to that by having a look at the params key in context. Now that's not a name I came up with. Instead, that is one of the properties exposed by this context object, which is given to you by Next.js. And params is an object full of key value pairs where the keys are the identifiers for the dynamic path segments. So in this case, PID, which is the only dynamic parameter of this page here. And the values are the concrete values that were entered in the URL. So here I then get my product ID by accessing params.pid PID, because that's what I picked here on the file name. Now, one quick note about extracting the params here to avoid confusion. Of course, you can also extract params through the useRouter hook inside of the component function. That's what we did before in this course. We got access to that router object with the useRouter hook, and we extracted params with router.query. Now, there is a difference between extracting params in the component function and in getStaticProps. When we extract these params in the component function, we can use them inside of the component, for example, to use that extracted ID to send a request to some backend server to fetch data from there. But that would then only happen in the browser. If you want to pre-render a page with help of getStaticProps, which we use to prepare the data for pre-rendering the page, then this happens on the server. And as I explained, getStaticProps runs before the component function runs. It needs to run before that because the component function is then executed to pre-render the page. So if you plan on preparing a page on the server or during the build process with getStaticProps, then you need to get access to the params, so to that dynamic path segment inside of getStaticProps, so that you can use the param data here to prepare the data for the component. Then we don't need to extract that dynamic segment in the component function, unless we also need it there for some reason. But for preparing the data, we then want to do that in getStaticProps. And now with that, we could reach out to our file, to the dummy backend JSON file, and try to read that product with that ID. So for this, I'll briefly copy that code from index.js, where I get access to this dummy backend JSON file. And I'll therefore also grab those imports here and add them to pid.js like this. And now that we got hold of this file, I just want to filter my data, the products in there to be precise, for a product with this ID. So here I'll then get my product by reaching out to data products and calling find there. And then we pass a function to find, which is executed on every product in that array. And we want to return true here if the ID of the product we're currently looking at in that array is equal to the product ID we got here from our parameters. And if that is equal, we know that's the product we need for this component. So then here at the end of getStaticProps, we return an object with the props key. And here I then set my loaded product, let's say, equal to the product fetched here. Now there is a loaded product props available inside of the product detail page. So here we can extract this, maybe again with object destructuring. We can get this from the props, which we should accept therefore. And then it's this loaded product from which we can read the title and the description. So here it's then loaded product.description. Now, in order to test this, we need to make sure we can go to this detail page. And there from the index.js file, I will wrap the text inside of the list item with the link component, which of course needs to be imported again from next link. So that still needs to be imported. Then I move the product title between those link tags. And then ref is set to a dynamic value, which I construct with a template literal, where I want to go to slash and then inject the product ID here. And with that, if we now save all, we got clickable links here. And if I click on a link, I get an error. getStaticPaths is required. Now, that is an expected error, and it's an important one. So let's understand what it does. But before we do that, in the next lecture, I again want to emphasize that the code here is generally correct. We use params to get access to the concrete values encoded in the URL, and we can then use that extracted data to fetch a specific piece of data and expose this to the component. So this is not wrong, and still we have this problem. So let's understand where this is coming from. So what's up with this error? Now the good thing is, this error actually tells us the solution, though of course we don't really understand why we need that solution. Well, keep in mind that currently Next.js is pre-generating all the pages, and I mentioned that it would pre-generate pages by default. It turns out this is not the case if you have a dynamic page. So where the name of the component has such square brackets, if you have a dynamic segment leading to that page. If you have that, the default behavior is not to pre-generate the page. And why is that not the default? Because keep in mind that technically for this page, we won't just have one page, but multiple pages. For different IDs, we have technically different pages, which have kind of the same frame and the same general HTML content, but different data. This page can be loaded for /p1/p2/p1000. So Next.js doesn't know in advance how many pages it needs to pre-generate for this dynamic page. It doesn't know which values for PID will eventually be supported. And because it doesn't know that, dynamic pages like this are not pre-generated by default. Instead, they are always generated just in time on the server, which is why it worked before. But it's now not working anymore because we added getStaticProps. And as I mentioned, when you add this function to a page component file, then you tell Next.js that you want to pre-render this page in advance. For index.js, that didn't make a difference. There it was the default anyways. But for this dynamic page, it does make a difference because there it was not the default. For the reasons mentioned, Next.js has no chance of knowing how many pages you need and which concrete values of this dynamic segment you need. That's why for such dynamic routes, we need to give Next.js more information. We can also tell Next.js which paths, so which instances of a dynamic page should be pre-generated. Because here we don't just need data, we also need to let Next.js know which ID values, which dynamic segment values will be available, and for which values a page should be pre-generated, so that multiple instances of that page blueprint can be pre-generated by Next.js. And we do inform Next.js about this with another function we can add on the page. So another function we can add in this page file. And that's the getStaticPaths function, which also is async, so where you can also use the await keyword. And just as getStaticProps, that's a function which you can add to your page component files and only there, so not in any other component files. And you need to export it to make Next.js aware of it. And now let's explore how this function works and how we use it. So let's solve this error with the getStaticPaths function. For this, in our PID.js file, I simply export another function, another async function called getStaticPaths. And just like getStaticProps, you must make sure that you have no typo in there because Next.js will look for this function specifically. Now, the goal of this function is to tell Next.js which instances of this dynamic page should be generated. Therefore, this should return an object, just as getStaticProps does, but an object with different kinds of values. An object where you have a paths key. And that's now an array full of objects. So that is a given structure which you must return here. Now, in this object, you must add a params key now, and that holds another object where you have a bunch of key value pairs, where the keys are all the different dynamic segment identifiers that might lead to this page. If that would be nested deeper in a folder where the folder name is also dynamic, you could have multiple identifiers. Here it's only one, so PID. And the values are then the concrete values for which this page should be generated. So here, for example, we know that we want to generate this page 3 times for P1, P2, and P3 as values for this dynamic page identifier here. And therefore, I'll set PID here to P1. And then I will repeat that. So now we just create another object where params is set to another object with PID P2. And we now repeat this a third time here. So another object where params is then set to P3, like this. Now this tells Next.js that this dynamic page here should be pre-generated 3 times with these 3 values as a value for this dynamic segment identifier. And then Next.js will call getStaticProps 3 times for these different IDs, and we then can extract that ID like this inside of this function. Now for this to work, we also need to add another key next to paths, and that's the fallback key, which for the moment should be set to false. I'll come back to that later. For the moment, set it to false, and then if you save everything, you will see that if you load localhost 3000/p2, for example, you have the product2 page. If I go back to the starting page and I click on product3, I have product3 data here. And now that is displayed correctly and successfully because it was pre-generated successfully by Next.js. And therefore getStaticPaths is required to tell Next.js which concrete instances of this dynamic page must be pre-generated. Now, before we dig deeper, I again want to show this pre-rendering of multiple instances of this page in action. And for this, again, we can run this npm run build command here to build this for production. So npm run build. And what this will do is it will create an optimized production build again, pre-rendering all the pages it needs to pre-render. And we see what it did here again. We see that it pre-rendered a couple of pages. It generated 5 pages in the end here. We see that for the starting page, for /nothing, so for this index.js file, it recognized this 10 seconds revalidation period. And we see that for this dynamic page here, it generated 3 instances for p1, p2, p3, which makes a lot of sense because these are the param values I'm returning here in getStaticPaths. It also pre-generated the 404 page just as it did before already. Now we can also see this if we dive into the next folder again, into server pages. Here we see the HTML files for those different parameters. We also see the JSON files for preloading that data if we would navigate to such a page through a link. So after we already are on the page, not for the initial page load. And if we have a look at those HTML files, in there, of course, ultimately somewhere we will see our product1 text. Here it is. So we see that here as well. Now I can also show you that pre-fetching of data though, because in index.js we do render some links. So now if I do run npm start here, if I do that to start that production server on our local machine with that build project, if I reload, we got these clickable links. And if you now open the developer tools here and go to the network tab, if I now reload localhost 3000, you'll see something interesting. You see here are requests to p1 JSON, p2 JSON, and p3 JSON. And if you click on them, you see what was fetched. And in the end here, it pre-fetched the props for the page that would need to be loaded if you click on one of these links. So in the end here, it pre-fetched that data, even before I hovered over the links, just because I'm on this page. Now, the exact point of time when data is pre-fetched, that's something figured out and done by Next.js. The important part for us here is that it does that pre-fetching for us. Now, when we now click on a link, we're not sending a new request to the server and load the pre-rendered HTML file. Instead, we stay in this single page application now. We stay here in this React application, which was loaded and hydrated after this initial request. So in the end, now JavaScript will render a new page for us, just as it would do in a regular React app without Next.js. But the data needed for this page is coming from that pre-fetched JSON file, which it loaded and read under the hood on our behalf. So that it doesn't need to fetch the data after we navigated to that page, but so that the data is already there when we do navigate, to show this final product1 page even faster. And that's another neat feature built into Next.js, which we get for free, so to say. Now let's again explore this fallback key here in greater detail. So what's up with this fallback key here? The fallback key can help you if you have a lot of pages that would need to be pre-generated. Here I only have 3 dummy products, and I'm currently not even fetching that data from that file. We'll do that later, but we only have 3 products. Now imagine that you have like an Amazon-like website with millions of products. Of course, pre-generating all those products like this might not be optimal. Not just because I hard-coded this here. We could fetch this dynamically from this file, so that's not the problem, but simply because pre-generating all those millions of pages might take super long. And there might be products, let's say you're not Amazon, which are rarely visited. If you're building a blog and you have hundreds of articles, you might have some articles which are basically never read. So then pre-generating such rarely visited pages is a waste of time and resources. That's where fallback becomes important. Here, we can set this to true, and then, for example, we could decide to only pre-render some pages. So let's say we want to pre-render the page with product ID 1, so with P1, because that's a highly frequented page, it's visited very often, but we don't want to pre-generate the other two pages. With fallback set to true, that's possible. Because now if I save this, you will notice that if I go back to the starting page, if I click on product 3, we still load this page successfully, even though it was not added here to paths. And the reason for that is that with fallback true, we tell Next.js that even pages which are not listed here, so even parameter values for the PID parameter which are not listed here, can be valid values that should be loaded when they are visited. But they're not pre-generated, instead they're generated just in time when a request reaches the server. And that allows us to pre-generate highly visited pages and postpone the generation to less frequented pages to the server, so that they are only pre-generated when they're needed. So that can be a very useful behavior. But you'll notice a problem here. If I don't click on a link here, but instead I directly enter this in the URL and therefore send a new request to this page, we actually get an error, cannot read property title of undefined. The reason for that is that this pre-generation, this dynamic pre-generation when it's needed, does not finish instantly. So therefore, instead, when using this fallback feature, you should be prepared to return a fallback state in your component. For example, by simply checking if loaded product is maybe not a thing with if not, and then returning something like loading here. And if you do this and you add this to your component function and you save everything, if you now reload this page, you see loading briefly, and then Next.js will automatically give you that data once it's done loading. So this is a little bit like the standard React solution with useEffect and setState, except for that you don't need to do any of that. You just get something through props, you check if it's there yet, and if it's not, you show that fallback content. And once it's there, Next.js will automatically update this component page for you and then return the regular content here. So with that, you see that now I can also reload this page and we still load this successfully eventually because of that fallback feature. An alternative would be that you don't set fallback to true or false, but to a string with a value of blocking. If you do that, then you don't even need that fallback check here in the component, and hence we can comment this out, because then Next.js will actually wait for this page to fully be pre-generated on the server before it serves that. So then it will take a little bit longer for the visitor of the page to get a response, but the response which is sent back will be finished. So if I now reload, that still works, it just takes a bit longer. And again, it's up to you which approach you need for your application. Sometimes it's important to show something quickly, especially if you know that generating the page and fetching the data might take a bit longer. Sometimes it's worth to wait for it and you don't want to show an incomplete page to your visitors. In such a case, blocking can be better. Here you saw both, and as you see, both is super easy to use. So now we learned about getStaticPaths. At the moment, the way we use it is still a bit unrealistic though, because I hard-coded my PID values here into this function, and in reality, we would be fetching this kind of information from a database or a file as well. So therefore, in reality, we would basically just repeat this code here, and hence I'll grab that code and just outsource it into a separate function, async function called getData, where I then return data. And since it's async, we can use await in there. And then we can just get our data here by calling getData and awaiting this here in getStaticProps. And we can do the same in getStaticPaths. So a little bit of refactoring to have no code duplication. With that, we get the data. And now here in getStaticPaths, we want to use the data to read all the IDs we want to support. So for this, we could get our IDs array here by going through all the data pieces. Now the data we get back here, by the way, will already be parsed JSON since we do that in getData. So it will be a JavaScript object. So here IDs then should be an array. And in dummy backend, we have this products array. So in the end, what we want to do is we want to access data.products and then just map this array of complete product objects into an array of just product IDs. Just like this, for example. Just extracting the ID for every product and then having such an IDs array here. And then we need to translate this IDs array into an array of such objects. So here we could then create another object, params, which is another array. But we create this array by going through the IDs and mapping these IDs such that every ID is mapped into an object. And we need to wrap this in extra brackets here, extra parentheses, so that this is not considered as the function body, but that we instead inline return a new object for every ID, an object with a params key, which then holds another object with a PID key, which has this ID as a value. And that's then repeated for every ID, so we end up with an array full of such objects which have exactly that structure we need down there, so that we can set paths equal to params here. Or we name this paths with params maybe. Whoops, paths with params, just like this. And of course we could perform these two operations in one single step as well. I'm just using 2 steps here to hopefully make this a bit easier to understand. And with that, if I now save this, it still works as before. Everything still works as before. Now also all the pages are pre-generated again, by the way, because I am going through all the products here. So now we can also set fallback to false again, because we are loading all possible IDs anyways. And that's of course a bit more realistic here, because typically you would not pre-hardcode all supported values here. Typically you don't know all dynamic values in advance as a developer, but instead you would fetch them from the same data source as the actual data is then fetched from later. So now that we understand this concept of having a fallback and of generating certain pages for certain IDs, let's take another look at the not found case that we're trying to request a page which doesn't exist. And let's start by simply visiting a page with a product ID of P4. Now we get a 404 error page here, so a not found page, because in our data we only have the IDs P1, P2, and P3. There is no product with an ID of P4. Now we get this not found error because in getStaticPaths we load and build our array of IDs, our array of routes or of parameters for which pages should be generated from that dummy backend JSON file. So paths with params here in the end is an array where we only configure param pairs, so PID value pairs, for the values P1, P2, P3, since these are the only IDs that exist in that dummy backend JSON file. And automatically, if we then try to load this page for an ID which was not pre-generated, we do get this 404 error. Now that makes sense. What if we use fallback true though? What if we, for example, assume that the products stored in dummy backend.json might not be all the products for which we are able to fetch data? So we only generate pages for the 3 product IDs we find in that file, because we go through that file here in getStaticPaths. But by setting fallback to true, we then also tell Next.js that even if an ID value is not found here, we still might be able to render a page. That's what the idea behind fallback is, that we don't have to predefine all possible pages, all possible values for the dynamic segment. So therefore, now if I set fallback to true here, we will see that if I visit P4, I get this error that we cannot read the property title of undefined. Now we saw that before in the course already. We get this because we need to have this fallback scenario here that we're still waiting for a product. Because when we set fallback to true and not to blocking, then Next.js will instantly return a page which does not yet have the data, and it will load the data in the background and give it to us on the page and re-render the page once the data is there. So we need to render this fallback for the time we're waiting for the product to load. But if I now do that and I reload, we see a loading here, but then after a while we get another error, failed to load static props. And this hopefully also makes sense. I'm trying to load this product page for an ID of P4, for which we just don't have any data. Because in getStaticProps, we are also reaching out to dummy backend JSON, and we're trying to find our product by ID in that file. And we won't find a product with ID P4 in that file. So we see loading initially as a fallback, but then Next.js tries to load the actual data for this page, and it just fails there because we don't have such a product. So that's why we get this error eventually here then, because it failed to load the actual data. Now that is a perfect example for setting the NotFound property on the object we return in getStaticProps. Here, when we try to get our product, we also want to check if we don't have a product. And if we don't have a product, so if we failed to find a product for the given ID, then we want to return an object where NotFound is set to true. By setting this, we are able to use fallback true and try to find a product for a parameter value which was not predefined here, because maybe we do have that. Maybe dummy backend JSON is a more dynamic data source which could yield that product. But if we then still fail to fetch it, we don't want to return the regular page with the missing data, which causes an error, but we then want to show the not found, the 404 error page instead. So with that, if we save this, now you see for P4, I get loading and then the 404 page. And for P3, on the other hand, it still works as before. So that's how we can then utilize the not found property here in getStaticProps together with fallback true. And of course, it's up to you which combination makes the most sense for your exact scenario and use case. This is just one example and one other idea of using Next.js and its features. So now we had a look at getStaticProps and getStaticPaths. And these two are working together. You don't always need both. In the case of Index.js, we only needed getStaticProps. But for dynamic pages that should be pre-generated, you do need both. Now, you might recall that earlier in this module, at the beginning of this course section, I showed you this slide and I referred to two forms of pre-rendering: static generation and server-side rendering. Now, what we had a look at thus far, that's static generation, because we statically pre-generate pages. Even though it's not fully static because of incremental static generation, which I also explained, but generally pages are pre-generated. And that is really important. Inside of getStaticProps and also inside of getStaticPaths, we don't have access to the actual request which is incoming, because these functions are not called for the actual request, at least not only. With incremental static generation, they are also called for incoming requests, at least sometimes if they need to be revalidated, but they are generally called when your project is built. So inside of getStaticProps, you don't have access to the actual incoming request. Now, very often, you also don't need access. For example, here, in the examples I showed you thus far, we don't need access to the actual request which is reaching the server. But sometimes static generation is not enough, and instead you need real server-side rendering, which means that you do need to pre-render a page for every incoming request. So not at most every second, but really for every incoming request, and or you need access to the concrete request object that is reaching the server, because, for example, you need to extract cookies. And that is something we're also going to see later in the course when we talk about authentication, but I already want to introduce you to real server-side rendering here. The idea is simple. Next.js also supports this run real server-side code use case, which means it gives you a function which you can add to your page component files, which is then really executed whenever a request for this page reaches the server. So that's then not pre-generated in advance during build time or every couple of seconds, but it's really code that runs on the server only, so only after you deployed it, and which is then re-executed for every incoming request. And that code is added to a function called getServerSideProps. Just like getStaticProps, it's an async function, it needs to be called exactly like this, and it needs to be exported, and you can only add it to your page component files. But then if you do have such a function in a page component file, Next.js will execute that function, and it will execute it whenever a request for this page is made. And therefore, you should only use either getStaticProps, what we saw thus far, or getServerSide props, because they kind of clash. They fulfill the same purpose. They get props for the component so that Next.js is then able to render that component, but they run at different points of time. So let's say we have a dummy user profile JS file here in the pages folder. So a user profile page, for which I'll add a component here, the user profile page component. And in here, we want to get some user-specific data and show that on the screen. So of course, we export it like this, but now that's a page which we can't pre-render because we need to know for which user we are rendering this. Now we could expect a user ID as part of the URL, so we could make this kind of dynamic and expect the user ID instead, but then everyone who enters this ID in the browser is able to see some data for that given user ID. So that's not what I want here. Instead, we want to identify the user making the request, let's say with help of a cookie which we set before. Now at the moment we don't have that here. We didn't add any authentication, we're not placing any cookies on the user's machine, and therefore we don't really have the use case here. But it hopefully is a scenario that's easy to imagine. And later in the course we'll dive into authentication and we'll then have this actual scenario. So therefore here we want to return some user-specific data, let's say the username, but again, we need to get access to the request object, which carries the cookies and the headers to find out which user sent this request. That would be a typical use case for getServerSide props. We can't pre-render this page because we don't know which users will have in advance, and we don't get access to their cookies in advance. Therefore, we want to export an async function here, an async function called getServerSide props. Now we get a context object here, at which we'll take a closer look in a second, and we also need to return an object here, and the object which we return actually needs to have the same format as it does in getStaticProps. So that return object does not change. It should have a props key, it can have a not found key, and it can have a redirect key. The only difference is the revalidate key. That is not required here, and that can't be set here because getServerSide props per definition runs for every incoming request. So there's no need to revalidate after a certain amount of seconds because it will always run again. So therefore we return an object with props, which makes sense, I guess, since it's called getServerSide props. And these props will then be made available to this function, which will still be called by Next.js. But as mentioned before, it will not be called in advance when we build the project, but really for every incoming request. So here we could then have a username prop, which I for the moment hardcode to max. And then here we output props.username in the component function. And if we do all of that, and we then visit a /user profile page, so this page which we just added, we see max here at the moment. So that works, and that proves that getServerSide props works because that's where the value max is coming from. But the important thing now really is that this only executes on the server after deployment, and also on our development server here, but it's not statically pre-generated. And that has a couple of important implications. So which implications does getServerSide props running on the server only have for us? The implications can be found in this context object. Unlike context in getStaticProps, we don't just have access to the params and a couple of other less important fields. Instead, we get access to the full request object as well. And also to the response which will be sent back, so that we could even manipulate this and add extra headers if we wanted to. To be precise, we do get a couple of values, a couple of keys in this context object, and we do get access still to the params. That does not change. If we have this on a dynamic page, which we don't have here, but if this would be on a dynamic page, we still would get access to params. But in addition, as mentioned, we also get access to the request object and the response object. Now, if you know a bit of Node.js and especially of Express.js, this might look familiar to you. There you also can write server-side code where you get a request object and a response object, and you can then manipulate the response object as needed to send back an appropriate response. Now you don't need to worry about sending back a response here. Next.js will do that for you. It will be the rendered component. But you can manipulate the response before it's sent back by adding extra headers, for example, by adding a cookie, for example. In addition, you can also dive into the request object that reached the server, and you can read incoming data from there. For example, headers that were attached to the request, and therefore cookie data that was attached to the request. Request and response, the objects you're getting here are the official Node.js default incoming message and response objects. So here I will briefly log the request and then also log the response so that we can get a closer look at them. If I save this and I reload user profile, now this code executed again, and now we see a long log here because these are quite complex objects with a lot of built-in methods and properties. So you see there's a lot in there, and you definitely don't need to go through all of that. But for example, you see that there are headers in there, which we could extract if we wanted to. Now we don't need this here, but it will become more important later once we talk about authentication. Now I will quit this here and not go through all of that, but you can definitely take a close look at that. And these again are the default Node objects for incoming messages and for responses. And I'll link the documentation of these objects to this lecture, so that you can take a closer look at what's in them in the official docs as well. And getting access to this kind of data can sometimes be important if you, again, for example, need special header or cookie data. Another reason, as mentioned before, for using get server-side props could be that you don't need request or response specific data, that you don't need to work with request or response, but that you really want to ensure that this function runs for every incoming request, so that it's never statically pre-generated. Because, for example, you have highly dynamic data, which changes multiple times every second, and therefore you know that any old page you would be serving would already be outdated. That could be another reason for using get server-side props. But as you see, using it is simple. You can still write any server-side code in there. You can still reach out to the dummy backend JSON file as we did it before, for example, and you still return the props for the component function in the end. The only key difference is the kind of data you get access to in the context and the timing of this function. Now, get server-side props can sometimes be useful. I also want to mention how you would use it with a dynamic page. Here, before, when we used get static props, we also needed get static paths to let Next.js know which instances of this page should be pre-generated. Now, when using get server-side props, that's not the case. If I do have a UID.js file, UID in square brackets, so that I have a dynamic page for a single user, for different user IDs. If we use get server-side props, we don't need and we can't use get static paths. So here, if I have the user ID page, and I get some props here, and here I then simply return h1 tag where I output props ID, something like this, and we then export this. If we do all of that, and I then also have this async get server-side props function, which we export. If we have this, then you will see that we don't need get static paths at all. Here I just return an object, and now I'm interested in the concrete param value which I'm getting here. So we can get access to that through context. From there, we can still extract params, as I mentioned. And from params, we can then still get our user ID by accessing UID, since that's the identifier I picked between square brackets. And then in the props, which we pass to the component function, we could have the ID prop, since I'm accessing that here, and set this equal to user ID dash, and then let's say the user ID we extracted from the URL. Just to have some dummy code here that proves that this code actually did execute before this component function code ran. With that, if we want to test this, we first of all need to make sure we get rid of pid.js, because otherwise we have two dynamic segment pages on the same level in our pages folder. So Next.js wouldn't know if a value after / nothing should be a product ID or a user ID. And therefore, if I move the pid file into the products folder here, and in index.js, I update my links to go to /products/someid. Now we resolved this clash. because now we know that if it's just slash something unrecognized, it will always target this user ID route. And now with that, if I bring back that development server, if we visit, let's say, slash U1 for user 1, we see user ID U1 here. So it worked. And it did work without us adding getStaticPaths. Why? Because this runs on the server only anyways. So Next.js does not pre-generate any pages at all, and therefore, of course, it also doesn't need to know which pages to pre-generate, because there is no pre-generation. So unlike in the other case with getStaticProps, where we do pre-generate pages, and where we therefore do need to tell Next.js for which parent values pages should be pre-generated, with getServerSideProps, that's simply not an issue because we run that server-side code for every request anyways. So there's no pre-generation and therefore no need to define those dynamic paths in advance. I hope that makes sense. Now before, I also always had a look at the production build to really show you what Next.js does under the hood, and I want to do the same here for getServerSideProps. So for this, I will add a console log statement here, where I log server-side code, so that we see when this function runs. And now if we save that file, and we again run npm run build to build this for production, we'll see when that code gets executed. Now here, if I make this a bit bigger, we see that we again pre-generated a couple of pages, and importantly, it's the same number of pages as we generated before. It's still the starting page, /nothing, with the revalidation recognized. It's then the 404 page, and it's then the product pages for P1, P2, P3, and so on. Now, the user profile page was not pre-generated, as is in the end signaled by this lambda symbol here. The UID file also wasn't pre-generated. So this lambda symbol here shows you that these pages are not pre-generated, but instead will be pre-rendered on the server only. And that makes sense because in user profile, we're using getServerSideProps, and in UID, we're using getServerSideProps. That's why those pages are not pre-generated. So now with that, if we again start our server with npm start here, if we load localhost 3000, we're on this page here. But if I now visit the user-profile page here, and we see Max, if we go back to that terminal where I started this production server with npm start, we see server-side code being logged here. So this output here. We see that log here, and that proves that this code now executed, but as shown before, that this page was not pre-generated. With that, I'm going to get rid of that console log statement, but I hope it's crystal clear when which code runs now. And that is it for getServerSideProps and getStaticProps, and also for getStaticPaths. I hope the differences are clear, especially between static pre-generation and server-side code that only runs there. I hope it's also clear why we use that, simply so that we can prepare data for our component ahead of time or on the server so that we can serve a finished page to the client that can offer a better user experience to our users, since they get the finished page and all the content is there right from the start, but it can also help us with search engines, since search engine crawlers also see the finished page. And with that, there's only one thing left, which I also want to take a look at in this module, and that's client-side data fetching, what that is, and when we still might need that. Now that we learned a lot about page pre-rendering and data pre-fetching in various ways, I want to conclude this course section by having another look at client-side data fetching. So basically the opposite of what we did thus far, where we talked about fetching and preparing data on the server or during the build process. When building Next.js applications, you will sometimes have data which just doesn't need to be pre-rendered or which can't be pre-rendered. Examples would be data that changes with high frequency. So for example, if you have stock data which you show on some page and that data changes multiple times every second, pre-fetching and pre-rendering might not make too much sense because you will always see outdated data when you visit this page. So in such a case, just showing a loading spinner when you visit the page and then fetching the very latest data for you and maybe updating that data in the background then might be the best user experience. Another example would be highly user-specific data. For example, the last orders in an online shop. If you are in your account, in your user profile, and you view that data, that could be an example where we don't really need to pre-render the page. Definitely not for search engines, because they won't see your private profile, and also not necessarily for the user experience, because if we go to this page, we might be more than fine with just waiting a second for the data to be loaded on the client. And having a quicker navigation to the page might be more important than having the data available right from the start. Or consider the case that you have partial data. So let's say you have like a dashboard page with lots of different pieces of data, lots of different kinds of data. In such a case, loading all these different pieces which make up the overall dashboard might just slow down the request if you do that on the server. And pre-rendering it statically during build time might also not make sense because it's personal data or because it's changing a lot. So in such a scenario, it would again probably make sense to fetch that data on the client, so from inside the regular React app once a user navigated to that page. And these are just some examples, but there can be use cases like those here where pre-fetching the data and pre-generating the page with that data might just not really work or might not make too much sense. And in such cases, it might make the most sense to use the traditional approach of writing some code in your React components, maybe with useEffect and fetch, to fetch data from some API from inside the client-side React application. So not from inside getStaticProps or getServerSideProps, but really from inside the component so that this code only runs once the code executes in the client, not on the server. And therefore that's what we're now going to take a closer look at. This here is basically an example I showed you earlier in this module already. This is a standard React app not using Next.js at all, which uses a very traditional approach of sending a request inside of useEffect once this component is rendered, setting some loading state, and then displaying some data down there. Again, that's a very standard React-ish way, and of course there are ways of changing that, of handling errors, of using custom hooks and a lot of other things, but this is the most basic form of sending a request from inside React on the client side. And in the end, that's kind of what we now want to build again with Next.js here. Now for this, I'll add a new page here, a new route therefore, and I'll name it last-sales.js. Of course, this will just be a dummy page here. This overall project is just a dummy project. We're going to have a more realistic example in the next course section when we apply this to our events project again. But in this dummy file here, in this dummy page, I want to show you how we could implement client-side data fetching with Next.js. And of course, it starts with defining our page component here. And of course, we also want to export that component so that it can be found. Now in here, in that component, we want to return some JSX code, let's say some sales data, which should be rendered as a list, but we want to fetch that data from inside this component function as well. We don't want to add getStaticProps or getServerSideProps here because that's exactly not our goal here. We don't want to pre-fetch the data on the server or during the build time. Instead here, we can now write useEffect, so use the useEffect hook, which we import from React therefore. And then in there, in this effect function, we can execute some code which sends a HTTP request. And for a useEffect, we also need to add this dependencies array, listing all the dependencies of this useEffect function. And in this case, this function won't have any dependencies since I won't use any other component-specific data here. So now in here, we can use the built-in fetch API, which is available in the browser. And as a side note, which could also be used in getStaticProps or getServerSideProps, it is available there as well. We don't need it there right now, but you could use it there as well. But here we use it on the client side inside of useEffect to send a request to some API, to some web server. Now to test this, we need some dummy backend, we need some web server, and I will use Firebase for that. It sounds like it's just a database, but actually Firebase is a service offered by Google, which gives you an entire backend with a lot of different features, but one of the features is a database with an attached API, which we can use as a dummy backend here. So we're not going to build anything complex with Firebase, we're just going to use it as a dummy backend. For this, you need to go to the console, and for this, you need a Google account with which you should log in. And once you did log in, you can add a new Firebase project, and I'll just name it Next.js course, but you can of course pick any name you want. Click continue. You can disable Google Analytics, we don't need that, and create that project. Again, Firebase is a service totally detached from Next.js, which is actually made up of a lot of different services and tools and utilities, which you can use to build powerful backends for your application frontends. Here, I really just want to use its built-in database with a connected API. And that will be the real-time database which I want to use. So here I'll click on real-time database on the left, and there we then can click on create database. Now you can leave the default here, click on next, and on security rules, you want to start in test mode actually, which ensures that we do have access to the database from outside. Now this will create such a database for you. The great thing is that it will be a database into which we can look into here, and we also get an API here to which we can send requests, which will then automatically be translated into database operations by Firebase. So we send regular HTTP requests to this API here, and then automatically data gets written, deleted, whatever we want to do here in Firebase. Now here I actually want to prepare some data though, so that we have some data we can fetch with our Next.js code here. Therefore, we can click on the plus here when we hover over this database name, and then add any key of your choice. I'll go with sales here, and then click on the plus here. And now we basically created a sales node, a sales table kind of, and we can now add different pieces of information that belong to a single sale. For example, here we could name this first sale, which we want to add S1, and click on the plus again, and now add the data that belongs to that sale. Like for example, the username, which could be Max. Click on add now, and then click on the plus next to S1 again, and also add a volume of, let's say 100. And now let's click on the plus next to sales again, add a sale with the name of S2, and click on this plus, and here add a username of manual, and then click on the plus next to S2, and add a volume of 50. Click on add, and now we added 2 sales entries to this dummy database. Now I mentioned that it would be this URL which we can use to send a request to interact with that database. And that is correct. I'll copy that URL, and now here in fetch, we can use that URL, at least as a starter, and then here we want to send a request to the sales node and fetch all the sales. So here I'll then add /sales, and now in Firebase world, we also need to add .json at the end. This is not a Next.js requirement. This is really just required by this Firebase API we're using. And this will send a request to this sales node in this Firebase database. Again, we just use it as a dummy backend here. Now, fetch, this built-in browser API, this function which is built into the browser, then returns a promise. So here we can add a then block to work with the response, which we actually get back here. And on this response, we can call .json to read the data from that response. That's how this fetch API works. Again, nothing Next.js specific. This is the standard browser fetch API and how we can use it. So now with that, we're taking the response and extracting the response data. This again then returns a promise. So we can chain another then call here. And this will then give us the actual data which we parsed from the response. And it's now in here, in this function here, where we can use that data which we received. Now we might want to update the state of this component to output the data down there once we did get it. And for this, we can import the use state hook here and register a state in this component. Let's say the data state or the sales state with a set sales state updating function. And we call use state to initialize this state. And initially, let's say that's undefined because initially we have no sales. And maybe we also want a loading state, the isLoading state, so that we can show some loading fallback whilst we're waiting for that data to arrive. So here I'll then also set up this state, and initially it's false. And now in useEffect, in this function, we want to set isLoading to true here at the beginning to set this loading state to true because we are now fetching data. And once we got the data here in this second then block, we want to set sales equal to our sales data. And we'll do this in a second. And we also want to set isLoading to false here again because we're not loading anymore. Now, regarding the sales data, it is important to know that the data we'll get back from Firebase will not be an array, but it will be an object where these IDs here, S1 and S2, will be keys, which then hold the detail data as nested objects. So if we want an array, we need to transform this data. So here we can have our transformed sales, which is an array, and we build that with a for in loop by looping through all the keys in data. Because again, data will be an object where our IDs, S1 and S2, will be keys. So then for transformed sales, we push an object into this array, and that object maybe has an ID property, which has the key as a value, because again, the keys are these IDs. And then we have our username field, which is data for the given key, dynamically accessing it with the square brackets, which is standard JavaScript, .username. So now we're diving into that nested object here, accessing the username. And we want to do the same for the volume. So I'll also add a volume key here and set this equal to data for the given key dot volume. Now I'll reformat this and it looks like this. So now this is how we transform our sales from an object to an array. And then I can set these transformed sales as my new sales. And that would be a very standard React-ish way of sending such a request. We can now use it and check if we are loading here. And if we are, I return a paragraph where I say loading, let's say, or where we show some loading spinner, of course. And otherwise here in the unordered list, we can also access our sales then, our sales state, and map our sales so that every sale is mapped into a list item where the key is set to sale.id, and where we then output the sale username, then a dash maybe, and then after that the sale volume, and maybe a $sign in front of it, but that's just cosmetics. With all of that in place, we now got this client-side code. Now we can spin up our development server again to preview this. For this, I'll go to localhost last-sales, since that was the page name we added. And here I get an error, cannot read property map of undefined. And that makes a lot of sense because initially isLoading is false, and our sales state, which we try to use down there, is undefined. Now in useEffect we change the isLoading state, but the way React works is such that useEffect only executes the effect function after the whole component was evaluated and rendered for the first time. And for this first render cycle, sales therefore will be undefined and state will be false. So we'll reach that code and we'll then try to call map on something which is undefined. So therefore I'll add another check and check if not sales. So if we have no sales yet, in which case I return no data yet here as a paragraph. Now with that, if we save this with this extra check added, now if I reload, you see loading, and then you see that data eventually. And that is how we could fetch data on the client side. Now, if we inspect the page source here, then the interesting thing is that we see no data yet. And that hopefully makes sense. The page is still pre-rendered by Next.js, because I explained earlier in this module that that would be the default. A page which does not use get server-side props effectively will be pre-rendered by Next.js. The key thing here just is that the data used by this page will not be prepared by Next.js with get static props, for example. Hence, when Next.js pre-renders this page, it will not execute this effect, it will not wait for this, it will not care about that, it will just return and pre-render the very basic first version of what this component spits out. And that is no data yet, for the reasons I explained a couple of seconds ago. That is the initial state of this page, and that is what gets pre-rendered therefore. So we still have pre-rendering going on, but without the data, because we're fetching the data on the client side now with this approach. Now you can absolutely write this client-side data fetching code on your own as we did it here. There's nothing wrong with that, and you might have good reasons to do that because this of course gives you full control over the entire component state and how exactly data is being fetched. But this is also such a common pattern that you could consider creating your own custom hook to outsource this logic into it, or to use a third-party hook created by someone else. And you can look into the SWR hook. If you Google for use SWR, you will find swr.vercel.app. This is a React hook developed by the Next.js team, but you can use it in non-Next.js projects as well. In the end, this is a hook which under the hood still will send a HTTP request by default using the fetch API, which we also used, but it gives you a couple of nice built-in features like caching and automatic revalidation, retries on error, and you don't have to write all that code on your own. Instead, you can use this hook in a much simpler way. The strange name, SWR, by the way, stands for stale while revalidate, which is the name of this hook because this hook has a built-in features for caching data and revalidating data to give you the most up-to-date data without you noticing in a positive way, and so on. Now you can dive into the docs of this hook to learn all about it, because you can definitely also create a short course about this hook here, but getting started with it, thankfully, is super simple. In our project, we just need to quit the dev server and install it as a package. With npm install SWR, we install this SWR hook package into our project. Now in last sales, if we want to use it, we can import it. We can import use SWR from SWR, just like this. This imports the hook. It's the same example you see here. And now you can use this hook in your component, so not inside of useEffect, but directly in your component. All React hooks must be used directly in a component, not in some nested function. And we use it by simply executing it. Now this hook wants at least one argument, which is an identifier for the request it should send, typically the URL of that request. And it's also called an identifier because this hook will bundle multiple requests to the same URL, which are sent in a certain time frame, into one request to avoid sending dozens of small requests. Not an issue we'll have here, but nice to have in general. So we can grab our URL here as an identifier because it will then conveniently use this identifier as a URL as well. And in the simplest form, this is all we have to do. You can add a second argument, which is a fetcher function, which is a function that describes how the request should be sent. But the default is that it will use the fetch API, so if we want to stick to that default, which I do here, we don't need to change anything. Instead, we just call used SWR like this, and a request to this URL will be sent when this component is loaded. So now we can work with the data which is returned by that hook. And that will be an object, which we can destructure therefore, which contains the data that was fetched eventually and potential error information. So I'll use the exact same object destructuring here and pull out the data which we eventually get and the error which we might get. Down here in our custom code, we have no error handling, but now we can easily implement it by just using this extra piece of data which we get by the use SWR hook. So now with that, we can comment out our custom hook. We could also delete it, but I want to keep it around for reference. We can also comment out our custom states though. And now we can work with data and error. If we don't have data yet, then we know that we're loading. So here I'll check if not data. If we don't have data yet, then I return loading. If we have an error on the other hand, I want to show an error message here like failed to load. And we should move that in front of the if data check because an error is more important than the loading state. If we have an error, I want to show it. Now, if we don't have an error and we do have data, so if we make it past these two if checks, then we can output the data. Now, the problem we'll then face, however, is that, as I mentioned, the data we get back from Firebase is not in the right format. We need to transform it. Now, to work around that issue, we got two main approaches. We could define our own fetcher function. You can learn about that here in the SWR docs to basically fine-tune how exactly data will be fetched and returned. Or we again use useEffect, but now not for sending the request, but for simply transforming the data. So then here, our dependency would be the data which we get, because I want to rerun this whenever we got new data. And in useEffect, I want to check if we do have data, because if we don't have data, there's nothing we need to do. But if I do have data, then I want to go through these transformation steps here. So I'll copy this code from down there, comment this in, and then bring back my sales state here so that I can set this state after we transformed the data here in useEffect. So here, instead of this if check, still, instead of useEffect, I'll then set my sales to the transformed sales, which are now based on the data key we're getting from use SWR. So now we have our own transformation logic here, which will be kicked off as soon as data was fetched. And that means that now again down there, we can check that even if we have data, it might not have been transformed yet. So if we don't have sales yet, which is our transformed data, I still return a paragraph where I also say loading, for example. And of course, therefore, we can merge this and say if we don't have data or we don't have sales, I want to return loading. But if we do have both, then we can safely again output our sales. And that's how we can now use SWR and still apply our own transformation logic. With all of that, if we now save this and restart the development server, we should again have a working page. If we go back to last sales and reload, we see loading, and eventually we see the data. And still, if I view the page source, we don't see the data there, but instead we now see loading. We see loading here because that is the starting state, the first initial version of this component which is being rendered. Because initially error is undefined, so we don't return this, and data and sales are undefined, so we do return this. And therefore that's what we see as part of the pre-rendered page. And again, data fetching only happens on the client side. Now using this hook, this use SWR hook, is not mandatory. As you saw, you can write your own logic, you don't need to use it. It just can be convenient to use this hook because you save a little bit of code, especially if you also would add error handling down there. And this hook also has a bunch of other nice features which we're not using here, but which can also be very handy, like automatically refetching data when you lose and regain focus and other things like this. So that's something you can also look into, but for the moment, that's all I wanted to show here, because now we also know how we can implement client-side data fetching. Now, as a little bonus, at the end of this course section, I want to combine client-side data fetching with server-side pre-rendering. Not because we need it here, but because it can be a pattern which you do need in other kinds of applications, where you want to pre-render a basic snapshot and then still fetch the latest data from the client, and therefore that is a pattern you should also know. And I'll stick to the last sales page. Here we are already fetching data on the client, now I just want to prepare some data on the server or during the build process as well. And therefore we can add one of the two main functions we learned about, get static props or get server-side props. And I'll go for get static props to pre-generate that during the build process and possibly revalidate it after deployment with the revalidate key. So for this we export the async function get static props here, where we get a context, which we don't need here though, so I will omit it. And then in there I want to also fetch the same data which I'm fetching here on the client side. Now for this we now can't use the use SWR hook, because this is not a React component down there. Get static props is not a React component function, and therefore we can't use hooks in there. We'll have to write ordinary fetch code instead. So I will grab this code here from the commented out useEffect function, where we did fetch manually, and I'll copy that into get static props and comment it back in. Now get rid of the code where we set some state, we don't need that here, and we're almost good. Now we're using fetch here, and as I briefly mentioned before, you can use fetch here in get static props and get server-side props as well. Next.js ensures that this also is available in this context, so on the server side. And then we just use it as we did above. We parse the response, transform the data, and now then, once we're done transforming the data, here, after this for loop, what now? Well, now you should keep in mind that the function you have here, getStaticProps, is an async function, so it wants a promise in the end. And we do have a promise here. So all I want to do here in this second then block is return my object, which eventually should be returned by getStaticProps. I will return an object with a props key, where in there I have an object with a key of sales, which holds my transformed sales. And here we could then also add the revalidate key and set this to 10 seconds, for example, if we want to. So that, as you learned, this is executed again every 10 seconds, or at most once every 10 seconds after deployment. And now we just also need to return the overall promise chain by adding a return statement here in front of fetch, so that the overall promise with all its step and the final data here is returned by getStaticProps. Alternatively, we could of course also use the await keyword here. Then in the end, we just would have written response equals await fetch, Then here we would write const data equals await response JSON and remove this semicolon here, remove this then block here like this. And now we would be back to the code you recognized from before. So that is how we could write this with async await. Both works, there is no better or worse alternative, it's just different syntax for the exactly same operation. So now we return our data as part of the props, and therefore now here in the last sales page, we of course should accept props again and do something with those sales we receive. The question now just is, what should we do with them? And I would say here, it makes by far the most sense to use the props we get here, the pre-fetched and pre-rendered sales, as our initial state. So the initial state for the sales state is props.sales. Those pre-rendered sales from the server or from the build process, these are the sales which are used for the initial state here. They then can and will be overwritten by the result of the client-side data fetching. But initially we use the sales which we get from getStaticProps as our state for the sales state here. And that means that now initially, this here will not return loading because sales will not be undefined. However, we should change this from an OR to an AND operator. If we don't have data and we don't have sales, then I want to show loading. But now we do have sales because we pre-populate them. We initialize our state with the pre-fetched data from getStaticProps. So now we'll make it past this if check and render our initial sales here. So that's now what will be pre-rendered. And still, when this component then runs in the client, it will fetch again to fetch the latest sales. So if I save this here and I reload this page, now we see what we saw before, but if we view the page source, we see now that our sales data here is part of that pre-rendered page. And that's a difference compared to before. Now, if we reload again, and the data would have changed between the point of time it was pre-rendered and prepared, and we visited this page, if the data would have changed here, then we would see the updated data here, since it is fetched in the client, but not here in the page source. Now that's hard to simulate here in development, since this will always trigger getStaticProps for every visit, but it's easier to show if I build this for production and I remove revalidate, so that this is not revalidated after running it in production, because that again will make it hard to kind of catch this page in an outdated state. So if I disable revalidate here, and I now run npm run build, so now we build a snapshot of this page once during the build process and never thereafter, then we'll see what I just said in action. So now last sales was statically pre-generated, as we can tell. And now if I run npm start to start that production server with the production ready bundle, if I reload here again, in the page source, we see our data. But if I now go to Firebase and I add a third sale here, s3, with a username of Julie, and give this a volume of 70, let's say. If we do that, and we reload last sales again, actually, we don't even need to reload because this SWR hook saw that this page got focus and it automatically refetched data. That's part of the magic this hook does. But otherwise, if we would have reloaded, it also would have fetched that data again. But in the page source of the pre-rendered page, we don't see Julie anywhere because it was not there when we pre-rendered the page, when getStaticProps ran, but it is there once we view this in the browser, because then this code runs on the client side, this component code, and the client-side data fetching kicks in. So this hopefully also is clear, and combining pre-rendering with client-side data fetching can sometimes lead to the best possible user experience because you have some data right from the start and you then update it from inside the browser. Now this was a long module with a lot of key concepts. In general, this module was about how Next.js pre-renders pages for us, so that if we view the page source, we have some data in that page source, some data which is there right from the start and which is therefore also visible to search engine crawlers, which is a key difference to standard React apps without server-side rendering. Now you did learn that out of the box, Next.js pre-renders your pages. It does that automatically. But you can also force it to do so by adding getStaticProps, because you add this function whenever you also want to prefetch data for your component. So if your page component doesn't need any data, of course you never add getStaticProps typically, because it doesn't add anything to the page then. But if your page does need data, like the list of products here, then you add getStaticProps so that during the build process, this data is pre-fetched and available for the page when it's pre-rendered, so that the pre-rendered page contains pre-fetched data. Now, since getStaticProps executes during the build process, you can execute Node.js code in there, which wouldn't run in the browser. For example, you can get access to the file system and read data from files. Now, since data can get outdated after the pages were pre-generated, you can also add the revalidate key here in the object you return from inside getStaticProps to tell Next.js that this page should be regenerated again and again even after the page was built and deployed, at most every X seconds, here at most once every 10 seconds. Therefore, getStaticProps is great for ensuring that you are pre-rendering pages with data. Now, if you have dynamic pages with a dynamic parameter, then you also need to let Next.js know how many instances of that page should be pre-rendered, because it could be an infinite amount in theory. You do that with getStaticPaths, and you need to add this when using getStaticProps on such a dynamic page. Otherwise, you'll get an error because Next.js doesn't know how many pages to prepare. GetStaticPaths returns an object with a paths key, which holds an array of param objects in the end, where you basically just make Next.js aware of all the parameter values for this dynamic page that should be used for pre-rendering a page. And you can also reach out to a file system or database or whatever you need to do here. And when you do that, Next.js will pre-generate all the paths, so all the instances of that page for the paths you tell it to pre-render. It will then call getStaticProps for every page instance that it creates. You can access the params there, as you learned, and then you can fetch and prepare the data there just as it's needed, return that to the component function, and then last but not least, Next.js will execute this component function in the build process or on the server to pre-render this page as well, with the appropriate data. Now, sometimes you don't want to pre-build during the build process, and even when using revalidate, the data might not be updated enough. Instead, you really might want to run logic for every incoming request, either because you need access to the request or because the data changes all the time. In such cases, you can use getServerSide props. It's an alternative, and unlike getStaticProps, this really runs on the server and only on the server, not during the build process. Here, you can get access to the request and response objects, to the real node request and response objects, and you still return props to the component, which is then pre-rendered, but pre-rendered on the fly on the server. You can also do that for dynamic pages, and here you don't need getStaticPaths because this now really does only execute when it's needed, not in advance. However, sometimes that's also not what you're looking for. Sometimes you really need to fetch data from inside the client, or you want to combine pre-rendering with client-side data fetching. And that's what we saw in the last lectures. You can also still write regular React code, regular React JavaScript code for fetching data in your component function. And this code will then not be executed on the server, even though the page will still be pre-rendered, but this code will be skipped, since it's inside of useEffect typically. Instead, you'll just get some snapshot of your page, which is then returned, and that code really only runs in the client, so when a visitor visits the page. Here, you can also consider using the useSWR hook, since that can make writing that code a bit easier, and since that is a feature-rich custom hook built by the Next.js team, which, for example, also automatically refetches data if you lose and regain focus in your browser tab. So that can also be nice. And as you saw, you can even still combine that with preparing and prefetching data. And therefore, this was a long module, but data fetching and pre-rendering of pages with prefetched data is another key aspect of Next.js. The file-based routing was nice and already a great feature, but this year, prefetching and pre-rendering, that's the feature which really makes Next.js super powerful. Because now it's easy to optimize pages for search engines, it's easy to show users some data right from the start, and you can still apply everything you know about React. And therefore, let's now apply what we learned here to our demo project in the next section before we then dig deeper into Next again.